Hey NEET warriors, welcome to the NCERT Line by Line series where we have changed the name of the series from 2000 questions to 3000 questions. Yes, that's right. So in just a matter of few days, we are completing thousands of questions of physics, chemistry and biology, and that too these questions are straight away from NCERT, which will help you obviously for your NEET examination. Not just that, students who are preparing for boards, this is the best way to revise the NCERT. So two birds in one stone, and this session is going to be very useful for all kinds of kids out there. So welcome aboard. Hello Krishna, we have all our regular students. Hello Surya, hello Shilpa, hello Hamsa. Welcome Kishore, welcome. Good evening Sri. Hello Sravani. And today in physics, we're going to do electromagnetic waves and alternating current. Some kids were like, sir, please mention the topic name. How do we know what is the topic which is going to be taught? So there we go. It's there on the thumbnail. So you know what these sessions are all about, right? And the older sessions are still live on the YouTube live tab. So make sure you check those recordings of those live classes, right? We have done almost 2 classes before this on YouTube, and 1 class was on the Wave platform, which I had made a video on. Even Gopika ma'am and Baswa sir had told you about it, right? So make sure you check out those videos. Make sure you are, revising through those videos, and you will be getting all these notes combined together in one single PDF very soon, okay? So my name is Captain Shreyas. You can call me Capto or Captain also, and I have been sending kids into the top-notch colleges for more than a decade now, and here I am to help you make your dream come true. Okay, so make sure you are showering your love and marking your attendance by hitting the like button down there, and also be a part of this wonderful YouTube community, which is full of students who are enthusiastic, who are very eager to crack the NEET exam, and who help each other. So be a part of this community by hitting the subscribe button down there. Yes, and everybody is excited. Definitely, very good. Niku, I will be doing it on the JE channel, dear. Don't worry, very soon. So let's get started with the first question: electromagnetic waves and AC. So these 2 chapters mainly you are going to cover in this particular session, and then after me in the same session you're going to have Diksha ma'am and Baswa sir as well as Gopika ma'am. All the subjects in the same session, so you don't have to run anywhere, you don't have to click anywhere. Just keep the session on, don't turn it off, that's all, okay? And keep making running notes. Electromagnetic waves are produced by oscillating dash and dash fields. Or warm-up question number 1, and post all your answers in the chat box. It's okay if your typing speed is not good and you're like, sir, I'm not able to type so fast. It's okay. Even if you're not able to type fast, at least think about it mentally. If you're able to type, I would love to see your answers as a chat. Very good. Yes, electric and magnetic fields. Very good. That's a warm-up question. Everybody is warmed up, and I can see the chat box is already on fire with lots of fire emojis out there. Very good. Yes, good evening, Shrivani. Yes, let's move on. Speed of light in vacuum is approximately dash meters per second, which is also the speed of all the electromagnetic waves. Light is an electromagnetic wave. Electric field and magnetic fields are, moving together in perpendicular directions, and they travel at what speed? 3 lakh kilometers per second, which is 3 into 10 to the power 8 meters per second. 3 into 10 to the power 8. This value you have to remember. This won't be given in the examination hall. Keep that in mind, right? So 3 lakh kilometers in 1 second. And you should also know approximately how much time does light take to go from sun to earth. What's the answer for that? That can also be used in some places. So you should know that data point. How much time does light take to travel from the sun to reach you on earth? Roughly, how many minutes? Yes, it is not in seconds. It is not so quick also, but it is not very slow also. Yes, roughly 8 minutes. Roughly 8 minutes. You should know this data as well. The wavelength of visible light is from which range to what range? I mean, what is the range of the wavelength for visible spectrum? When you talk about visible spectrum, that means violet, indigo, blue, right? All these colors, yellow, green, orange, red, all these colors. Come on, think about it. What are the approximately maximum and minimum wavelengths of this visible spectrum. Red being the largest wavelength, blue or violet being the smallest wavelength. It goes somewhere close to 380, 400 nanometers to 700 nanometers. That's around that. Yes, 380 nanometers or 400 is close to violet. 700 is approximately for your red color. No, sorry, for your red color, correct. 700 for red, 380 or 400 also. Many books use 400, so you can use 400 also. 380 is little bit close to 400. That's okay. You check the options and mark it. Next one. The dash voltage of a AC source is √2 times the dash voltage. Which voltage? There is a name given to different voltages, the terminologies of AC. What are the different terminologies? One is the instantaneous voltage, one is the peak voltage, one is the maximum voltage or peak, one and the same thing. RMS is there, average is there. All these are different terminologies in AC. So which is whose √2 times? Vrms is Vmax by √2. So Vmax is Vrms into √2. So the maximum voltage or the peak voltage is √2 times the RMS. Yes, don't put RMS first and peak next. No, the peak is √2 into RMS value, because RMS is Vmax divided by √2. So you shift the √2. So √2 into RMS is Vmax. Is that absolutely clear? Yes, it is √2 times. Very good, Raghavi. Yes, perfecto, perfecto, perfecto. Moving to the next one. In a AC circuit, the phase difference between the voltage and the current in a purely resistive circuit is dash degrees. In a purely resistive circuit is dash degrees. How many degrees is it? For a purely resistive circuit, the angle, phase difference between voltage and current, how much it is? Between voltage and current, they are in sync because it is resistance, they are in phase. So it will be 0 degrees, yes or no? Very good, very good. Very nice, Anvi, Suprabha, very good, Srinidhi, Krishna, Niriksha, Shivani. Awesome, Raghavi, awesome, Samaria. Great. Moving on, because they are in phase, resistance, pure resistance. Next one, the formula for the inductive reactance for an AC circuit, how much it is? XL is how much? Where F is frequency, L is, obviously L is inductance. This is straightforward. What is the formula for XL? Is it 1 by omega L or is it omega L? XL is omega L. Yes, XL is omega L. It is on the top. Think of it like this. L stands for love. Love is above all. So it is above, means in the numerator. When you talk about XC, it is not above, it is below. Below means denominator. So it is 1 by omega C. That's another way of remembering it. Omega is 2 pi F. Omega is 2 pi F. So 2 pi F into L. As simple as that. Very good. Many of you got it. It is not 1 by omega C. It is omega L. Yes, very nice. Then when you talk about capacitors reactance, what is the value? And C is what? C is obviously, now you know this, C is capacitance and XC will be 1 by omega C, where omega is 2 pi F. Omega is 2 pi F. So that will be now obvious. So 1 by 2 pi F into C. 1 by 2 pi F, which is omega, into C. Yes. Whenever L comes, love is above all. So it is on the top. C is below. So in the denominator. So you can see it is in the denominator. 1 divided by. The maximum dash field is C times the maximum dash field in a EM wave. Who is C times the other field? Which field is C? C is speed of light times the other field. Come on, come on, come on. If you remember the formula, C is E by B. Speed of light is electric field by magnetic field. Take magnetic field on the top. Electric field will be C times the magnetic field. So the maximum electric field is C multiplied by maximum magnetic field. How many of you wrote it? Oh, many of you wrote magnetic first, then electric. That is wrong. First answer is electric, next answer is magnetic. No, it is not magnetic and electric, it is electric and magnetic. If the order is wrong, you will get a -1 mark in the NEET exam. So be careful about the order also, because E by B is C. E by B is C. So E is B times of C, B multiplied by C. Okay, I hope this is clear. Everybody remember all your mistakes and don't repeat it. That's all. Why are you attending this session? So that you realize small things in NCERT, and when it comes in the NEET exam, you do not make mistakes. The distance between two consecutive crest and trough in an electromagnetic wave is, distance between two consecutive crest and trough in an electromagnetic field wave is how much? What is that distance called? See, from one crest to the next crest, the distance is lambda. From one trough to the next trough, the distance is lambda. But from one crest to another crest, in between you get a trough. So from one crest to the trough, what is the distance? Half of the wavelength. So I think it should be lambda by 2. No, many people got it wrong. It's not wavelength. Look at it carefully. Distance between the crest, where is it? Crest and the trough. Two consecutive crest and trough. It's not saying from crest to crest or trough to trough. That wording is only different. The distance between two consecutive crests, plural form. That means from one crest to other crest. Then the answer will be lambda. Did you understand how examiner will play with your mind? You will be given negative marks then. Yes, Mickey, that is the whole point. Killing two birds in one stone. Killing boards and NEET exam with this one session, right? Moving on. The rate at which energy is transferred by EM wave per unit area is measured by its. The rate at which energy is given by an electromagnetic wave per unit area is measured by. Rate means derivative with respect to time. So dE by dt, that is energy per unit time per unit area, that is joules per second per meter square, that is nothing but the intensity of the light. That is nothing but the intensity of the light. It is not the power of the light. A lot of people make a mistake over there. Okay, it is the intensity. It is the joules per second per meter square. That's the unit of intensity. It's not power, it is intensity. Keep that in mind. Phenomena of electromagnetic wave bending around obstacles. This is a common thing. Everybody will be able to answer this. I can see the spam coming up in the chat box. Yes, very good. When light bends around corners, that is because of what? Spreading of light, scattering of light, reflection of light. No, it is called diffraction phenomena. It is called as diffraction phenomena that distinguishes wave with a particle. Right? Whenever there is an obstacle, the light or any waves, they bend across that obstacle. That phenomena of bending is called diffraction. The law which tells you about the electric field in a plane wave is perpendicular to the magnetic field is called as which law? Electric field is there, magnetic field is producing it, and they are perpendicular to each other. From which law do you get it? Whose law do you get that it is, in this particular direction? Who is talking about the relation between them? Yes, very good. It's Faraday's law. Faraday's law says the rate of change of magnetic flux gives you the or it gives you the induced voltage in a loop or on in an empty space. It tells you how much voltage is being created in a particular loop, and from that you get, oh, the magnetic flux is here and this is the electric field which is created, and then oh, magnetic flux changes here, then the electric field changes in the other direction, which are mutually perpendicular to each other. So that is Faraday's law. In a transformer, the efficiency is given by the ratio of dash power to dash power. This is very simple. Forget transformer. In any case, no matter heat engine, refrigeration, transformer, any other motor, whatever. What is efficiency? Efficiency is you are giving in something, how much are you getting? So that ratio which is there. So it is the ratio which you get out of it upon what you are giving into it. Usually the output is lesser than the input. That's why it is the ratio of the output by input, not input by output. Don't make a mistake. How much you get is always less. So the efficiency is always less than 1. If you convert it into percentage, it is usually less than 100%. Next question. Dash effect is the change in the frequency of a wave in a relation to an observer moving relative to the wave source. This is a little bit debatable thing whether it can come in the NEET or not, but we should be prepared because in JEE this time they asked many borderline questions. So they were very debatable. So that's the reason why we are going to spread ourselves across the length and breadth of NCERT so that you are confident about the examination. Very good, guys. Yeah, just like in sound, there is something called as Doppler effect. I know that is deleted, but still, when you move relative to the source, you will see the wavelength frequency changes. Same way here, the Doppler effect in light tells you that if you are moving relative to some light source, the observed color will be slightly different. Okay, that is the change of the frequency. It's a Doppler effect, keep in mind. Relative motion causing changes in the color. So that's how you can see or predict whether the star is coming towards us or going away from us. If it's coming towards you, then it will look differently. If it is going away from you, the color will be different. So that's how scientists can predict if something is coming close or going away. That's called as red shift and blue shift, by the way. The phenomena where an electromagnetic wave is split into components that travel at different speeds through a medium. Well, this is a standard phenomena. It's there in internet. You can see in many books also. This is a standard phenomenon where light splits into components which are going to travel at different speeds, and that is nothing but your polarization. There are components of the light which are directional in nature, and certain directions are allowed, certain directions are not allowed, because of which you see the polarization effect occurs. Only a certain component of light is allowed in certain direction, other components get eliminated. It's not diffraction, it is polarization, and polarization is only found in transverse waves. Keep that in mind. If you have the EM spectrum which has radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and one thing is missing. Can you identify one missing thing over here? Yes, there is one thing. Dispersion is different, Deram. Dispersion is where light splits into individual colors, like white color gets split into individual things, violet, indigo, blue. That splitting of light in colors is called as dispersion. Okay, components of light getting split and a certain component moving inside the medium because of that polarizer, that is polarization. Slightly similar but also different. Yes, gamma rays, very good. And what is the use of gamma rays? What is the application? There is a beautiful table in NCERT which tells you about what is the application of gamma rays in medical sciences. Gamma rays are used for treating tumors, right? Gamma rays are used for treating tumors and many such applications that you will find of gamma rays. They are extremely dangerous if they are consumed in large quantities. They usually come from nuclear reactions. Yeah, great. The impedance of series RLC circuit at resonance. Impedance is like resistance but for the entire circuit. Resistor has resistance, inductor and capacitor has reactance. All their things combined together gives you the total resistance. You don't call it total resistance, you call it as the impedance. So when it is resonating, meaning it is in sync, it's giving maximum power, then the circuit is purely resistive because the capacitive and the inductive components cancel each other. The capacitance and the inductive components, they cancel each other, and you will see the voltage and current are in phase. Voltage and current are in phase. The phase difference is 0 degree. So it's very purely resistive. The power factor of an AC circuit in the resonance. Now this should be very simple. If you are able to answer the previous one, very good. I can see a lot of you answering all the questions correctly. Keep it up. Keep spamming the answers. I really love to see your answers. And that way you can also show off, yes sir, I know this. And even if it is wrong, good. That way you will not make that mistake. But type it out. Make that effort. Put in that effort to type it out. because that will remind you of your mistake in the actual exam. You will never forget it. That's how they say practice makes a man perfect. The power factor is always 1, yes, because in resonance the phase angle is 0, cos of 0 is 1, power factor is cos phi, so cos of 0 is 1. In a EM wave, the electric and magnetic fields are dashed to each other and the direction of wave propagation. This is very straightforward. I think everybody will be able to answer this. I can see a lot of spam. Very good. Perpendicular. Very good. Kudos to all of you. Moving on to the next one, because electric field, magnetic field is perpendicular to each other and also to the direction in which they are progressing. Unit of magnetic flux density in SI system of units is magnetic flux density. I know many of you will be thinking about something else only, and many of you are already thinking probably Weber. No, Weber is for flux. Density means Weber per meter square. Weber per meter square is a Tesla. Weber per meter square is a Tesla. So the answer is a Tesla. Okay, many people might think the answer was, Weber, right? So Weber per meter square, because Tesla meter square is a Weber. Tesla meter square is a Weber. So Tesla is Weber per meter square. Keep that in mind. Okay. Yeah, it is not Weber. AC changes direction how many times in a 60 Hertz power supply? You take a 60 Hertz. 60 Hertz. 60 Hertz means positive, negative, positive, negative. Like that, it is happening 60 times in 1 second. But in one cycle, understand, the direction changes 2 times. Once from negative to positive, then positive to negative, then again negative to positive, positive to negative. So one cycle comprises of a change which occurs 2 times. The direction of the current goes like this, then like this. That is one cycle. Once like this, then like this. So 2 times the direction is changing. So in 60 Hertz, 60 cycles, so it will change 60 into 2, which is 120 times. 120. A lot of people write it as 30 or 60, but that is definitely not correct. Very nice. Gauss, Jai Ganesh, Gauss is the unit of, again, flux density, basically magnetic field only, but that is a much smaller unit. One Gauss is 10 to the power minus 4 Tesla. So it's the unit of magnetic field or flux density only, but it's a smaller unit. Like you have ergs and joules, or dynes and newtons, same thing they represent, but in a different system of units. That's all. Moving on. The average power consumed in an AC circuit with a resistance, voltage and phase angle phi is given by, what is the formula for power? Where cos phi is what? The second part is very simple. Cos of phi, where phi is the phase angle, it is nothing but called as the power factor, I believe. And what is the formula? It is voltage into current, or V square by R. V square by R, directly you can write it, V square by R, right? There is a by here, I think that by did not come. By did not come. V square by R cos phi, right? As simple as that, everybody? Awesome, awesome, right? So you can use Vi cos phi, V square by R, right? All these things will work. Okay. When light passes from one medium to another and changes the direction, oh, we know that. When light changes the medium, it bends, that is refraction. The dash and the dash change, but the dash remains the same. What are those things which remain the same? Which things which do not remain the same? What are those things? Oh, we know that. We know that. What is it? Yes, the wavelength and the speed will change, but the frequency never changes. Frequency does not change. In fact, there are problems where question is to find what is the new wavelength in that medium, what is the new speed in that medium. Frequency never changes. Perfect. Some of you got the right answer. Yeah, very good, very good. The dash principle allows an AC generator to convert dash energy into dash energy. Which is that principle? Which is that principle which allows, think about it, which is that principle which allows, think, an AC generator. What does the AC generator do? AC generator, it takes in mechanical energy. Yes, you rotate it by some diesel engine or some water falling on it. So mechanical energy it is using and converting, it is giving you out what? Electrical energy. Which principle does it use? Obviously, the principle of your electromagnetic induction, EMI, the name of the chapter. Yes, electromagnetic induction. Yes, Anvi, yes, Rinidhi, very good. Awesome, awesome, awesome. Next, the dash current loops of electrical current induced within the conductors by changing the magnetic field in the conductor. What are those current loops called? Where electric current is there within the conductor because you are changing the magnetic field in the conductor. Those current loops, there is only one name that should come when you think about current loop, that is eddy current loop. These are very bad loops most of the times, because the eddy currents, when they are formed because you are moving a magnet close or far away, they cause loops of current and there is a loss of heat. It's unnecessary wastage of loss. Blue color has dash frequency than red color. So if you know the comparison between wavelength, you know the comparison between the frequency as well. It's very straightforward. Think about it. So when you think about blue color has dash frequency than red color, what do you think? Blue color has dash frequency than red color. Think about it. Yes, blue color is shorter in wavelength. That means the frequency is higher. Definitely. Very good, very good. If it was wavelength, then the answer will be lower. Relation between E, B, C direction wise is electric field, magnetic field, and C direction wise, not magnitude wise. Direction, only vector wise. I think electric field, magnetic field, and speed of light, they are all perpendicular. Yes. But also one relation which is holding true is electric field cross producted with magnetic field. Electric field cross product with magnetic field. Use your right hand. If electric field is here, magnetic field is here, then your thumb will point in the direction in which the light is going. So if electric field is here, magnetic field is here, then light will be going here. If electric field is here, okay, and magnetic field is here, electric field is here, magnetic field is here, then the light will be going like this. So E cross B is parallel to the direction of light. The different forms of expressing speed of light, many ways are there. You can name all the formulas that you know. So many formulas, and all these formulas are given at different places in NCERT, but I managed to collect it all in one place for all of you, and many of you know it already. Yes, all of them. If you wrote the answer as E by B, correct. E naught by B naught, correct. What is the difference? This is instantaneous value. This is maximum value. This is instant by instant. This is max by max. It's perfectly okay. Omega by K, also okay. F lambda, also okay. 1 by root mu naught epsilon naught, that is also okay. All these are correct formulas for the speed of light. So many formulas are there. You can note it down in your notes. All these are correct. I can see how many of you are giving the correct answer. Excellent. Very good, very good, very good. All these are correct. Okay, write it down in your notes in one place only. Don't put it at different places, or else you'll be like, that is different, this is different. No, they're all the same things, just writing it in different forms. For AC circuit, the power loss in terms of root mean square current and the resistance is given by the formula. If you have root mean square current and the resistance, then the formula is only one thing, that is I squared R, but that I has to be the RMS, and which is RMS. So I squared R, simple, that's it, nothing else. Simple I RMS. There is no cos phi here. A lot of people think there is cos phi. No, there is no cos phi. It's I RMS square R. I RMS square R. But if you write it in terms of voltage, then cos will come. V RMS into I RMS into cos phi. That is only with voltage. Otherwise, it does not come. The frequency of AC supply in most of the residential wiring is what is the frequency of AC? Immediately you can check out any appliances, be it fridge, AC, washing machine. It will be written over there, 220 volts 50 hertz. 220 volts 50 hertz. So that's in India, but in many countries abroad, you will see that the frequency they use over there is 60 hertz. So it is 50 or 60 depending on the country. If it is asked in India, it will be 50. But if there is an option saying it is 50 or 60 depending on the country, then you will mark that option. Is that okay? Be careful. If you buy a device from America, you will see most likely it will be 60 Hertz, 110 volts. The dash ammeter can measure AC current. Which kind of ammeter do you need to specially measure the AC current? You cannot use any ordinary ammeter. There is a special ammeter for that. Yes, you cannot use a galvanometer. That ammeter is based on the heating effect of the wire. It measures the heat and indirectly measures the current. And that is the hot wire ammeter. Yes, it's a hot wire ammeter. Is that okay, my dear warriors? Perfect, perfect. So, you know, back in the day, I remember when I was a kid, we had got a phone from, you know, US. Some of our relatives had got a nice cordless phone, and we could not use the adapter because that adapter was meant to be used at 60 Hertz, 110 volts. So it was a painful task to find an adapter which will work on the phone, which will connect for our Indian household 220 volts, 50 Hertz. But nowadays, even if you buy anything anywhere, you will see you can use it, because right now the adapters which you use are having that compatibility to work for both 50 as well as 60 Hertz, and even for 110 volts and 220 volts. So that is how they have been designed. So it is much improved. You don't have to buy a new adapter anymore. Next one, in a LC circuit, the frequency of oscillation, also known as the resonant frequency, is given by dash, where L is dash, C is dash. This is very simple. L is inductance, C is capacitance, but mainly what is this formula? What is the resonant frequency formula? Everybody put it up in the chat box. Everybody put it up in the chat box. Oh, somebody can relate with me. Vidya Venkat says, yes sir, it happened with me too. Okay. Krishna also faced some similar issues, I guess. Okay. So what is the answer? Omega is 1 over root LC, and you do the math. Omega is 2 pi f. You will see it is 1 by 2 pi root LC. 1 by 2 pi root LC. Very good, Vidya. Very good, Srinidhi. Srinidhi, 1 by root LC is omega. F, which is frequency. The frequency will be 1 by 2 pi. That 2 pi will also come. Yeah. So that 2 pi will come for frequency. If it was just omega, then the 2 pi will not come. Only 1 by root LC will come. Very nice. The phase difference between the voltage and the current through a purely LC circuit is how much? Pure LC. There is no resistance. So either it can happen that the current is here. It is more inductive, then the voltage will be here. If it is more capacitive, then the voltage will be here. So the angle between voltage and current will be 90 or even 90 like this. If it is inductive, more, then it is plus 90, else it is minus 90. Either ways, angle is 90 degrees. So there is no question of any other angle. Very good. Good evening, Deepthi. Joining in late. You missed some questions, but it's okay. There are close to 350, 70 questions more at least that are planned for today's session. So every session we try to cover as many questions as possible on YouTube. And if some questions are remaining, we give it to you in the PDF. So you're wondering where the PDF is, sir. The PDF is being made shortly, and we'll be collecting all the questions together and giving it to you. Okay, and do not forget, this Sunday there is a test. So there are some 400, I think, sorry, not 400, I think 100 questions or 200 questions which are being planned for this Sunday based out of NCERT, which you will have to give, you know, in this Sunday's test. All right. So the out of the 3000 questions, so close to, I don't remember the exact number, but there is a good amount of questions which you will be giving this Sunday. Okay, keep that in mind. Electromagnetic spectrum is classified into different types based on the wavelength order from longest wavelength to shortest wavelength. Microwaves, infrared, visible light, ultraviolet, X-rays, and what? Yes, what is the answer for this? What is the answer for this? Longest to shortest. Longest is radio. Shortest will be gamma. Yes, so longest is radio, then comes micro, then comes infrared, then visible, ultraviolet, X-rays, and then comes gamma rays. Very good. Next one. If you take a purely AC circuit, the current dash, the voltage by dash, purely capacitive. Inductor L, love is above all. Capacitor, it is below. So for a capacitor, the current is here, the voltage is below. Voltage is below. So the current, this current is always going to be ahead of the voltage. Current will be ahead of the voltage or leading the voltage by 90 degrees. It will lead by 90 degrees. Yes, leads by 90 degrees. Very good, very good, very good. Moving on. The power factor of LCR circuit where reactance is resistance. Reactance is the resistance. Interesting. X is equal to R. If X is equal to R, that means the phase angle will be 45 degrees. Cos 45 is 1 by root 2. So 1 by root 2, which is 0.707. Yes, perfect. That is the correct answer. Those of you did not get it, I'll explain this to you again. See, your resistance is equal to your reactance. That means your triangle will form like this. So this is your Z. So this will be 45 degrees because these two sides are equal. So therefore, what is cos 45? It is 1 by root 2, which is approximately 0.707, which is the power factor. This is your power factor. So it's 0.707, 1 by root 2. Okay, is that clear? Approximate value you should remember. The rate at which EM waves are reflected, absorbed, transmitted by material is described by its dash spectrum. What is that spectrum called? What is that spectrum called? Yes, the rate at which electromagnetic waves are reflected, etc. That is called as its absorption spectrum. You should know about this. This is just a theory point which you should know, that the absorption spectrum decides who is getting absorbed, who is getting reflected, who is getting transmitted, everything. That is absorption spectrum. The device which is used to change the amplitude of AC voltage without changing its frequency. No, the answer was not electromagnetic, it is called absorption. Every answer won't be electromagnetic. Students are like, every answer electromagnetic. Which induction? Electromagnetic. What is your name? Electromagnetic. What is the phenomena? Electromagnetic. No, some things are different. Device used to change the amplitude. So low voltage becomes high voltage becomes low voltage without changing frequency. What is that device called? Obviously transformer. Transformer. Excellente. Very good. Keep it up. Malakodi, Saturday I am planning to take gravity. Are you up for it? Let's complete gravity. It's a sweet chapter. 100% one question. Maximum 2 questions will come and very straightforward questions will come. Let's make those 8 marks pakka in your pocket, in your kitty, in your score. 100% this Saturday. 8 marks maximum, 4 marks minimum. I'm telling it to you right now. This Saturday 5 o'clock, what say? Are you up for it? Many students were commenting also. I read your comments, no? What did you think? And some students were spreading some fake news about the channel. Yeah, some students, Super 6 has stopped. Who said that? Super 6 has not stopped. We are doing NCERT meanwhile, and Super 6 is going to continue. It's not a series which we start and it goes. No, it's not like that. Super 6 is continued. So if you see a comment like that, tell those kids, hey, no, what are you saying? NCERT is going on. No, what? Well, NCERT again, Super 6 also you want. Super 6 NCERT also you want. Understand? We also have our limitations. How many videos will you also watch? Okay, we don't want to burden you so much. But at the same time, we don't want to ignore NCERT also. That is also wrong. Okay, moving on. Electric field and magnetic field in an EM wave are related by E and B are related by this we already did. C is E by B, where C is the speed of light in vacuum or in free space. Yes, this is straightforward. E by B, C is E by B, E naught by B naught, 1 by root mu naught E naught, then even omega by K or F lambda. All those are the correct formulas. Moving on. The phenomena of electromagnetic radiation being emitted or absorbed by atoms when they transition between energy levels known as the dash emission or absorption. This is straightforward. Because of issues in the link, Fari, let me see if we can do something about it. If we can get the recording. Yes. So that's why I was, you should have tried through some other device or some other email ID. Maybe that would have helped. Yeah, the correct answer is what? Quantum emission. Quantum levels. What are those energy? Quantas. One quanta of energy goes in, one quanta of energy goes out. When electrons go from higher energy to lower energy to higher energy, emission, absorption, radiation, all these are quantum phenomena. Quantum, okay? Great. Transformer operates on the principle of, your favorite word is going to come. Your favorite word. What is your favorite word for this lecture? Anything and everything. Anything and everything. The answer is electromagnetic induction. That's it. Very good. Electromagnetic induction or even mutual induction. That will work. That will do. Yeah. Kishore will be compiling the PDF of all the subjects, all the sessions and giving it to you. So even if you had missed one of those sessions where we conducted on the Wave platform, don't worry, you'll be getting the PDF at least. Okay, that's what you want now. We'll give you the PDF as a one single, or else one PDF of physics here, one PDF of chemistry here, that session here, this session here. There is a massive, work for all of you. So we will do that hard work. We have a team which will collect all the PDFs together, will stitch it together and give it to you. Okay, happy? Let's go. But it will take some time. Let all the sessions be over, then we'll share it within the next week. Impedance in a LCR circuit at resonance is equal to the impedance in a RLC circuit. Impedance is the resistance. Yes, because inductive reactance and capacitive reactance, they cancel out each other. So what is remaining? Only resistance. So the total impedance is just the resistance, because other two things just cancelled out. The skin effect in a AC circuit causes the current to flow predominantly at the dash of the conductor. Guys, where is your skin? Where does a human, come on, your bio students, if you don't answer this no, then Gopika ma'am and Baswa sir will not teach you only. If you don't answer this, where is the skin? On the surface, no? Where are the muscles? Little bit inside. Where is the bone? Even inside. So our structure, our chassis is made of bones, then you have muscles, right? And then on the topmost layer you have the skin, yes or no? So where is the skin? On the surface. So if I say the skin effect means it's on the surface. Current is going to flow where on the conductor? Inside? No, right? It will go on the surface of the conductor. Understood? That's how you should think properly. Even if you get a bouncer question, if you are a Shreyas sir student, you will think, or else you will be like, oh, where was skin effect taught? Where is it? It's bonus. Oh, what is this? I will protest. No, don't do that. Think logically. Skin effect. Okay, what is skin effect? I don't care. But it is on the surface. That's it. Enough. Done and dusted. So you have to use little bit logic at some places. Alternating current is converted into direct current using what? Yep. Come on. JE aspirant, let me tell you, NTA is like really rocking these days. Like literally. They released an answer key with the wrong serial number. I mean, question ID is there. You have to see in the answer key that question ID. When you see the question ID, then the answers are not in the same order as in the question. So you have to check the option ID and then mark the answer and then check whether it is correct or wrong. Then you need to remember, oh, whether it was correct. So they messed it up. They have in fact withdrawn the provisional answer key, everything. I think they will be uploading it soon. Hopefully things will be sorted and then you can claim for it. In fact, I'm going to release very important notice to all the NEET students. Guys, this happened with many kids who appeared for JEE and they are going to lose the entire marks because of it, or they might lose many marks because of it. What is it? I will tell you in a separate session. I will be making a separate session. Things to learn from JEE students thanks to NTA. So we will be making a separate session. Do you want that? Because I was there in all the JEE discussion sessions. I know each and every problem which each and every student has faced across because of the comments, because of the feedback that we get. So there is no better way or no better person who can tell you all the problems, that too for a NEET student, because I know what other NEET teachers have done on many channels. They have seen what other teachers have done on other channels. They have just chumma copied things saying, oh, don't do this, do that. Many teachers have not even researched what is happening, what is not happening, whether it is out of syllabus or whether it is in the syllabus. They have not done anything. Still, just chumma, they are copying other teachers. This is very, very hazardous. I mean, you are talking about students, career over here. We are talking about students' lives over here. We are talking about, being a responsible teacher over here. So let's not do that. Okay. So, on this channel, we are very authentic. We are true to ourselves and to our students. So I'll be giving you the authentic, things which you should follow for NEET based out of whatever NTA might do, because whatever NTA does, NMC can also do that. Let me tell you, they are like brothers and sisters, right? So we need to be careful about it. We need to be careful about it. Yeah. So I don't want, and I'll tell you what is the worst part. The worst part is you guys are going to get only one attempt. At least JEE students, they have 2 attempts, right? Okay, January messed up, no problems. At least in April you have the next exam. You don't have that, number 1. Number 2, at least that is online. Tuck, 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 you have to click. This is bubbling based. So you need to be a little bit more careful. Okay, so let's do that. Yeah, don't worry, we'll be doing it. Yeah, alternating current is converted into direct current by rectifier. Very good. In an electromagnetic wave, the energy transported per unit area per unit time is described by the dash vector. Few students know this, few students don't know this. What is that called? What is that called? What is that called? Yeah. In an electromagnetic wave, the energy transported per unit time per unit area is called vector. Which vector? That's called as a pointing vector. Pointing vector. Okay, keep that in mind. It's a name which you might overlook, which you might not realize it, when you're reading stuff for NEET or even for boards. But yeah, that vector is called pointing vector. It tells you it's a vector which goes in the direction of the wave. If light is going like this, it will go like that only. And the magnitude of the vector is how much energy is going per unit time per unit area. That's a pointing vector. Okay. Next, the diffraction occurs more when the dash of light is dashed to the aperture. Aperture is the size of the hole. Aperture is the size of the hole. So when does the diffraction occur more? When the wavelength of the light is close enough to the size of that hole or that aperture. Then you will see maximum light spreads. So that's when maximum diffraction occurs. So the wavelength is close to the aperture size. The spreading is also maximum. Keep that in mind. When light goes from dense medium to the rare medium, the wavelength will comparable. Yes, comparable is also a good word, Vidya. Yeah, you can use the word comparable. Yes, similar. Okay. Yeah, that is also fine. When light goes from dense medium to rare medium, speed will increase. Speed increases, wavelength also increases. C is f lambda, no? So C increases, lambda increases. So wavelength will also increase. Oh, very good. Oh, very good. Oh, amazing. Oh, let's go to the next question. The radiation pressure due to light on a reflective surface is given by radiation pressure. Radiation means electromagnetic radiation. Pressure means force per unit area. Can light give some force per unit area? Yes. It is very small, but it is there. How much it is? That is called as radiation pressure, and the formula for that, because it is reflective, it is 2 times I by C. If it was absorptive, then it is just I by C. If it is just going to absorb, then the force per unit area will be I by C. If it is reflective, it will be twice as much, so it will be 2I by C. So use this word, reflective. You have to be very careful. If you do not see that, gone. Big question. AC circuit containing only inductor, resistor, phase angle between the voltage and the current is determined by dash, where omega is the angular frequency, L is the inductance, and R is resistance. The phase angle, phi, I think there is a formula in tan or cos, you can use whichever you want. But since L is there, R is there, and only LR is there, so it will be, I think, tan inverse, right? Tan inverse of omega L by R. If you are wondering how this comes, arc tan is same as tan inverse, don't get scared. So what the hell is this arc tan? So you have a LR circuit. So this is resistance, this is your XL, which is omega L, and this is your phi. So what is tan phi? What is tan of phi? Opposite by adjacent. Opposite is omega L, adjacent is R. So phi will be tan inverse or arc tan omega L by R. That's it. That is the answer. Understood? That is how you get it. Okay, moving on. The displacement current concept, which helps account for the changing field in capacitor, was introduced by? Who introduced it? Was it me? Was it you? Was it Newton? Newton Anna introduced it? Or was it Faraday Anna? Lenz Anna? Maxwell Anna. Who was that name? Yes, it was Maxwell. Okay. Displacement current concept was introduced by Maxwell. You'll be like, sir, who are these two people? That's his first name, middle name. Okay, don't tell me, sir, who are these three people? It's Maxwell is the surname, James is first name, Clark, I think, is middle name. Okay, so it's Maxwell. Yeah. Okay, cool. Great. Moving on to the next one. Polarization can only occur with waves. Which electromagnetic waves are? Which waves? What is electromagnetic wave? It's a longitudinal. Mechanical? No, it's a non-mechanical wave, and that too it is a transverse wave. Only transverse waves can be polarized. Sound is a longitudinal, it can't be polarized. Keep that in mind. Very good. Maxwell Tatta, it seems. Oh my god. Yeah, because you are very young now, right? So yeah, Tatta is correct. Tata. Okay. The permittivity and permeability are doubled. The speed of light will. Permittivity is doubled. Permeability is doubled. What will happen to the speed of light? Use the formula. 1 by root mu naught E naught. Mu is doubled. E naught is doubled. So 2 into 2, 4. Root of 4, 2. So it will become half. It will become half. Yes, that is correct. If you are wondering how I did it, don't ask me. Okay, but I will show it to you because I can do it mentally. Maybe you might find it little difficult. It's perfectly okay to write it down and do it. It is 1 by root of mu naught into epsilon naught. So when I, that is the speed of light originally, when I write it as 1 by root of 2 mu naught into 2 epsilon naught, then what will happen? 2 2s are 4, root of 4 is 2. So it will become like this, 1 by root of mu naught epsilon naught. This is the original speed of light, so by 2. So it will become half. So this is the new speed. C prime will be C by 2. C prime will be C by 2. 2 2s are 4, root of 4 is 2, but it is downstairs. Is that clear, everybody? Okay, moving on. The EMF generated by a generator is given by dash when a coil rotates in a uniform magnetic field. What is the formula? What is the formula of the EMF generated by a rotating coil inside a uniform magnetic field? There's a beautiful formula. There is a biscuit which you get. It has black brownish cream in between, and there are some sugar particles on it. There are some holes also on it. And what is the name of that biscuit? Anybody remembering that yummy biscuit? At least I love it. Bourbon. How many of you remember Bourbon biscuit? Yummy, yummy biscuit. How many of you like Bourbon biscuit? When I told this last time, students were like, no sir, I like Jim Jam, sir. Who are those Jim Jam students? Who likes Jim Jam? Yeah, I like Bourbon. Yeah, Bourbon. Very good. So Bourbon, Bon. Remember Bon. Don't remember Boar. Remember Bon. Yeah. So Bourbon, Bon, B-A-W-N, omega N. Bon sine omega T. That is your EMF. That is your EMF. Bon sine omega T. Understood? Very good. I love Bourbon. Somebody for Jim Jam? Nobody for Jim Jam? Thank God. Okay. Next one. Yeah. See, Bon sine omega T. Density of electrical energy dash magnetic energy in EM wave. Density of electrical energy dash the density of magnetic energy. Electrical energy and magnetic energy are always hand in hand. They are always together and they are always equal. So it is the same. It's equal. Yes. Perfecto. 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 Moving on. In LCR AC circuit, voltage across L and C are dash phase. That means in phase, out of phase, or just not in phase. What do you think? Perpendicular in phase, 30 degrees in phase, 40 degrees in phase. Inductor is on the top. Capacitor is below. Love is above all. Capacitor is below. What are they two? Always opposite to each other. Always opposite to each other. Oppose means 180 degrees, pi radians, out of phase. So they will be out of phase. If they are together in phase, if they are opposite, then they are out of phase. Keep that in mind. Yes, perfect. In AC circuit containing only resistor, the current and voltage are dash phase. No, it was not perpendicular. No, a lot of you got it perpendicular. The answer was pi radian, which is 180 degree. Inductor and capacitor. Inductor and capacitor it was, not resistor or current. Read the question carefully, that's why. Inductor and capacitor, okay? So that was the answer. Right. So in a AC circuit with a resistor, the current and the voltage are obviously, there is nothing like inductor and capacitor in this circuit. So current and voltage are together, 0 degree angle. So they are in phase. 0 degree angle, so in phase. Understood? Oh, clear? Oh. Those of you get confused, let me also remind you over here. This is how it looks, the diagram. This is your current. This is your voltage across the resistor. This is the voltage across the inductor. This is the voltage across the capacitor. So you can see this and this are 180 degrees apart. This voltage with this current is 90. This current with this voltage is 90. This voltage with this current is 0 degree. They are parallel to each other. This is how the relationships are. Okay, moving on. If the permittivity and permeability are doubled, then the refractive index of the medium. We just did this question. But the concept there was slightly different, or the question asked was slightly different. The new speed which we got was c by 2. So the speed has become half. And mu, refractive index is speed of light upon speed of light in the medium. So basically C prime is c by 2, so it will become 2. So the refractive index is 2. Yes, very good. Excellent. Yeah, the refractive index of the medium is 2 because permittivity and permeability is doubled 2 times each. So C prime will be c by 2. We just did that in one of the previous questions. Average value of AC current is, what is the average value? What is the average value of AC? The average, how much ever positive, that much negative. So positive, negative cancel each other. The average value will be 0, right? The average value will be 0, right? Yep. Sign voltages, positive, negative, positive, negative, positive, negative, positive cancels negative, that's it, 0. Awesome. Those students who wrote 0, proud of you. Very good, Sanvi Krishna. No, it's not 1 by 2 pi, that's wrong. Yes. Okay, no problem, it happens. Very good, crazy dude, JS friend, Susmita, awesome. Moving on, a galvanometer converted into an ammeter will measure dash value for an AC current. Galvanometer converted into an ammeter. Converted into an ammeter will measure dash value. Now, galvanometer based on the deflection which is produced when the current is passed. Now, if the current goes like this, it will deflect here. If the current goes like that, it will deflect here. For AC, once the current will go like this and like that. So will it deflect here or deflect here? Think about it. The current will change the direction so many number of times in 1 second. So it's not like it's going like this, like this, like this. What, the galvanometer will dance or what? No, right? So what will happen? It will not be able to shake. It will not be able to vibrate so much, so quickly. So it will not show only anything. It will end up showing 0 value. 0 value is the answer. That means average value. It will be the average value or 0 value. One and the same thing. No, not RMS. It's the heat wire instrument when used to measure the current shows the RMS current. Remember this. Heating wire ammeter shows, or a hot wire ammeter shows the RMS current. A galvanometer converted into an ammeter based on the deflection principle will not be able to deflect, and it will end up not deflecting here, not deflecting here. It will show the average value of the positive and the negatives, which is a big fat 0. So that's the answer. Got it? Be careful. 2 different instruments. Power factor in AC circuit is defined as the, power factor in the AC circuit is defined as the, many ways of defining it. You can just call it cos phi, or you can call it as the cosine of the angle between voltage and the current. Yeah, cos phi, which is the same thing. What is phi? Cos of phi, what is phi? It's the angle between voltage and the current. What is the angle between voltage and the current? You take the cos of it, that's it, that's the power factor. Yes, very good. Cos phi, cos phi. Awesome. Yes, you can call it as R by Z also. Yes, you can call it as the resistance by impedance also. Very good. I can see that with Srinidhi and Dream Queen. Very good. Yes, you can call that as well. Next one. Electromagnetic wave traveling in vacuum has an electric field component E and magnetic field component B, which are related by E by B. Oh, this is known. This is C. This is speed of light. We did this already, just in a different way. It's being asked. That's all. Okay, but it's a very important line again. In a LCR circuit at resonance, the current is. Many filling the blanks can fill over here. In resonance for LCR circuit, the current is. If you remember, there was a graph, current versus frequency, and the graph goes up, and then it starts dropping down. It reaches maximum value when it reaches resonance. So it is maximum for sure. That's one answer which you can put. And how much is the value? It's EMF by Z. Z is R, so E by R. So E by R or maximum, both will work. Yes, maximum is also the answer. E by R is also the answer. Very good, very good, very good, very good. Keep it up. Last few questions, then the remaining parts I will be giving it to you as homework or in the PDF. Okay, let's try to cover up as much as possible. The average power consumed in AC circuit with resistance R, RMS current I is given by P is equal to I square R, known as which power? There are three kinds of power. Real, apparent, come on. Reactive, real, apparent, reactive. Which kind of power is this? Which kind of power is this? Let me know. Meanwhile, I'll just message Gopika ma'am and Baswa sir that be ready. Yeah. What is it called? It is called as the P is equal to I squared R is known as the real power. Yes. It's not apparent power. No. I'll tell you what. See, many students get confused over here. The triangle looks like this. This is the power triangle which you should know. I squared R, which is also VI cos phi. This is called as your real power, VI cos phi. VI, if you just do voltage into current, that will be this part. This will be phi. So VI cos phi is the base of the triangle. This is called as the apparent power. And this side over here, my dear warriors, this is VI. Opposite to it, that means it will be sin phi. This is called as reactive power. So you should know this power triangle. So when I do I squared R, I will actually get VI cos phi, which is the actual power which is being consumed in the circuit. Only VI is without cos phi is apparent. VI sin is called reactive. Okay, cool. Shall we go ahead? Next, move on. X-rays have wavelengths from which to which nanometers approximately? What is the range of the wavelengths? My dear warriors? Yes. What is it? Yes, it's in Armstrong. So I think it will be in some nanometers, like, you know, few nanometers here and there. 0.01 nanometers to 10 nanometers. Yes, perfect. It's actually 0.1 Armstrong, and then you can go ahead to 10 Armstrong as well. Yeah, perfect. Right. So 0.01 nanometers to 10 nanometers is the approximate range. You should remember it. Don't ask me, sir, why should we remember it? You have to. Number one, because you will be using X-rays in your medical field. So obviously you are meant to know the wavelength. Number two, they can give it to you as match the following with options. X-ray, visible spectrum, red light, blue light, something like that. And then wavelengths on the other side. So you should know the answers. Okay. The phenomena where AC generator produces an output voltage that varies sinusoidally over time is known as dash, based on dash law. AC generator producing voltage which varies sinusoidally is known as what? Electromagnetic. Is based on the phenomena. Yeah, the phenomena is electromagnetic, correct, and it is based on Faraday's law. Yes, the changing magnetic flux causes electricity, right? Yes, perfecto. Moving on, the dash effect demonstrates that the light can show properties of wave and particles both. There is one thing which shows that light can show both kinds of properties. One experiment, one effect. In fact, the answer should be very obvious now. There is only one phenomena which is having, or very few phenomena which has the word effect in it. What is that word? Photoelectric effect. Yes. So photons are the particles of light. Light was thought to be a wave, but then photoelectric effect showed that it also has particle-like behavior. So that's the answer, photoelectric effect. In the spectrum of EM radiation, the type with the longest wavelength, you can also call it shortest frequency. Shortest frequency, which is that? Come on guys, get ready for bio to start. We will do 70 to 75 questions maximum, right? Chalo, remaining 25 questions I'll be giving to you in PDF. What is the answer? Yes, it is radio waves. Very good, proud of you. Starts off with radio waves right till gamma rays. That's the answer. Dash effect is the process by which AC is transformed into direct current. I think we have done this before also. It is rectification. Okay, let's just move ahead. Microwaves are electromagnetic waves with wavelengths ranging from 1 meter to 1 millimeter. Yes, 1 millimeter to 1 meter. Used in satellite communications. And which other application do you use microwaves? Which other application do you use microwaves? It's so obvious. I mean, even if you are not a science student, I think you will guess it, yeah. The answer is over here only. It will be used in microwave only. Microwave ovens. Exactly. Yeah, very good. Yeah, where else will you use? Microwaves, the name only comes from there. So microwave ovens use those microwaves. The Dash law tells you that induced electromotive force in closed circuit is equal to the negative of the time rate of change of the magnetic flux through the circuit. Big things short, it is telling you the derivative of d phi by dt with a negative sign is EMF. Which law is that? Oh, come on, Faraday's law, right? Faraday's law. E is minus d phi by dt. So, see, in mathematics, writing it is so simple. If you write it in English essay form, it will be so big, 1, 2, 3, 4 lines. That's why we learn mathematics. So, all the students of NEET who say, sir, why mathematics, sir? If mathematics is not there, no, you have to write like this paragraph. But in maths, you'll just write E is equal to minus d phi by dt. It is all understood there. So, that's the use. UV has shorter wavelength than visible light, typically ranging from, what is the typical range of ultraviolet? Typical range of ultraviolet, yes, that is 10 to 400 nanometers. It's just before, think about it, wherever visible starts, that's where ultraviolet ends. Violet light has 400 nanometers, roughly 380 to 400. So that's where ultraviolet will end, 400. Before 400 nanometers, what is there? Till 10 nanometers is basically UV. Keep that in mind. That's how you can remember it. Relation between wavelength, frequency, speed of light in vacuum is given by this. The equation highlighting the wave nature of light and fundamental study of what? C is equal to frequency into wavelength. What is it highlighting? It is fundamental in the study of, obviously, wave nature, electromagnetism. Is studying of what? Your electromagnetism. Yes, perfect. Awesomeness. Next one, the dash of an electromagnetic wave is the distance over which the wave shape repeats. Something of an electromagnetic wave is the distance over which the shape repeats. What is that distance called? Oh, I repeat it after how much distance? Wavelength, right? So one wavelength. Exactly. Awesome. Dash currents are induced in circulating currents within a conductor exposed to changing magnetic field, causing dash losses. Think about it. When you take some kind of a current which is being formed as loops in a conductor, why they are formed? Because of magnetic field changing. They cause some kind of loss. What kind of loss? They cause energy losses, heat losses, and these currents are called as eddy currents, undesirable currents. Exactly. Very good. I can see many students who guessed eddy currents. Yeah, this is heat loss is also okay. Yes, and even energy loss. No, it is not hysteresis. Hysteresis is not correct. Hysteresis is for ferromagnetic material. When you magnetize it, demagnetize it, and the magnetic properties cause the hysteresis loss. Currents cause energy loss in the form of heat. The power dissipated in AC circuit can also be calculated using the formula where P is equal to, P is equal to VI cos phi. Vi cos phi, we have seen that before also. We have seen that before. Now, the questions after this, you will be getting it as PDF. I have kept all the 100 questions. Don't worry, it's not going to disappear. So now it's time for biology. So just like, you know, we have been telling you, all the sessions are going to be conducted in the same stream. So we have biology now, and after that you are going to have chemistry. Don't go anywhere. Okay, I'm calling your sir and ma'ams. Okay, chalo. I'm ending the session right away right now. I think ma'ams and sirs are already a part of this.
If we are audible and visible to you, a quick thumbs up in the chat or
Fire.
Okay, green hearts in the chat.
Fire emoji in the heart.
Or green hearts in the chat.
Fire emoji in the heart, I don't know.
Fire in the heart.
Yeah.
That is gastric.
Why are they not sharing link? Why is the chat's not moving? Are we not live?
Are we live, students? Let us know. Are we live too? Happy evening. Yes, Krishna, happy evening to you. Are we audible and the presentation behind us, is it visible to all of you? Let us know in the chat right now if we are audible and visible to each and every one of you.
Is that a delay?
Yes, is there a delay or is?
Yes, there is a delay. Students
Yes.
have already typed. Hello.
Are we visible? Hello, Crazy. Hello, welcome. Good evening, each and every one of you. Is our voice perfectly audible to you? Let us know right now. Hello. Yes, amazing, Sahana. Yes, Niharika.
Good
Good
evening.
evening,
Good
good evening.
evening. Yeah, did you people share the link with your friends?
Did you
What
call
the-
your friends?
No. They wouldn't have. See, no. I told you. Thank you. Thank you.
Misti.
1000 eyes.
1000 nice. Draw that fly, house fly. 1000 nice, no? Shit has.
Yo.
So students, this is a very important chapter, all of you know. And Gopika Mama has taught this chapter once, but
Very nicely.
very nicely. And the foundation for this chapter is from your class 11, that is biomolecules.
Yes.
If you know the biomolecules chapter, this chapter is going to be very easy to you. Now, when I say easy, I mean the foundations are correct. For example, nucleotide, nucleoside, everything you have learned in your class 11th biomolecules, which we did from me, that also very nicely. Okay. So,
Yes,
exactly,
ready?
like, don't be confused, they're saying. So, with that being said, this chapter will hold at least 40 marks, ma'am.
Yeah.
Yes, around 40 marks this chapter will hold.
Yes, yes.
So, we'll be doing every single line of NCERT today, where questions are beautiful. Yes,
Yes,
questions are
very.
beautiful today, and we have personally curated the questions. Can we start?
Yes,
Can we
ready?
start?
Yeah, the numbers are not at all happy. Come on. You people can do so much better.
Should we increase the volume? Should we hold, ma'am? Otherwise, it'll be too difficult, no? Anyway, we're not.
Let me listen. No, it's loud, no?
Hey, my voice is really loud. Do you want me to increase the volume or this is fine?
Isn't this fine? The volume is fine, right? Holding will be very uncomfortable.
Yeah, holding will be uncomfortable.
Okay. Please,
Put your mic.
Okay.
Only one mic is there. We can't hear too difficult.
Just hold it.
We'll just hold it otherwise.
Yes.
Can we start, ma'am?
Yes, please. Okay, so
Yes. Let's start with the first question, ma'am.
then we don't need this, no?
Don't need this. Yeah. No, let be there. Otherwise, that'll be.
Okay.
Okay, the first question.
DNA is a long polymer of dash. Okay? DNA is a long polymer of dash. This is literally the first line of NCERT.
And
Yes.
this, you can, if you know the biomolecules chapter, you can answer this question also.
If you know molecular basis
Basis
of
of
inheritance
inheritance.
also, you can answer this.
So easily. DNA is the long polymer of dash. It's fine. It's fine, ma'am.
Nucleotides, deoxy-
Deoxyribonucleotides.
Yes.
Yes.
Very good.
It is. Video is not. Shreyas.
What?
Nucleotides. The answer is
Deoxyribonucleotides. Students, nucleotide is the correct answer. But they are asking DNA is a long polymer of who? Is it ribonucleotides or deoxyribonucleotides?
Look
Okay.
at the pentose sugar here.
Yes.
In the case of your DNA, the pentose sugar is deoxyribose. Right? The one oxygen is missing. Like some of the students are missing here.
Yeah, all of them
we're
are missing.
missing. Some of the students are missing. The oxygen is missing there.
Yes. Okay.
Now, next question, ma'am.
Yes, please. Bacteriophage lamla has dash base pairs. Number of base pairs of bacteriophage. Phage.
Phage. So
Okay.
quickly tell me in the chat, what is a bacteriophage also? Is it a virus or is it a bacteria? Quickly. Is bacteriophage a bacteria or is it a virus?
Oh, sorry.
Sorry.
Come on, tell the answer.
Hello?
What's the number? What's the number?
Number. How many
Okay.
base pairs?
5386. One answer has come.
Who is the
Bacteria.
person? Srinidhi was the person to answer it, right? 58.
No.
No.
No. YS is the correct answer.
Bias the 48. Yes. It is 48502.
Yes.
The number of base pairs. Now, students.
Yes, virus
yes,
that attacks
the
bacteria.
Exactly.
Yes.
Bacteriophage is the virus which feeds on the bacteria.
So share the link quickly with your friends. Yeah, this is
Yeah.
very depressing. Molecular basis of inheritance, a high weightage chapter, and all of you are missing. All of you are missing. Okay? Quickly share the link on your WhatsApp, Instagram, Telegram,
Everywhere.
whatever you have, all the apps you have.
Next question, ma'am.
Yes, please. Okay.
Escherichia coli has a haploid content of human DNA is dash base pair.
Basically, tell the base pair. Oh, Shreyas told the answer 48502.
Shreyas sir, Google. Shreyas sir, no. Shreyas sir is watching our sessions.
Yes. Shreyas has been constantly watching the sessions and copy pasting your answers.
Escherichia coli has a haploid content of human DNA as dash base pairs. Quickly.
Yes. Tell me quickly.
4
Yes, 4.6
6 into 10 to the power.
Let's see who's the correct answer. 6, yes. Yes. Okay.
Into 10 to 6, na?
Yeah. 4 point. Oh,
1 second. You should.
I'm writing in the air.
1 second.
Selected.
Now this was for, see, the question is asked for haploid nuclei. Sometimes what NEET, the person who is preparing the paper, what if they ask you a diploid content here? They can ask, right? They can change the question from
I
haploid.
taught this also. There was
Ah.
a numerical which came.
Exactly. They can ask you, this was for haploid. They can give you a diploid content also. That time also you should multiply it into 2.
Yes.
Easy question.
Okay, next question.
The backbone. No, you can read.
The backbone of polynucleotide chain is formed due to dash between the phosphate group and dash group. Okay?
Easy question.
Yes. Students, what is the backbone made up of? What is the backbone made up of?
Students, remember in the entire nucleotide, there are 3 different parts. The first part is the sugar, and then we have a phosphate group, and then we have a nitrogenous base. Now, out of these 3, which one is the backbone?
Yes. Come on. Sugar, phosphate, very correct. Very correct. Okay, all of you tell me what is the nucleoside. So, can you remember how nucleoside?
Yeah. One sugar plus base.
Yeah, so how it happens, nucleoside means one person is pushed to a side. So I told them like this: phosphate is pushed to the side, nitrogenous base and sugar becomes company.
So
Full those.
nucleoside.
Yes. So students, it is sugar and phosphate group. So here, see, this is actually a good question. See, the backbone of a polynucleotide is formed due to dash and dash. This way also question can come. So I've given both the ways. One is phosphate group and sugar, or they can ask you phosphate group, sugar. And they can ask nucleoside.
Other way around.
Yes.
And remember, students, because of this phosphate group right here, that is why the DNA is called as negatively charged DNA. That you need to remember that. Okay.
Yes. Very good. Very good.
Pentose sugar. Now, next question, ma'am. In RNA, the sugar is dash, which has one more dash group than the DNA sugar. This is a complete structure-based question, ma'am.
Yes. Complete structure. Just tell what is absent, what is extra in DNA. And
what
is extra in DNA and what is
less?
Missing? What is extra in RNA and what is less in? Mona, I didn't forget you. Ribose, OH, okay.
Yes.
Srinidhi.
Your RNA has an extra oxygen. And that the oxygen is missing. That's why it's called deoxy. D means something is missing. What is missing? Oxygen is missing in the case of DNA. So deoxyribose sugar in the case of DNA, one oxygen is missing there. Okay.
Good job. Yes, ribose and OH. Perfect. Oh my God, my students are perfect. All because of molecular basis of inheritance.
Yes, I thought them in biomolecules also.
All because of molecular basis of inheritance.
Pyrimidines in DNA are dash and dash. Very easy question, straightforward question.
Yes. Who are the pyrimidines?
You cut the pyramid.
You know, there's a way to remember this.
I remember. You cut the pyramid. Cut.
Nahin tha. Cut. Yeah, cut was there. Cut is there, and
This is how I remember.
What is the way to remember? At Gopika ma'am's class. To remember adenine. At Gopika ma'am's class. This is for the bonding.
Okay.
Why can't you appreciate?
Oh, that was a nice.
Appreciate.
I had a trick for purines. That is for purines.
Pure as gold.
No. Air is pure. Air is pure.
Oh,
I made my
put
own.
Pure as gold. Pure as.
I'll tell you, I use some extra thinking there. Like when I use.
Oh God, students like consumption is going to tell some theory.
See, air is pure. This is what I used. Air is pure. Pure means purines. Air, A for adenine. And what is gas? Air is the type of mixture of gas. So G for guanine.
My God, again, sir, is shocking me. Yes, pure as gold.
No, sorry, air is pure. This is what I
Okay.
learned.
Very good, very good. So, what's the answers?
Cytosine and
Thymine.
thymine.
Yes.
And remember,
Next.
students, your pyrimidines. Tell me now, which is the single ring here, which is double ring?
Yes.
How many of you?
that
This
also.
so can be asked as a question.
Yes, yes.
Which is the purine single ring or pyrimidine single ring, or it's other way around? Tell us fast, quickly in the chat.
Come on.
Now we'll tell you every single possible way of asking questions. Also,
Their energy is very low.
very low energy, right?
Should I go?
Where will you, where will you go?
Outside. Baswa sir will take class alone.
No.
Come on, show some energy. They're putting laughing emoji. They're lazy to type the laughing emoji in this one. There are students who tell, ma'am, I am laughing. So I should understand that they're putting laughing emoji.
Okay, purine and DNA are
Yes,
dash and dash
very.
again.
See, purine is double ring, pyrimidine is single ring. For that also, I made a idea, but now I forgot.
No,
Okay.
I remember that because when I was teaching N-glycosidic linkage, it's called as N-glycosidic. Why is it called N? Because of the nitrogen attachment there.
Perfect. Okay.
No
The
appreciation only for my.
The purines in DNA are dash
Dash
and
dash.
dash. Adenine and guanine. They're very fast.
Adenine guanine. Yes.
Yes.
Next question, ma'am.
The famous model for the structure of DNA is known as. This is when my brain don't work for a minute.
Exactly. You're saying you're sending the.
Have you ever have you ever like after eating something, instead of throwing the waste, have you thrown the plate itself into the dustbin? That means your brain cells are always working. Huh?
Yeah.
Students, what is this?
Why did I throw the plate? My mom hit me on the.
No.
the plate.
See, I'm trying to throw the spoon. Imagine a plastic spoon I've eaten, cake or something, and then I want to throw the spoon, but I instead go and throw the entire plate or something like that. You know, that's when the brain don't work for some time. Very good. Double helical structure.
Double helix.
Yes, double helix.
Next question. The double helix model was proposed by Dash and Dash.
Two famous
Sign.
people who gave you more trouble to study.
And the two more people who are forgotten also here. Also tell that about.
Yeah. Mainly one person.
That lady.
Feminism.
Feminism, that lady. Yes. So there are two main scientists who one of them is a cricketer. Name only. Other one sounds like an insect. Yes, no. Sounds like an insect.
Yes, ma'am. Purine sounds like ending with 9, so it can't be single ring. It has to be double. Oh, that's how she remembers. Something I told in the class.
Watson and Crick, exactly. Now tell us right now which are the other two scientists who have been forgotten.
Mainly one person who was not even recognized.
They
One
were-
more person was recognized.
They were usually their contribution was so massive because without X-ray diffraction you cannot get the
Yeah.
structure, right? Yes.
Who told? Wilkins and Franklin are
Franklin,
forgotten.
forgotten.
Very
Yes,
good,
Franklin.
Stanley. Yeah, even I think Mona told before Franklin, but it is
Yes.
Franklin.
Yes. Next question. The
Yes.
base pairing between adenine and thymine involves dash hydrogen bonds.
How many hydrogen bonds keeps these two people closer? Full name and all they're putting. Rosalind
Wilkins and
Franklin. Full accent, no? When we talk about
See, their names are like that. Basavaraj, if I say Basavaraj.
Basaraj and Gopika identified double helical. So poor students won't even study only.
Won't study only.
Names have to be changed. Yeah.
But
Let us become
You
famous.
should know, students, unlike those scientists, we have also done some scientific work.
Yes. Teaching you is the scientific work.
Before,
No, I'll tell you. We check their set of characters. Then according to that, we behave. So this is like a study.
apart from that, ma'am, in our master's final days, we have to publish a paper also, right?
Yes,
So we have done some hardcore research for at least 1 year,
Yes.
full on.
Even I think we both have worked for almost 2 years on the same research. At the end of the time, we had to sit and cry, students, because we had I think I had around 7,500 pages that entire
thesis.
booklet. Yeah.
Massive.
My, crazy.
That is two hydrogen bonds between adenine
Yes.
and thymine.
No problem. No problem.
Guanine and cytosine are paired. Question.
Students, did you smash the like button? Now the numbers are satisfying.
Yeah,
Come
it
on.
just went down. As soon as you said it went down.
Nazar lag gaya. Students, smash the like button.
So between guanine and cytosine, they will know, ma'am. Easy.
Okay, yeah, but they're telling na.
They told already.
Yes, yes. You both are great scientists. Thank you so much.
Yes, I am from Karnataka. Ma'am is also from Karnataka, but
I'm born somewhere, brought up somewhere. I'm hybrid.
I am also born somewhere only.
Okay, he's also born somewhere, students.
Huh.
Uganda.
I was born in Ayodhya. Uganda, it seems. Okay, next
Okay.
question.
The distance between the two strands of the helix DNA is approximately.
Number is
What is
very
the
important.
distance? These people don't even laugh, yeah. Don't even smile. It's like we are cracking jokes for ourselves.
We are not funny enough, that's all.
You can't accept that. Whatever we
Okay,
say, they
we are
have
not
to
very
laugh.
funny.
Students,
Okay.
what's the distance between two strands of a helix? This two are strand, double stranded. What's the gap between these two? Come on, come on. 3, yes, correct. Guanine and cytosine are bond with 3. Correct. YS took 1 minute to type.
YST is just patronizing you. She's just Gopika ma'am should not feel bad. Even Sharat also.
Oh, now tell Sanvi also. Come on, come on.
And everyone is laughing. Shit.
I'm going to take Super 6, locomotion and movement.
I am considered. Which chapter do you want me to take, students?
Cell.
Cell cycle, cell division.
Ah.
L cell cycle, cell division. Next.
Okay. Rachel, I answered your question. Students, the distance between two strands is how much? 20 Armstrong. They can write 20 Armstrong or 2 nanometer, okay?
Yeah, yeah.
Yes, next one.
I think some of them wrote 0.34 nanometer. They are telling.
Therefore, they're telling for the distance between both the base pairs.
Yes.
Galat. The pitch. Yeah, here is
Yeah,
where
question.
you should answer. The pitch of
the
two chains in double
helix
helix.
is dash nanometer.
Ha. JDSS, DPISS.
So, ma'am, here still students do not know what is the pitch. Like, how do we calculate the pitch? Usually, pitch is calculated based, that is, number of base pairs in the between the two strands. That is your 10 base pairs into
Into your the helix rotation. How much it takes
how
to
much takes to rotate. That is 0.4.
3, 4.
So your pitch will be how much? Pitch will be
3.4.
3.4. That's how you calculate the pitch.
Very
That is-
good. 3.4, correct.
That is between the distance between two, 10 base pairs are there and one turn. Then you have to multiply it, you get 3.4.
Yes. Okay, next question. Okay. One turn of double helix has about dash base pairs. You told off. Turn. Next question.
Okay, that is 10 base pairs in each turn.
They know this. We hinted the answer.
Yeah.
The central dogma in molecular biology states that the genetic information flows from DNA to dash to dash.
And also tell us,
What do you think?
no. Who gave the central dogma? Yeah, who gave the central dogma?
Okay.
Tell that in Malayalam. No.
Who gave central dogma? Tell in Malayalam will be so funny.
It's the same name only.
Students, I have spoken Malayalam for first NCERT line by line. Every time we...
Yeah,
remember, we
yeah.
spoke in almost all the languages.
Yes.
Very good. RNA, protein, Sanvi.
Yes, it is.
mRNA to protein, RNA to protein. You can write anything.
I can self-replicate.
Yes.
To
RNA
to.
to protein.
Now quickly tell me.
No, don't ask. Are you trying to ask?
Yeah. You want to ask? The question is there.
Yeah.
Okay. Okay. I was gonna ask what is ulta, but that question is there.
Yeah, the question is there. Don't answer.
Okay.
Francis Crick.
Yeah.
Whoa.
The process by which a DNA is copied is called as.
Self-copying. I'm going to do a Xerox and I'm just copying. Taking a Xerox of it. What is that called? Yes. Did they all smash the last
No, they're
part?
telling transcription.
Students, no. Self-copying. DNA makes multiple
Copies of itself. That
Come
is
on,
called
come on.
as. When DNA is making a copy of itself, you're telling transcription is from DNA to RNA. Yes, correct, Shubhashini. It is replication.
Yes.
Next question.
Let
This
me
is
see.
question.
The process by which DNA is transcribed into RNA is called as. Okay? Yes, correct. Replication is the correct answer. Very good. Now, what?
Previous one, new question.
Yeah, new question. Now, next question.
Replication.
She told already she took bail. Telling that spellings are wrong. Please forgive.
Okay.
Yes, very good. Very good. Srinidhi, Sanvi, Subhashni, Crazy Dude, Krishna, Decity. Okay.
That is
Transcription. So DNA to RNA, transcription. So this is the only thing that you need to remember is this entire central dogma. You know, in this only, sir, just by knowing this one diagram, they'll get maybe 1 or 2 questions. And in boards, don't even ask. They'll only teachers
ask
normal
only.
question target is this one.
In board assess,
Yeah.
especially even the semi-conservative method of DNA is a very favorite question.
And you know that the Messelson and Stahl experiment is really difficult to understand.
Yeah.
So they will catch on that only. Yes, next question. Sure.
The process by which RNA is translated into protein is called as easy question, ma'am. Again, that is
Yes, that question will come.
reverse transcriptase and will come.
Yes. Come on, answer this.
Process by which RNA is translated into protein is called as translation. I think they'll know this, ma'am. Their
Let
students
them
are,
tell it's okay.
they told no. See,
Now they're telling. You told before that
JDSS, DLPSS.
only. No, JDS told transcription. Subhashni told translation. Okay, next question. In some viruses, the flow of information is in reverse direction. That is, from RNA
Back to DNA.
to DNA. This way. Okay. What is the enzyme or what is that process called as?
Tell us the 3 things here: process, enzyme, and example.
Yes. Go for it. Students
things.
clear?
Reverse transcriptase is the enzyme. See, AAC is the enzyme.
Very
What is the
good.
process? Reverse transcription is the enzyme.
One person is giving one
One
answer. Okay. Oh, they're feeling depressed
Why?
because their scores are low. Okay. So I think we already thought about this, and we thought, why not give you a little sweetness to add a little sweetness to your, entire NEET preparation. We thought, why not take a mentorship, a very small interaction, just both of us with you students.
Yeah.
Okay, and it will not happen on YouTube because it's very difficult to track on YouTube.
Not only that, ma'am. So students might not be
Feeling like to type it on such a big public platform.
What is someone they'll talk about me.
Yes.
So just for those students, we are planning something where you can be more motivated. You whatever problems you might have in any chapter wise, anything.
Yes. So students, just to give you that one-on-one attention, we thought we both will come together. So you can talk to us like, your big sister, big brother, and you don't have to, okay? You don't have to feel like, okay, why should I, put it on this public platform? Because even I wouldn't feel as a student to put it out there that my scores are decreasing because I have some kind of a family issue. I wouldn't want to put it out there. So we thought, why not give you a little private space where you can talk to us. So we will be coming to very close, like I know it's online, but still we will give you, and you can also talk to us if we allow you to unmute. So this will only happen on our Vedantu platform.
On the platform, we'll be coming live weekly once. Yes, weekly once will be coming where it's going to be Gopika and I will just be sitting there. Don't think of our teachers that time. Think you're talking to your elder brother or elder sister, and you can talk to us anything that time. Tell us what is troubling you in your preparation because you just have less than 90 days left. And this is the time where you need to be very motivated and that confidence needs to be very high. So in any way we can help you, not just academically. This is academic, we can help you out.
Yeah.
If you want any kind of support from us, we are always here. That's why we are providing everything for free.
Yeah.
Because we know there are so many students who cannot afford question paper books. So we are doing free question papers. There are so many students who cannot, attend classes. So we are giving free on YouTube.
Yes.
There are so many students who cannot afford NCERT line by line reading. If you go also separate, you have to pay for it.
Yes,
in many
yes.
places.
Students, even for this NCERT line by line, for such questions, you have to pay for the booklet.
Yes.
There are companies that do it. There are people who do it. They ask you some amount of money, and it is never less than, it will be somewhere between 750 to 1,000 or whatsoever.
Yeah.
And we are doing that also for free. You think making these questions are easier? Never.
No. You might think someone has to sit and type this. You know that, right? Someone has to sit and type
The entire thing. It's not copy pasted from anywhere.
Exactly. But we were reading a lot of your messages, and we are like, everyone here and there, they say, we are feeling a little depressed, sir. I'm not able to cope up with my, preparation. I'm still getting 400 marks. I'm getting 800 marks.
Yes.
So all of these small things, right? So we'll have a small safe environment for you, because it's not going to be YouTube. It's going to be on Wave platform, where it's going to be much more safer, and you will not have anyone who can judge you there.
We also won't
Won't
judge
judge
you.
you.
We as teachers will never, because we
So-
know what everyone goes through. So
Clear?
we will be coming for a mentorship class, and it might be on the day where you are expecting chocolates from someone. So we will be giving a little sweetness by being the mentors.
Mentor
Okay, now
class,
you
yes.
can guess the day. You can put the dates also in the chat box. We will tell you. Okay?
Now here, example, I was saying HIV, but
Yeah, yeah.
not even a single person gave example COVID. I'm so surprised.
I want to cry. Did
Why
they
did
give
no one?
HIV?
Yeah, they told HIV.
Okay, then thank
They told
I
HIV,
thought
but
them HIV.
no one told COVID. I'm like super surprised.
It's okay. Sometimes brains
COVID is
don't.
gone, nah,
COVID is gone. That's it. Okay. Okay, this is the answer. Reverse transcription. If the length of very good problem, students use your mathematics calculator, everything. If the length of E. coli DNA, okay, what are they talking about? E. coli DNA is how much, sir? 1.36, no? 1.36 mm. Okay, then calculate the number of base pairs.
in E. coli.
Okay, base pairs you have to calculate. Okay, so can all of you calculate? Oh ho, Shravani knows it. Doctor, no, not 14th, not 14th. Not 14th.
It won't be 14th. 14th, we'll be taking classes. 14th is going to be normal classes. We are not going anywhere. We also don't want you to also go anywhere. Sit with us on 14th. We'll be teaching you.
This is not the time for all this
that-
kind of drama.
drama.
Okay, yes.
So we are not giving you a. Yes, I saw the answer.
Saw the answer.
Yeah.
Don't give the answer. We should at least calculate it for them. Just okay, students. So for those students who do not know the sum, just look here. First, I will. So what you have to do is total number of base pairs into the base pairs. What do you tell? Distance between two base pairs. Okay. So 1.36. I'm converting mm into 10 to the power minus 3. Okay. I'm converting it into meters, so I can easily do it. Then what will be the distance between two base pairs? 0.34.
Yes.
So 0.34. Now that also I will convert to 10 to the power minus 3. So what I'm going to do is 1.36 into 0.34 into 10 to the power minus 9. Okay, both 6.
6.
Sorry, 10 to the power 6. Into will become plus. I can't erase, no? Never mind. Okay. No. So the answer will be somewhere between 4.06 something. So we will take it into consideration 4 into.
6.
Yeah. This is how you'll do it. Understood?
Clear?
Yes. Okay.
Remembering
They by
morphology-
hearted the answer. Okay, next
Like
one.
morphology, it's so hard. The morphology, you have to remember the examples, ma'am. Unless you have some tricks. But tricks
We can do that. We can make tricks.
Okay,
for
fine.
that.
I'll start making morphology tricks from the next class. Actually, I have a morphology trick. It was made. It was supposed to go today. No.
It'll go. It'll go this week. Students.
It'll go. I have one trick for you this week. Every single, alternate days or once in 3 days, you'll get one trick from morphology from my side. Okay?
Yes. Okay. The DNA in eukaryotic cells is organized in large loops held by what? Very easy question. Just little grammar, little English, British language they have used, but you know the answer. Come on, tell
Very
me.
easy. This is also easy.
Yeah, but let them do it. Oh, Madhumita, very good. Very good.
Very
Well
good, very
done,
good.
sir. Very good. Proud of you.
Anatomy is beautiful subject, ma'am. And I'm actually a little sad that I could not teach all of you secondary growth, because secondary growth is even more interesting.
Not for them.
No,
Only
it
for
is-
us.
no, secondary growth is they would have loved its secondary growth.
Yes, correct. Histone
histone-
or
Histone is a
protein.
type of. Histone
Type.
is a type. What is histone? What is it made up of?
protein.
Protein, right?
So I think one person. Okay, yeah.
Grammatical. DNA in eukaryotic cell is organized in large loops held by histone, that is a
Protein.
proteins.
Yes. Histones are rich in the basic amino acid residues.
Now-
Dash and dash.
This I have told them in my biomolecules also, ma'am.
Yeah.
You might have also told. In
Yeah,
the
Very important question, students. It will be very usually asked for MCQ, even for PYQ.
Even board
Yeah,
exam, board exam also.
MCQ. Yeah.
Yeah.
Come on, what's
Basic-
the answer? Okay, they are telling the answer for the before one.
Not testing secondary. Secondary growth is very interesting actually.
Very good. I cannot read your name. Azwan.
Lysine and
Lysine and arginine. Okay, lysine and arginine. Yes.
now they become basic in nature.
Yes.
I was going to say something else.
Okay. A unit of 8 molecules called dash is involved in DNA packaging. Who is involved?
Also tell us what is the length of DNA, how
Yes.
much it is getting packed, no compactly packed. Tell us the length of DNA and how it is getting packed also.
Yes. Such a big thread.
Huh. Where's the pen?
Okay.
Like this is your DNA. This will be small blobs here. That is your answer. And then all the DNA will be wrapped around it. Look like a beads on string structure. But they should tell what is this now.
Tell. Very good, very good. Histone octamer. Histone octamer and DNA is approximately 2.2 meters. Okay, very good. Next question. So you want to read?
Ma'am, we can ask them also. It's not in the syllabus, right? The types, octamers, what are the numbers? H2A,
Yeah,
H2B.
they know. I've taught
It's there,
them.
huh?
Types of-
H2A,
no,
H2B.
I taught them because in PYQs they have asked.
Exactly, H2A, H2B,
Students,
H3, H4.
Tell which are the histones involved in histone octamer. Histone octamer. Just tell the number. We know which is double and which is single.
Just
tell
tell
the number.
number.
Okay. I have taught you this. All of you remember quickly.
Next question.
By then they will remember. Huh?
DNA is wrapped around the histone octamer to form a structure called as. Now, this is nice.
Yeah, so we'll wait for their numbers also. Let's students tell all the types of histones involved in the formation of histone octamer. Students, biological classification plant kingdom will do very quickly. Okay.
I'll teach you.
Very good. Dr. Sid, you missed something. H1, H2A, H2B, H3, H4.
Yeah.
H4. Right? 1 second, sir.
H4. Yeah. Kartika is saying yes. This answer is nucleosome.
My 3D diagram. You can never draw. You can never even copy.
Doesn't even look like 3D.
It does. You look from that backside. Go.
No. It looks like a bubble gum.
Oh.
This is the
No.
H1 linker.
Students, how is my diagram?
Here, student, can you see this part?
Did you
This
just
is the H1 linker. This
No one
is
cares. Please put my
H1
diagram.
is the H1 linker here between the two.
Where's my diagram?
Yeah.
Such a beautiful diagram. My God. I am amazed at what I've drawn. I would have got award if I
Nobel
did
Prize.
this somewhere else.
Nobel Prize.
No, Nobel Prize is too much to ask, but at least Grammy Awards.
It is a nucleosome.
Yes.
Here, when the DNA is wrapped around the.
Nucleosome, they wrote.
We wrote, right?
I know, beautiful.
Only one person is saying.
Many will tell. Give them time. Don't give next question. Students, please tell how
Next question
the.
is here. The repeating units of a structure in nucleus called dash thread-stained colored bodies seen in the nucleus.
I'll just break it down. Which is the one which is densely stained
Densely stained, which is transcriptionally active.
and tightly packed. Densely packed.
Densely stained, densely
Packed.
packed.
That's the question. Yes, I am the star. Gopika, I'm artist. I am the drawer. Remember we used to tell when we were kids?
I know. You're the drawer.
I am a drawer.
I'm a
because
drawer.
I never knew the word artist. Very. Hey. Chromatina. Hello, which type of chromatin? Euchromatin or
Heterochromatin.
Very good, Srinidhi. You
Neha
passed
also.
the finale.
Neha also.
Dr. Siddha also. Who else wrote, yeah? Yes, heterochromatin.
Answer here is chromatin they have given us, but it is supposed
No,
to.
we asked the question.
We
not
asked the
NCERT,
question,
Because
okay.
this kind of question won't come.
You
Like
qu-
in the sense, colored bodies. they
You
will
won't ask you. They'll ask
specific.
you specifically that is it is euchromatin.
Or heterochromatin. Okay. Okay. Oh, it came.
It came.
Okay, never mind. Skip.
That is
Heterochromatin. Okay. We are very fast forward. Griffith. Okay.
Looking into the future.
But we can't see our future.
More.
Griffith, in experiments with Dash, discovered the transforming principle. What did he mean? He worked on what? Okay.
Which was the organism he worked on? No, don't tell mouse. They'll tell mouse. I have seen this, ma'am. If I ask him which is the organism he worked on, he'll say mice.
Easiest thing. Rat. Oh, Sharad, you break the records.
You are with us. You're with us.
You put rat.
Even they're saying mice. It's Streptococcus pneumoniae. Yes.
Do you see how fast messages are getting deleted?
Yeah.
This is so smart, yeah.
Yeah.
So smart. Streptococcus pneumoniae. Mice. Mice. Okay.
Streptococcus pneumoniae. Now, this is a disease where the lungs get filled with alveoli filled with
pneumonia. The same
fluid.
like pneumonia. The experiment that uni equal lululu.
See, the meaning of this, English meaning of this is shutting of
Shutting
the
of
mouth.
mouth.
You completely shut their mouth. Tell them savage reply you give them. Like how you should give, no? When someone is doubting you right now, someone must be doubting you, like you will not clear NEET. You should also become this. I'm not able to pronounce this word. You should become and shut everyone up when you become a doctor.
Students, English is a complicated language and we totally respect it.
Yeah,
It is better
why
with
not saying it?
Britishers. Okay.
Experiment that
Uni.
un.
And yeah, why? That is the problem. Unequal locally proved DNA as a genetic material were done by dash and dash.
In 1952.
They're least bothered. They're like, who cares about English? We know the answer.
Hershey and Chase, yes.
Yes. Some people have put Hershey. That also same spelling, huh?
Hershey syrup.
Hershey syrup also same
Yeah,
spelling, no?
Hershey syrup.
Yeah.
Too good. Chocolate syrup. Put
Yeah.
on, vanilla ice cream and eat.
Wow. Everyone does that only.
No.
Okay. Oh,
Might.
yeah.
I'm
No.
not that Chase.
You'll get Nobel Prize. We'll apply.
Hershey and Chase work with viruses that infect the bacteria called as. We already told this answer to all of you. Bacteriophages.
No, we didn't tell. When did we tell?
One question was there in the starting, no?
That is different. Okay, ठीक है.
Hmm.
Now they'll Papa type the answer.
Second time.
So, students, you see Baswaraj's real face. Okay.
See, I believe in hard work, so I want all of you to type. The more you write, more you practice, more you type, you will learn it better. You're like, oh, I saw.
Okay. They discovered that dash alone from the S bacteria caused R bacteria to become dash.
Basically,
From zero to hero. Who made it?
remember how I learned it, Like the rough stain, ma'am. The rough stain is, you look outside rough, it look full on, but inside it's so papa. But the smooth stain is like, complete smooth. Inside, if you look, when evil it is from inside, smooth stain.
Thank you, Madhumita. One person took some time to appreciate us.
Yeah.
It's okay. We don't want. We are down
Yes,
to earth.
they discovered that DNA alone from the S bacteria caused the R bacteria to become virulent.
Think always like this. R was zero, then he S strain made it hero. Did it is
Yeah,
zero? Hero.
Yeah.
God, pronunciation God. No, they'll tease. Okay.
Next question.
The genetic material that entered the bacteria from the virus was. Who entered from the virus? Come on.
This is for Ashinja's experiment.
NT will be like, learn the rat structure. Yeah, don't put. NT is being nice actually.
Now this is a trick to remember this. Like when I used to read that phosphorus, right? Phosphorus is present only in the case of DNA. So DNA will have the isotope, radioactive isotope. The sulfur is not present in the DNA, so sulfur is present in the protein coat. You just said no in your head.
DNA, very good.
Exactly.
Students, is it a problem that I don't understand Basu sir's way of remembering? Like
I remember it like that. I don't
no.
know why.
Yeah,
I
exactly.
remember it like that.
See, instead of eating like this, he eats like this. Then he explains it to me who eats like this. Like
No. I remember logically. See, that's me.
logic will not fetch you, man.
Logic. What? See, this is how I remember. Phosphorus is present in your DNA. Like DNA structure has phosphorus in it, nucleotide, right? Nucleotide. So phosphorus in this experiment, that isotope will be present in the DNA, and then the sulfur is not present in the DNA, so sulfur will be present in the protein coat.
Okay.
That logically you should remember things. If you make tricks too much, 2-minute tricks, now you'll not remember.
Okay, students. Baswa, I'll tell you exactly what. Students, please type in the comment. Baswa sir makes solutions for problems. So, Baswa sir makes problems for solutions.
No, this is how you should logically
Wait, I'll
remember
write.
things. You should
Baswa
logically
sir makes
understand and-
problems for solution. This is how he works.
See, this, if you remember now, will you ever forget now? Will you
Students,
ever forget
please
to
put
make-
this. Please put this. Please put this. Baswa sir makes problems for solution. Usually for solution.
See, this is how you should be. You should learn logically. Like, see.
No, Baswa sir makes solutions for problems. Oh my god, I am gone. Students, ulta.
This is also wrong. See, this is what happens when you don't use logic. This is what happens when you don't use logic, okay? Use logic.
Okay. Okay, students understood, no? This went galti ho gaya. Solution. Okay, I'll figure that out. It's they grew virus who? Okay, yes. They grew virus that on a medium that contained radioactive dash to trace DNA. They problems for solution. No, solution problems for solution. Yes, correct. Problems for solution.
This is what happens when you have a lot of tricks. See, I'm telling you, you can have mnemonics for 1 or 2. The more in the exam, if you think you'll have a trick, you need a trick to remember the trick in exam then. So don't have too many tricks. Use logic. Yes, Gopika ma'am make those problems.
No, students, when we teach, we always tell logic, but I was just
I know.
telling, let's not complicate their small cutie brains. Okay, phosphorus, yes, everyone knows.
If you knew my logic, you would have told this answer very easily. Right? If you know the logic, right, you would have answered this very easily. So they grew virus that on the medium that contained radioactive phosphorus. And phosphorus will only get into the DNA because DNA structure has phosphorus in it.
You think I didn't give this explanation?
No,
Molecular
no,
basis
no,
of
no.
inheritance.
My explanation is this.
Okay, next question, students.
Next question.
Finished our tug of war is over. We will continue. The search for genetic material was not answered until it was proven that dash is the genetic material. Very easy. Come on. Who is the genetic material? Yes, P32, S35.
See, everyone is saying, sir.
Correct. Dr. Sid. Perfect.
Mona is telling right.
Basar sir took it personally. I was chumma telling.
No, not RNA. Yes, it is not RNA, it is
DNA.
DNA is the
Genetic material. That was only the way that they could, find out further about the DNA. Why it is the genetic material? Is it going through the criteria of genetic material?
Like, there are many criteria, right, when you're trying to find.
Yeah, 1 second. I'll check if their attendance is marked.
No, check, ma'am, check. Someone is typing photos and this is for no reason. I don't know why.
Puchuk.
Next question. Radioactive phages were allowed to attach to dash bacteria. Easy question. This is the organism they're asking, ma'am, here.
Okay.
That is, here it is E. coli. Okay, there is the E. coli is the organism here. Next question, ma'am. The experiment that concluded DNA is the genetic material and not the protein was conducted by dash.
They didn't like.
They don't like them. They don't like them.
Will not come next week. Okay. The experiment. Okay, what was happening? Yeah.
Next question.
Next question. Okay. Students, like the session quickly.
The experiment that concluded DNA as the genetic material and not the protein was conducted by.
Very, very amazing experiment that literally made a crack in the
They
entire
shut everyone's mouth.
community of biologists and zoologists because everyone were trying to work on it. So that is Hershey and Chase.
Yes.
And it is a very usually asked question also.
And remember, even after doing such experiments, they will not all the scientists were convinced, right?
Yeah, every McLeod and McCarthy experiment completely was there. Because it's very confusing, every McLeod and McCarthy experiment.
Next question, ma'am. Can you read?
RNA is the genetic material for certain virus like dash virus. RNA is the genetic. You can give example of any of that.
Yes.
Some friends who think they are so brilliant marking 2 marks question to 10 marks. Madhumita just roasted you.
It's fine.
We take good criticism, not bad criticism. Yes, HIV, tobacco mosaic virus is the one given in your textbook.
That's why tobacco virus.
Yes.
Next question, ma'am.
Let's go. The two chemical differences between DNA and RNA involve the sugar present and the absence of dash in RNA. Something is absent, no?
A missing factor is there in RNA.
Yes. But instead someone else is there.
Uh-huh.
Come on. Oh, to make Baswa sir happy.
Yes, COVID.
Yes, very good, Dr. Sid. Thymine is replaced by what?
Thymine is replaced by someone else. Don't virus.
Rhino, I meant. I think
Right.
ulta would be.
Cold, no?
Students, thymine is replaced by what? Thymine is replaced by who?
Uracil, yes.
Very good. Okay, very fast at typing. A molecule that acts as a genetic material must fulfill the criteria for dash and dash.
Expression.
Yeah, scope of mutation and expression.
if I remember my teacher, okay, when she was teaching this, she used to tell how did you select when you're going for when you're trying to select a wife or husband, what do you see in them? First thing, everyone sees, are they financially stable?
Oh, is it?
Right, they check now if the guy is
Ah.
financially stable or the girl is financially stable.
Yes.
Next, they'll tell how is they mentally stable.
Nowadays, you have to check that on spot.
So
Mentally
all
stable.
that, I feel she has many tricks like that. I don't remember some of them. That's how I remember this class 12.
Oh, yeah, yeah.
Yeah.
It's like how a
Are they
person
able to-
stands for
are they able to
election.
replicate also. That's what she told us.
Come on, students.
Yes.
Very good. Replication and stability.
Stability.
They haven't heard.
Also, they should be able to adjust. So they should not be reactive.
Yeah,
Remember
yeah.
how DNA is less reactive than the RNA.
Like how sir reacted when I teased him.
So they
Okay.
should not be reactive at all. All that adjustable.
Okay.
Next question.
DNA stability DNA stability is partly due to the presence of dash instead of uracil. Very
This is
easy.
the question.
You actually tell stability and partly continuously.
Stability and partly.
Nice.
Stability partly.
It became party. Party in Tamil is grandmother, I guess. Govardhini. I'm sorry if I don't pronounce your names right.
Yeah.
I know it's because I had a friend G. G was praised instead of K.
Huh?
Govardhini. So it should be.
This is easy question.
Yes, very good. RNA's world hypothesis suggests RNA was the first genetic material because it could act as both as a genetic material and as a dash. Very good question.
Very good question.
Yes.
Very good question.
Tongue twister. You know, when I talk, thank you, you're welcome. When I talk
Yeah.
for a longer time, like imagine I'm taking
become
morning
gibberish.
class. Yeah, full.
I know.
I-
Same.
Last time I wanted to tell, okay, students, let's continue. I told something and all that I can't even remember now.
Remember when I was teaching biomolecules, after 5 hours, I'm saying tomorrow. But the words are not coming out of my mouth.
They don't understand because we're talking for 4 hours, so it's very difficult.
The tongue
They
becomes
think, what is this ma'am telling? I talk with my friend full
10
night
hours,
till morning.
Full night at 10 hours to go on a call.
Till morning 4 o'clock and you can't talk for 4 hours.
That is it acts both as a catalyst.
Students, all of you answered very good. Very
Now,
good.
Quickly tell me an example for this. So when I was teaching you about proteins from biomolecules, I told a line that every single enzyme is made up of protein except one enzyme which is not a protein. Yes, I told you about ribozyme. That also can be used here as an example because it is a ribozyme which has a catalytic property as well as the protein synthesis.
Yes, students, can we make it 200 likes? Come on.
That's how you connect the chapters, ma'am. Like
Yes.
because this
And bio is everything. Foundation.
Especially
Foundation.
biomolecule is one big foundation for this chapters. All of these.
Yeah. True. The dash model for semi-conservative DNA replication. What is the model?
The scientists basically.
Scientists who came up with the semi-conservative DNA replication.
We're doing ribozyme still.
Yeah.
Students, share the session. We want to see 100 plus students, and we will put on duel. Yesterday was fun, ma'am. Yesterday was fun. Yesterday on the Wave platform, I had a bunch of fun. Like
Any of you
Dole,
missed.
shower is coming. Something is happening.
Okay.
No, not Michelson and Stahl. It is Watson and Crick.
Very good, very good.
Watson and Crick model.
Student Michelson and Stahl did the experiment to prove if DNA is going to replicate by semi-conservative
Conservative
pattern.
method.
But Watson and Crick already had informed. See, if you do not inform, how will we do the experiment? Blindly, we can't start the experiment, right?
True.
So that's the reason Watson and Crick. Okay, it's a confusing question. So those who got wrong, please. The specific pairing in DNA replication is due to the base pairing rule, also known as. Okay,
A scientist.
scientist, or you can one more name is there. Yeah.
Name is there.
Yeah, normal name. Come on, tell the answer. Such a big sigh.
Yeah.
Chargaff's rule. Yes, correct. Or other
Also
word?
called as Chargaff is also called as
One.
complementary.
Yes, very good. Who told?
Anupam.
Speedy. No, Anupam, huh?
Yes, Anupam.
Anupam.
Anupam
Complementary. Yes,
This
complementary
complementary
base
base
pairing
pairing
or
rule.
Chargaff
Chargaff
rule.
rule.
Okay.
The type of DNA replication where each new DNA molecule has one parental and one new strand is called as dash replication.
What type of replication?
Easy.
Yes, come on, come on. Sharath wants menti quiz from you.
We'll give.
No, you, only you.
Okay,
Sir, give us menti quiz. But every class is one quiz only for us. Students, sir will give you menti quiz. Semi-conservative. Very good, very good.
The experiment that demonstrated DNA replicates semi-conservatively was first shown in. Now, this is the.
Where your answers come. Okay,
Yes.
this is where your answers should come.
Yes. Now, this is where I feel everyone will go wrong.
No, no.
Yes, they'll go wrong.
Tamil Nadu staff psychologists have to do. No, Diksha. Shreyas.
Shreyas.
Yes, see they got.
E. coli.
Oh,
Exactly. E. coli. Message stand where the.
people who did it, students where.
See, it was shown in. They're asking about the organism which was shown in, and it is the E. coli Escherichia coli.
Yeah, Message style is
I
wrong.
remember I used to be so scared when working with E. coli. Like I used to keep washing my hands, go out of the lab, wash my hands and come back again, then sit again in the lab, do the work. Again, go wash the hands again. Because it was so the germ thing now when you're doing the microbiology experiments.
Yes, yes. Okay. Avery, MacLeod, and McCarthy experiments showed that the transforming substances was not protein or RNA, but
it was dash.
who? But who?
Spelling mistake, it's fine.
No problem.
No
We
problem.
know that you know.
Remember in NEET exam they'll not check your spelling mistake.
MCQ. Just put tick and come. No, OMR sheet. Yes, DNA. Very good. Next one.
Now here I remember ivory sounds like the ivory from the elephant. Like that's so. Then we have McLeod sounds like McDonald's. McCarthy sounds like one car. I used to think about all these things.
MacLeod was very connected to McDonald's.
McDonald's.
Always think
Yeah. And I used to become hungry after saying this.
Now I'm hungry. Why did you walk? Let's not eat. No junk.
Next question.
Matthew Messelson. Okay, Messelson and Stahl performed the experiment in which year? Which year?
Yeah.
Year.
Not they'll think yeah.
Please take this photo and tell Gopika ma'am feeling helpless.
Yes,
Oh, crazy. Crazy. He answered fast. No, year.
See this. Cursive handwriting I've written.
Yes, 1958. Yes, correct.
Next question, ma'am.
N is the heavy isotope of. Very easy. N is the heavy isotope of.
Yeah.
But then, tell me the two types of heavy isotope and light isotope used in Messelson and Stahl experiment. Let's not make the question easy. Tell me the two types. First, which one was used? Second, which one was used?
Starting, which one you used? Starting.
Yes.
Was it 14 or is it 15?
1895.
Oh, I thought you were saying 18, 19. I said 15 and 14. Nah.
Very good, Dr. Sid. Very good, YS. Very good, Arush. It is N15 and
Initially
14.
it was, everything was
15. Then?
And then they shifted to.
Yeah, that question also is there.
Is there?
Yeah. Oops.
The nitrogen. What was the gradient used in Messelson and Stahl experiment using?
That means what is the gradient? That using what is extra? Yeah, Arush is like, as in like, traffic signal stop comes, no? His names are popping up. I'm like, oh, what's happening? Students, tell me what was the gradient used in Messelson and Stahl experiment to do the differentiation? Yes, crazy dude. Very good. CSCl or cesium chloride. Yes, yes, very good. The DNA extracted from the culture after 20 minutes of E. coli division showed dash density. 20 minutes. That means so. First N15 say we did.
That is normal condition. Then
Normal condition. After that 20 minutes.
so what is 20 minutes, students? Why they think 20 minutes?
Oh,
For the
E. coli.
replication.
It's actually less than 20 minutes.
It's 18 minutes.
18 minutes.
18 minutes.
It's 18 minutes, but then to make it easier for students, they have made it 20 minutes.
Actually,
So
if I remember correctly, then some book was written 38 minutes also.
Really?
Huh. That is some different strain of E. coli where different enzymes have been used or something.
Yes, very good. Hybrid
Great.
or intermediate, right? Yes, good. Oh, same words and all they used to. If E. coli was allowed to grow for 80 minutes.
See, first is 20 minutes, then we had NCERT says 40 minutes. But NCERT does not show 80 minutes, right? If E. coli was allowed to grow for 80 minutes, the DNA would show portions of dash and dash densities.
Yes. 18 minutes for division, 20 minutes for replication. No, 18, not 16, 18. Okay. Yes, come on. 80 minutes, students. 20 done. 20, you know, hybrid you'll get. 40, you know that something you'll get. If I tell this, you will get the answer for this. 80, you should get something. What is it? What is it?
Light and hybrid.
Wow, Shreyas, he is so sad
Shreyas.
telling the right answer. He's like that
I'm like, hey,
humble.
it's very easy. Very easy.
What are you asking?
Okay.
Light and hybrid. Very good,
Yes.
very good. Yes, correct. The process of DNA replication in E. coli takes about dash minutes. Okay?
Easy, ma'am.
Yeah, now we told, no? Just skip.
18 minutes.
Yeah.
See, here NCERT is telling in the diagram it's showing 20 minutes somewhere.
Yeah.
Right in text is showing 18 minutes if I'm not wrong.
No, they changed it. I think everywhere it's showing 20 minutes.
Huh?
I think only in diagram they're showing and teachers explain actually. The replication fork in DNA replication has a leading strand that synthesizes DNA in a dash manner. What manner? It's cold, yeah. Oh, it's in 30. Why is it not still? I'll wear a jacket. Yeah, no, it's cold. Still, this students, 1 second. Yeah, I can't write anymore. Yes, correct. Students, it is continuous. We are feeling very cold.
The AC is not reducing from that time. I'm like, why is it not reducing?
We can't write anymore. Our hands have gone numb. Okay, yes, continuous. Very correct.
Continuous manner.
Yes.
The lagging strand question is there. Right?
Yeah. The lagging strand synthesizes DNA
in dash manner.
dash manner. No, still it's cold. Since we Bangladeans cannot tolerate a lot of cold because we have never
Often, like-
experienced. Yeah, we are like the moderate people. Even if little that side, this side it moves, no, then gone.
We're just for namesake thermoregulators. We are not thermoregulators at all.
Yeah, total discontinuous. Very good. Very good.
Okazaki fragments question is there, right?
Huh?
Okazaki.
No, that's not that. Okazaki fragments. Okay. Students, so what are these discontinuous segments called as? What is this discontinuous segments called?
What is the other name for it?
Other name. Come on.
Heat interpreters.
Yeah, my nose also. If I was to go to Kashmir, I don't know what I'll do.
The dash is a specific region in DNA where replication begins. Good question.
Very good. Okazaki fragments.
Yes, Okazaki fragment.
Your son, we already told ORI.
She told already.
See? ORI.
Very smart.
Krishna
Origin
also.
of replication.
Origin of replication.
Next question.
The enzyme responsible for unzipping of the DNA strand. Okay? So DNA strand is like this. I remember. Don't tell.
For supercoiling. Supercoiling. Helicase for
ORI, correct. Origin of replication, correct. Next question, students. Look here. Which is the enzyme that helps in unzipping? Unzipping. Madhumita, very good. Helicase.
So helicase is the enzyme will help in unzipping, but so DNA doesn't actually look like this. It'll not just this, it'll have supercoilings like this.
Yeah, it's
Hopefully completely ball like shape.
like, you know how it looks in prophase phase.
Yes, like that. And students, if you want to see the actual, microscopic image of DNA, cell division, I will show in my live class because I have images from my college days where I've done the proper experiments. Every single, when I'll be teaching you cell division chapter, that time I'll be showing the microscopic images. Now the enzyme which is responsible for the reducing the supercoiling is topoisomerase. From here it is helicase.
I taught this as a story.
Huh?
Yeah, one next level story. Girl, boy.
Only you know.
Yes, okay. Next one. Huh. The Lac Operon model has two types of gene. What is that? Shall I write the box? Pipo, Pipo,
People. Huh.
Pipo, ZYA. Who is this? Who is this? Pipo, Pipo, ZYA. Yes, yes, Sharath. Full story solely. Molecular basis is full of story. Come on, come on. No, I think it's a lag there.
Yeah,
No, it
small
should
lag.
be here faster.
The Lac Operon model.
The Lac Operon model has two genes. What are this? Still cold, no? Should we off it or that will be too hot? We can never find it. Very good, Deepak. Pippo ZY8. Pippo is correct, na?
Yeah.
No,
One-
go a little back. 1 second. This is regulatory gene. Okay, because I gene will regulate. Only if I gene decides that, okay, inducer, like operators say inducer does not bind, then only these people will get activated. Otherwise, they'll be sleeping. Structural gene. Got it? Yes, good job, good job.
Next question.
Okay, please.
The promoter region in DNA is responsible for dash the process of transcription. What is the work of promoter region?
Yes, promoter.
And also promoter, right? It is the same region which has adenine thymine data box.
Like origin of replication, same. Origin of replication happens in where adenine and
The thymine.
thymine is there because two bonds, easy to break.
Easy to break. So it's also called as data box. Like
We remember that we do this box like this in MSc and all.
MSc, exactly. The upstream,
that's-
downstream, then
yeah.
the data box. Then you have one more sequencing after data box. Students, you are learning DNA replication or transcription for 1 page or 2 page.
study
But
it as a whole unit.
but actually the DNA replication you need to study. It's going to be for 3-4 pages, and transcription is for around 5-6 pages, right?
One unit.
One unit used to be on transcription alone.
Yeah.
Every single, like, you know how RNA polymerase comes and binds enzymes.
One unit.
And if the RNA polymerase is coming, sitting, when it's sitting, it has to properly bind, like nut screw, it has to join there. Oh God.
Yes. Students, don't worry. Lot of questions we'll do today. We have good questions because we only
That is
sat and
initiation.
modified. Yes, very good initiation. Next question. During transcription, the dash strand of DNA is one that is used as the template. Yaar, answer to hai. Answer is there. Answer is there.
And here the funny part is something called as coding stream does not code only.
But you know, the coding strand and the mRNA are opposite. Matlab, the uracil and thymine difference, but they are the same.
Same.
And you know why two mRNAs are not used? Like why not both the strands of DNA are not used? Yeah, because even when they form mRNA, they're going to be complementary to each.
each other, they will coil.
Yes. Yes, totally.
You guys learned all this.
That's why your guys are masters. Yes.
The thing is, we learned it in like that the level used to be so different. Like this is like so nice to read actually.
We feel nice teaching this because when we used to learn, my God, all full solar system we could see. Because it's all imagination, students. It's not like, you know, our books that, and we don't have books. We just have lectures. We have to write lectures.
everything.
Whatever teacher says, we have to visually imagine. Now we give you tricks and all. There we didn't have anything. We could
And-
not even ask tricks. They'll be like,
What is
postgraduate.
graduation?
you are
I
going to
still
do PhD.
remember my bio teacher, botany teacher. He used to never give us diagrams, and he never allowed us to draw diagrams from the internet or textbook, anything. You know how you're supposed to draw the diagrams in MSc? You're supposed to look under the microscope. Look under the microscope, and what you're observing under the microscope, read anatomy, not just like, you know, cell structure, anatomy, what parenchyma, collenchyma, sclerenchyma. You're supposed to draw from the microscope.
And you know, we have done dissection of almost so many things like
Ah.
fish, prawn,
Everything, no?
frog, and all was
I remember
banned.
used to keep,
Cockroach.
I remember all of you keeping crabs also. I came to zoology lab one day and I'm seeing crabs there.
You won't believe we sat and waited for cockroach in the college because we had to bring next day cockroach. Very difficult.
It was fun.
Okay. Yes, but it was fun. I
During
miss college.
transcription, the dash strand from the DNA is one.
Students, you people have told 3 dash to 5 dash. Tell the name of the strand. Template strand or coding strand. Template strand. Okay, next number will come. I think next one is that. The newly synthesized RNA is dashed to the DNA template strand. That means I just told that. I just told now. Oh, hello, aimless game. Aimless game. No, I have not grabbed a frog, but I have touched a frog.
Even I've touched.
Very good.
Yeah.
Bro, they're very slimy. The moment you
I
touch
know.
one, they will jump off. And they don't have any aim where to jump, what to jump.
Jump.
Correctly,
On the face
between the leg only they'll jump, or on the face only they'll jump. Students, come on, tell the answer. Complimentary. Very good.
Very good. Easy
Very good.
question.
Yes, yes.
The enzyme responsible for adding nucleotides during the DNA replication is direct question.
We are from Christ University.
Christ deemed to be university, which is in Bangalore.
One of the very good colleges.
It's actually one of the top colleges. Actually,
Yeah, yeah.
one of the top colleges
Students,
for.
it's not easy to get admission.
Yeah, it does not get easy to get admission there. Also, we had to go through around so many interviews and 3-4 interviews and write one essays. Writing used to be there.
Ask.
After getting in, also jail.
The enzyme responsible DNA polymerase. Yes.
DNA polymerase.
Yes. The dash unit in DNA is defined primarily by the promoter, the structural gene, and the terminator. What is this three people together? Promoter, structural, terminator together called?
Ligase.
Why are they telling ligase?
Why?
Shouldn't why are you telling ligase?
Racial listing ligase.
No, still not.
Yes, DNA dependent, DNA polymerase. That's a proper answer.
Yeah, DNA dependent. But then NCERT does not say. NCERT actually does not even introduce helicase, ligase, anything. It is just imagination. That one is unzipping, one is binding, one is gluing. Primase will lead DNA polymerase.
The single strand binding
No.
protein.
No,
Single
they
strand
don't
binding,
roll
which holds the two, make sure the unwind doesn't happen back.
Yeah. They never talk about SSB. And I didn't mention about that because earlier in NEET they used to ask that. Now they don't. Because helicase, ligase only is more from the NCERT. That's extra.
See, the thing which we do is we try to keep most of the NCERT topics. We are not here to show off that we know so much. We don't want to do that. We want to teach what is the NCERT because they will not ask you out of NCERT. Here and there, we might teach you an extra concept for your better understanding. That's all.
Students, because very clearly NTA told this time that we want to reduce the number of suicides and we want to reduce the number of pressure, the amount of pressure that we have been giving students for this many years. Finally, they realized. Okay,
Yeah.
so that's the reason why they are like NCERT. It's not about how much a teacher knows. See, a teacher definitely knows a lot. Because see, when we did also post-graduation, now you are studying only Sanger sequencing. We learned the entire sequencing. We have done it in the labs. We have seen polymerase chain reaction. We have done gel electrophoresis,
We have done
DNA
PCR
fingerprinting.
PCR also we have done.
We have done that. Forensics we have learned.
We
So
used to sit 7 hours in front of PCR machine and wait for the thing to happen.
Exactly.
Sit there. Microbiology, entire microbiology we have done.
yes, we know E. coli. We know about all the rhinovirus, fungus, whatever. But that's not important for you. Okay. Yes. The two strands of the DNA in the structure of transcriptional unit have opposite polarity and the DNA dependent RNA polymerase catalyzes polymerization in only one direction. They're just asking you the strand number. Okay, strand number. Got it, students? Yes. He's singing. Oh, Arush. One is giving us trophy. I wish, in college, if they gave us trophy for all this, I would have cried for 2 days.
I know. Oh, why will you cry?
Because I'll be so happy that they at last complimented us. They never appreciated. Yes, pi dash to 3 dash. Correct. Yes.
It's not
Next
all
up.
this, na?
Yeah.
That's why they know. Otherwise, no.
The strand that has the polarity 3 dash to 5 dash acts as a dash and it is also referred as template strand. Yeah, skip kar do. Same question. I think I removed this. I don't know why it's come back. The other strand which has the this is not there. The other strand which has the polarity 5 dash to 3 dash,
This is the first one which you just told. The one which is below here from 5 prime to
which will not help in transcription, but it has the same complementary to mRNA. Come on, everybody. Why?
It is called as
Where's our students? Yeah, we can also see.
some A something.
Subhashni, Sanvi, YS, Crazy Dude, Sharat. Where is all of you?
All coding.
Coding
Exactly.
strat. Yes. Now it's hot.
The sequence of RNA transcribed from the DNA is complementary to the dash strand. Very good question. Easy question. You should be able to answer this one. From which particular strand we getting the RNA? See, when you say DNA to RNA, what is getting transcribed? Which is the coding? No, it's not the coding.
I think they're in the before one.
Yes.
Jaya Ganesh.
Share Ganesh.
Students, we saw a lot of new students. Yaar, come on, subscribe to the channel and hit the like button and let us know.
So many.
Join us on our regular class.
Samriya, Deepak.
So many new students. No, Rani. Maybe they. Students, do you watch our sessions recorded?
Have you seen a session recorded? Because live we have never seen so many names.
Yeah.
But yes, it's good to see new names.
Students, tell us quickly.
This is a template. This is easy.
Next one. In the schematic structure of transcriptional unit, the dash flanks the structural gene at the upstream end. My God.
This is the hand here.
Okay.
What do you have here?
Why subscribe? Because Arush, we are taking the effort to give you so many things for free. That's the bare minimum you can do, students. Why subscribe?
I recorded it in 2x. They're watching my session in 2x, sir.
Yes. Subscribe to the channel. Come on, is that too much to ask for?
Yes, Sanvi, it is promoter.
Yes, very
It is the
good.
promoter here. Upstream, this is called upstream. This is the
Downstream. So, upstream, I think that question is coming. If I tell off the answer, then it's gone. Yes, see. At the downstream end of the coding strand, you will find dash. What will you find in the downstream?
See, this is the, again, downstream of your coding strand. Downstream of your coding strand, they can also ask question as, at the 3' end of the coding strand, what is present? Also, they can ask
Yeah,
you.
yeah.
Yes.
He's still in shock, Papa.
Why is he shock?
From that type, from our PCR, so he's in
Oh.
shock.
Somebody will also do PCR.
We wanted to show them, no, the videos and all that, but then
Yeah.
I forgot to take everything when I was in college.
But I am actually uploading. Today, did you see on Telegram, I uploaded on, what did I upload? No, Colorado roots. I uploaded a photo of Colorado roots. Yesterday, I uploaded a photo of sporophyll because I teach them sporophyll and everything. Then I've also shown them different types of algae under the microscope. I've shown them different type of bryophytes under the microscope. Today, Markensia also. I showed them a live image of Markensia on the Telegram channel. So join the Telegram channel. Join the Telegram channel where I'll be showing you small snippets, small here and there, what we have studied, which will also help you to visualize better.
Yes.
Okay. It is the terminator.
Very good. Next one. The DNA sequence that provides binding site for RNA polymerase is called as. Who is giving the binding site? Yes, binding site.
Where will the RNA fly and come and sit?
Yeah. Where will it fly in?
RNA polymerase.
Be dancing and coming like this.
One question, brilliant question from here, if I remember correctly. I'll ask. Which enzyme is responsible for unwinding of DNA during transcription? This question was from like around 3 years back, NEET, and everyone wrote helicase.
Okay, because they didn't
Read the transcription. They didn't read the transcription part. Everyone wrote helicase. Answer was your RNA polymerase, because RNA polymerase, when it is going and joining, it is also unwinding your DNA.
Otherwise, transcription cannot happen, right? Template.
Exactly.
Okay. Okay. Students, cockroach is coming. Please, cockroach is coming. Insect is cockroach.
That was a NEET PYQ like around 4 years back, ma'am. Very good question. Very good question. It is just one line of NCERT. They took one added question.
The only way to make molecular basis of inheritance difficult is manipulate the grammar.
Like the grammar.
Because terms, everything students will know. Just they cannot understand the grammar. Okay. In bacteria, RNA polymerase binds to the promoter and initiates transcription, a process that begins with dash phase. Okay. Yes. Arush, did you subscribe? Then I'll take your thanks. Come on, subscribe. He asked me why to subscribe.
Yeah, I saw the answers on the Telegram channel, Colorado Roots. All of you answered. Yes, it is initiation.
Yes, we made good
Initiation
students.
phase.
They made it 208 likes.
Next question, ma'am.
The process of transcription in bacteria includes which 3 major types of RNA? Only 3 are mentioned in your textbook. That 3 you should know.
Here I should remember.
Sorry.
I had a trick here also.
For remembering the RNA polymerase also.
Yeah.
I remember, actually one of my ma'ams had taught me.
RNA polymerase 1, RNA polymerase 2, and RNA polymerase
Polymerase 3.
3.
Okay, now there is one
My
way.
li-
MRT or MTR something.
No, my life, okay,
Yeah.
took a right turn after meeting Tanya.
Students, ask who is Tanya. I have no idea.
Even I have no idea. So my
RMT, RMT, RMT.
RMT.
So,
So
when I worked in college, the HOD of that place, like HOD, like very senior ma'am, she taught me this when I was going for a class. No, I was like, how to remember, how to remember. I have to give a trick. And then ma'am told me, this is the way to remember.
I remember this. My life took a right turn after meeting Tanya, like RMT.
Students understood what you should do. Never meet Tanya in your life. Then like sir, only right turn you will have to do.
See, right turn is good, left turn is bad.
Can't predict. Yeah, after right turn. Not Tanya, Tanya, T.
T.
Okay, T.
T. See your RNA polymerase 1 act on R. You tell me.
RRNA. Okay, RNA polymerase 2 will act on mRNA. RNA polymerase 3 will act on tRNA. Okay, tRNA. That is the way to remember.
Yeah, and these are the 3 different RNAs here.
Yes, very good. Next one. The RNA polymerase in eukaryote that transcribes rRNA. See, the question
See,
came.
the question came now. If you know my trick, you will be able to answer this question very
It's a
easy.
good trick. I totally agree.
Nice.
It's not complicated. Yes,
Ah.
Tanya.
Yes.
Something.
Now use that trick and answer this question now.
Use that trick and ask sir every day who is Tanya. How is Tanya?
Tanya, do you drink water?
Tanya took left turn when sir took right turn. Tanya took left turn.
Yeah.
So, Romeo Juliet did not happen.
Easy question again.
Yes, they told one.
RNA polymerase 1. See, I told you, no? Here. See, RNA polymerase 1, rRNA. Okay?
Yes.
Next question.
Oops moment. Okay. In eukaryotic transcription, the pre-mRNA undergoes dash, which involves the removal of introns. Yes, good job, Arush. Tell mom don't have so much confidence also on me. I am NEET student. What do you expect? Okay. Yes, what's this? Come on. Removal of introns. Removal of introns is called. Very good. Splicing.
And how I remember this is introns interfere. Introns will interfere with the process. So interference should be removed completely.
Yes. Okay.
Even have to I don't tell only tricks, but
Good job. The addition of the 5 cap and the 3 poly A tail to the pre-mRNA is a part of dash processing. Very, very important. Very, very important.
Sai Ram, you see the Malvaceae, what I told you, the example was hibiscus example I've told you. But there are, 3 to infinity, or also it can be from 5 to infinity. See that infinity here ranges,
example, no?
it depends on examples also. The general rule is 5 to infinity. Okay?
Okay.
Now tell me in the chat, why do we need to do this 5 cap and 3 cap A tailing?
Yes,
Why
yes.
is it required? Why is it required? Why do you need to add? After removing the interferons, why do we need to do capping and tailing? Why is it required?
2 reasons are there. You can tell at least 1 reason.
Yeah.
And students, do prokaryotic genes undergo RNA processing?
Very good question.
Thank you, thank you. Thank you. Students, do RNA.
First answer that question.
Okay, sorry. Tell us why you need to do capping and tailing. And second question, do prokaryotic gene undergo RNA processing? You can definitely expect for your PYQs. Okay, such kind of things students ignore.
This is the conceptual based question. No one is filling the answer still.
Wait, I think they are
Transcription
typing.
modification. Yes, it is the transcription modification, but why do we need to modify?
Okay, no, they don't for the prokaryotic one. Correct, correct.
Now you tell me why in the case of eukaryotes, capping and tailing has been done?
Yes. Students, I have mentioned in my class. Come on, tell me. To move,
No.
no.
No, not the answer. Not the answer we're looking for. Samria is almost there.
Samria.
Samria is almost there, but no.
Something similar but not
Yes.
to the point. One word is wrong.
I'm still waiting.
No.
Split genes also somewhere there.
Split genes correct. Exon, introns correct. To make the mRNA to proceed
No, see that is happening. See, splicing is happening because introns are not required. After
not
unnecessary,
sequence.
after splicing is done, why do we do capping and tailing?
I think you should tell, sir, because they don't know the answer.
Do you know what is restriction endonucleases? Do you know what is restriction endonuclease? If you know the answer, you will know what I'm telling here. If you don't-
Just to make sure that no interference happen, like nothing is interfered, and also to mark the ends. Because 5' and 3' end will not be marked in the newly formed mRNA. It is like a new baby. No name is given. Only once you give a name, the baby has an identity. Same way, only if you do a capping and tailing, you can mark it as 5' and 3' end. That is the second reason. First reason is to make sure that the restriction endonuclease does not come and trim and biological scissors.
Exactly. That is
Clear?
a very good question. This can be a, I don't think it's a PYQ, but I think you will learn this in the biotech chapter.
Yes, we have to do biotech. Next
You
question.
do or should I do biotech?
We'll see. We'll play Audible.
Audible. Good. That's the beauty, right? We don't decide initially like who will do which chapter. We just
The structure at the end of a eukaryotic pre-mRNA that consists of a string of adenine nucleotide is called as
a dash
dash tail. Dash tail. Yeah, why are they only thanking you? Even I told the information. No. Sir is easy to type. Ma'am is so difficult to type.
they don't write the apostrophe, no? Very difficult.
Yeah, very, very heartbreaking. In my session, they'll be like, oh, ma'am, hi, ma'am, beautiful ma'am. Sure, they'll like, sir. I'm upset.
Easy. Poly-A-tail. Easy question. No. The completed mRNA transcript after the processing has a dash at 5' end. I predicted this. Easy
telling-
question?
Yes, welcome. Sharath and YS, we are one gang.
Who is in my gang then, ma'am?
That Jaya Ganesh.
Jay Ganesh is my gang. Yes. Jay Ganesh is my gang. Yes.
I have more gang people. We'll make a big gang. Mafia.
And then you attack me, no?
Yeah. A Kuti Mafia to attack only Baswarath, sir.
This is what happens to the botany minority all the time. Every student I've seen, whoever I spoke so much, everyone says zoology. Very few students who actually love botany, but my aim is to make sure a lot of people love botany.
After my botany class, you will love botany.
This is the capping at the 5'
Okay.
end.
Yes.
Next question.
A dash is a DNA sequence coding for tRNA or rRNA molecule, also defining a gene. Very good question.
Very good question.
Very good question. Come on, answer. Okay. Yes. Trust issue.
Thank you so much. Mom is coming now.
All my gang. Kutti Mafia will make against you.
I'm even more kutti than that.
That's why I told Kutti. Many are not joining hands here.
Cistrons, yes.
Very good. Wait, let others also tell, no? Only 1% told. I think many are thinking.
No, they know that as typing stuff. They know.
Cistron.
Full confidence.
Cistron is a sequence. It's a sequence that is actually helpful. Other things are useless. Okay?
The dash gene in the transcription unit could be said as a monocistronic or polycistronic.
Very twisted question.
Good question.
Very twisted question. But only thing that you need to remember is they are the only useful part. So which is the useful part? Out of all, which is the useful part? Now let's see who is going to answer it. We need to applause. We don't have no dole on this. I missed that. Wow, we made GMAites. Like Christites. Ooh, Sharath! Proud. Proud. Azwan. Very good. Ooh,
Structural, exactly.
very good. Jai Ganesh, Sanvi, Malar Kodi, Anupam, Subhashni, Ramakrishnan, Govardhini, Rachel. Rachel? Krishna.
This a segment of DNA that is transcribed and includes both exon and introns is called as.
Yes. Again.
Easy question.
Easy question.
Yes.
Students understood structural gene. Easy question, no?
Easy question.
Cistron means the part which is useful. And structural gene is the only region which is going to make the mRNA. Entire 2.2 meters, if they become mRNA, what's the use?
Exactly.
Right?
Deepti is asking victory mock test syllabus. You will be knowing it in the Telegram channel. Okay.
Students, this week the timetable is not out because we are doing NCERT line by line for the till Friday. Right? And
Because
Saturday.
it's a challenge. Shreyas sir,
Yeah,
what
it's a challenge. It's a challenge to complete. Why we are doing it is not like we are challenging ourselves. Oh, every day you wake up at 5 o'clock and start preparing questions. No, it's a challenge to make sure that we complete 12th portion. So if there is any board students, it will be helpful for them.
And this is a good revision for NEET aspirants as well. So Shreyas sir came up with one genius idea where it'll help both NEET aspirants where we understand every line of NCERT and board students who's writing the exam also.
That's why he's a captain,
Yeah.
not chumma.
Hmm.
Yeah, students told H and RNA. Wait a minute.
Huh.
What is the question? Go back. There's no. The segment of DNA that is transcribed and includes both axon and oh yeah. H and RNA is correct.
One second, can I get some water?
You fill it. I'll do this for 2
2
minutes.
minutes I'll be back.
Yes.
2 minutes I'll be
H
back.
and RNA is correct, students. Sorry, it's not transcriptional unit. Okay, it's our mistake. The term dash refers to the addition of a cap to the 5' end of mRNA. That means what is the process of adding? Okay, what is the process? Yes, 2 birds, 1 stone. Yeah, evolution is very boring. I'll sleep off, I have a doubt. Vasha, yesterday it happened on Wave. You can go and watch, is what I believe. Okay? Yes. Capping, very good. Capping. Ooh, did I show the answer? No? Yeah. RNA polymerase 2 transcribes precursors of mRNA, the dash. Students, try to, yes, methyl guanosine capping, very correct. RNA polymerase 2 transcribes precursors of mRNA. That means what? Before it becoming the original mRNA, it had something. It had this khichdi, no? That khichdi's name you have to tell.
The answer you were telling when I left.
Yes, correct.
Yeah.
Perfect. I have to take evolution, they're punishing me. Such a boring chapter.
I'll take evolution.
They'll sleep off from it.
I will make sure the evolution becomes like this for them. I'll tell one amazing story to you. Evolution.
That students, one of us will take evolution.
Don't
okay?
worry. We'll not run anywhere. We'll make sure the
We'll just tell it's boring. We should be honest, no? We can't be like, oh yeah, every chapter is beautiful. Why I made the textbook or what? So, I have the rights to tell against. Yes. The RNA polymerase 1. Okay, change. We did this. Okay, in capping of H and RNA, an unusual nucleotide dash is added to the dash of the hRNA. Okay? Okay, we'll do evolution. Don't worry, one of us will do.
Ma'am, they want ma'am from only.
You both are sister brothers. Yes, we are.
I call her bro only all the time.
Even I call him
Bro.
no gender. Yes, we are sister brothers from different mothers. Whoa. Actually, that's already existing. Baswa sir?
Yes. Almost. Okay.
Wait, what is he trying to write in Kannada? Okay. Yes, 5-end and methyl guanosine triphosphate. Very good.
Questions have been repeating. This pattern has been repeating.
Huh.
During the tailing process, the adenyl residues at 200 to 300 are added at dash in a template independent manner.
At which end?
Yeah. This is the question.
Oh, yeah. We were standing only.
Exactly.
Pavam students. They're like, ऐसे
They're like
मुड़ के देख रहे मुड़ के Don't mur- my Hindi after seeing this, no, someone will teach me Hindi for free. They'll be like, please don't pay any fees, please learn Hindi.
try teaching in Hindi also someday.
Yeah, हो जाएगा.
That is a pre-primary, easy
Yes,
question.
very good. Oh, beautiful. Okay, next one. Genetic code is nearly universal. For example, from bacteria to human, the codon U.
You know, humans, we have not gone after Mars also. We think it's universal already.
U. Codes for dash. 3' correct. Good job. 3' Thank you.
Thank you.
What is the answer? Yes, very good.
Phenylalanine. Alanine.
We are. Should I tell the answer?
I showed the answer, no?
No. The question: how can I always like both of you, ma'am and sir?
Just like me, don't I?
Just like him, don't like me. No, students. Just we are like friends to you people, brothers, sisters. The codon for initiation of protein synthesis is, what is the start
Hold
codon?
on.
Start codon. Again, we are blocking and standing like two
Ma'am,
pillars.
I remember this.
No need. Leave it.
It's fine. You'll become complicated for all of you.
Yes, Azwan. Very good.
AUG. And AUG is also gun in PUBG, if I remember wrong.
Yeah. AUG. Methionine. Codes for methionine. Yes, next one. The codon is read in mRNA in a dash fashion. What fashion? What fashion?
Them Paris fashion.
Yes, AUG has dual functions. Very good. Methionine. Students, answer this. What
one.
kind of fashion?
Yes. Spelling is wrong.
Where is our Mona? Spelling mistake. She went off.
Very comedy, that's why.
Just be relaxed.
Yeah.
Life is beautiful. Yeah, continuous fashion. Okay.
Yes. Without any commas.
Yeah.
No full stop.
Le-
no hyphen.
Venkata Lakshmi. Contagious fashion. Correct.
Yes.
Oh, come on.
If following is the sequence of nucleotides in mRNA, predict the sequence of amino acid code by it. Take help of a checkboard.
Open your NCERT and see which is the one. AUG, UUU, UUC. You know the answers. That's why we are asking you. Otherwise, usually checkerboard questions will not be asked.
Will not be asked.
But this three they have mentioned in the
Text.
salient features.
Yes.
That's the reason they are asking. Okay, come on, tell the answer.
And why so less students from today? I don't understand.
They ran off. They thought only questions will come till replication. After that, questions won't come because NCERT does not have that much pages.
No, I know. Every single time we start something, we will have we'll have a lot of students who are like full Josh will be there that I will learn every line of NCERT.
Then demotivated.
Demotivated, then no consistency, and after 2 to 3 classes,
Then one day before NEET, they will search on YouTube
how to in one day.
Yeah.
Arush, all of us have it. Arush, all of us also have that problem.
We all have syndrome. Same
Yeah,
thing.
syndrome, laughing
Laughing
syndrome.
We are the
Stop copying me.
methane- What is the laughing gas?
Laughing, yes.
A mutation in a gene that results in a change of a single base pair in the gene for beta globulin chain results in a disease called as. Yesterday we discussed this, but you people are not there.
No, yesterday we discussed the disease, no?
Yes.
In the wave.
Yeah, we discussed the exact structure.
One question was
Hemoglobin.
done.
Yes, it is going to come.
Hemogen project, every single numerical questions are there.
Yes, it's coming.
Everything
Thoda,
is there.
wait.
Yes, sickle cell anemia.
Very
Yes,
good.
That's one.
Sickle cell anemia, correct. Next one. The genetic code is read in groups of dash nucleotide. Come on, be quicker. Yes, sickle cell anemia, correct.
Deepak, you cannot.
No, that's what I told you. This the students who don't have consistency, they'll search last day. How to crack NEET in one day. Okay. 3. The code that signals the end of a protein coding sequence is dash codon. That means who is?
Stopping, but tell us what are the stop codons.
Yeah,
That is
tell
more
us
important.
tell us the stop codons. Don't tell stop codons. Tell us what are the stop codons.
The 3 stop codons.
Yes.
What are the 3 different stop codons? While you answer that question, let me go to the next question, all of you. The next question is here. The exercise of changing the sequence RAM has red cap by insertion or deletion demonstrate dash type of mutation. Yes, UAA, UAG and UGA. Correct. All of you are correct. Now, if I remove this and we shift one something, what type of mutation is that? Anyone who can tell me? Let's wait for a couple of minutes, ma'am. Let them answer. Let's see how many of you can answer. Yes, Ishwant, it is called as frame shift mutation. Very good. It's called as frame shift mutation. Next question, ma'am. Can I read?
Yes, please. You want to read?
Dash is the adapter molecule that reads the codon on mRNA with the help of dash.
Yes, correct. Frame shift mutation. Deletion and insertion will lead to what kind of a it will change your reading shift, right? Normally Ram has a red cap, it becomes something else. Same way, frame shift mutation. Okay.
Dash is an adapter molecule that reads the code on mRNA. Remember, which is that which reads? It looks like an adapter comes.
Yes, with the help of whom? This two people has to come. I told you, if 60S does not come and bind, the 40S with the tRNA will not move. So who else? Who else has to come? Come on. No one told that, no? Not even one person told that.
Yeah.
tRNA everyone told. Second one I want. Second one, students, tRNA with whom? Come on, come on. No.
No.
Come on, come on.
No one is answering.
No. See, don't tell me the sites in the tRNA. If yes, very good. Azwan and Govardhini, very good. Ribosome.
Exactly.
Students, tRNA with ribosomes together form like a lens. I told you, no, they will be like reading the codes. Okay? Yes.
The tRNA molecule has a dash loop that has bases complementary to the codon.
Yes. Now you tell me which is the site in the tRNA
Yeah.
that will
Exactly.
form-
Anticodon.
Yes.
Anticodon.
Understood? Yes. Not maybe. Anticodon.
Anticodon. Next question. The other end of tRNA, opposite to the anticodon loop, has a dash which binds to the amino acid.
Yes. Again, easy.
Easy question.
Now anticodon you told. Now what will be
Opposite to the anticodon.
If this person is not there, polypeptide chain will not be formed.
True.
This is one of the amazing topics. Amazing.
I know.
How tRNA reads, you know. But there's lots in it that we.
What they have told us.
No, I think still they're telling anticodon.
Yeah.
No, students, opposite to anticodon side. Who has to be there? Otherwise, polypeptide chains will not be formed. Protein chains has to be formed. Yes, amino acid
binding site. Hello, Neha.
or
Neha.
acceptor end. Anything. Amino acid acceptor site or amino acid binding site. Yes. The secondary structure of tRNA is sometimes described as dash leaf structure.
I'll give you one clue here.
Lucky.
Good luck.
Yo.
For good luck. And it's also a name of an anime also.
Yeah, I don't know what's her name.
It's called a black clover where we have
Oh.
5-leaf clover.
I know black
Netflix
clover.
would have seen, no?
Hmm.
5-leaf clover.
Yes, clover leaf model. Very good. The secondary. Okay.
A tRNA molecule that is referred to as dash tRNA is responsible for initiating translation.
Yes. Oh, they put the leaf. Yes, correct. Clover leaf model.
The fourth one is luck. Love, faith, and something is there.
Oh, 3 is there, no? That is
3. One is love, one is faith, one is known for
hope.
hope. Last one is for luck. If you have 4 leaf, it's luck. Last one is for luck.
Luck. Okay. Yes. What's the answer?
I showed the answer.
Oh no. Initiator. Not adapter, students. Initiator. I told you, no, tRNA, if the initiator tRNA is not present, the reaction will not happen. So, initiator tRNA has to be there. Okay? Yes.
Next question, ma'am.
The ribosome used... Okay, go for it. The ribosome used in translation in eukaryotes is...
Which type of ribosome? The number.
Number.
Inside work unit.
It has... Not depending on the size. It's a sedimentation factor. Tell me the number. Very good. I'm so proud of all the students who stayed from the starting. Students, you would have understood half of molecular basis of inheritance.
Not half, almost 1. 3/4
Yeah,
is over.
3/4
is over now.
Yeah.
3/4 is over. Exactly 80 years. Tell me also what type of ribosome is seen in the case of your bacteria.
Yeah. Prokaryotes. Yes, 80S. So it is divided into 60S and 40S. Okay? Yes. Untranslated regions found at both ends of the mRNA are referred to as. Okay, untranslated regions. Just
Oh.
70s, correct, for
Correct.
prokaryotes. Prokaryotes 70s. It's divided into 40 and no.
No.
It's divided into 30
50.
and 50, I guess, yeah. Nothing.
Fine. Untranslated regions found in the both end of the mRNA.
It's called as UTRs. Did anyone say? Yes, very good, Shreyas. UTR. Right? Untranslated regions. Yes, next one.
The end of the translation process is marked by a dash factor that terminates the translation. See, I think they will tell the answer. They'll not
No,
tell you
the
the
factor is mentioned, no? So
Ah,
there's only two factors.
factors. They are-
One in the initiation, one in
the
the termination.
termination.
So you cannot go wrong. Factor word is mentioned, otherwise I was actually trying to remove the factor word.
Yeah,
Then
yeah.
I realized they will say terminator.
Yeah. Row factor.
No, no, no.
Yeah,
Row.
this is what I told you.
Oh, this is
what I
what.
told you.
Oh, you
They
told
will-
about the row factor.
Yeah, they will say row factor here.
So this one we have to tell after the row factor. If you see in the paragraph where they put untranslated region, there is one more factor that they mention. At the end of transcription, there'll be one more factor who binds.
Yes.
Very
Yes.
good, Venkata Lakshmi. Release factor.
Release factor.
Row factor is correct, students, but that is during the termination. That means for termination to happen. Here the question comes after termination. There's one more factor to end everything, like
Yeah.
khatam karne ke
This
liye.
is why I told you, they'll go wrong here.
I thought you were talking about terminator.
No.
Release factor. Yes, understood. Good job. Yes, very good question. The regulation of gene expression in eukaryotes can be at level of dash dash dash. That means to regulate the gene, they can only do it during this time. They cannot do it before or after.
Yes.
So what is that? Yes, release factor, correct. Sigma factor is for initiation. Okay.
Sigma.
Termination factor is row factor. After termination, after everything is going to come to an end, release factor will come. Yeah, MCQ will be there. If they give row factor and release factor, which one will you take? That you should know, no?
Yeah, they should know that much.
Transcription, processing, okay.
Translational, one more, sir.
Translation, okay.
Transcriptional, post-transcriptional modification, that including capping and tailing they can do. Then we have transport of mRNA. What is the meaning of transport of mRNA? When mRNA is produced in the nucleus.
No, yeah. It has
So-
to, from the cytoplasm.
From the
for
nucleus, it has to go to the cytoplasm. When it is going, that time also regulation can be done.
Done.
And translational, last one.
Students, you can also say RNA processing. In this post-transcriptional modification, you can put RNA processing also. They can stop there also.
Now I'll ask you one more question here. This is for eukaryotes.
What about?
What about prokaryotes? What is the regulation level in the prokaryotes? They'll ask you a question like this. Now you
Yeah,
tell.
yeah.
Ah,
Okay.
that is
They'll
a
take-
good question now.
Yeah, true. An enzyme called beta galactosidase is synthesized by dash if it is used to catalyze the hydrolysis of a disaccharide lactose. Students, listen to the question. No, transcription, Rani. Translation, you don't use all that. You only have tRNA, ribosome, amino acid acceptor, anticodon. Done. Translation done. Transcription, you use factors. E. coli, very good, Aswan. No, students, yes, they went wrong. Gene, they told.
Yeah.
Students, what is the question? 1 second. An enzyme called beta galactosidase is synthesized by whom? LAC-Z is present inside whom? E. coli.
Organism.
Right, if you're not there, if I'm telling, oh, NEET exam, you will go write. That means who is going to write? You are going to write. No. So that's what. NEET exam does not matter. Who is the person who is going to write the exam? That matters.
Next question.
Now you tell. The dash operon is an example of transcriptionally regulated system. Yes?
Now the answer to the question here in prokaryotes, it's only and only your transcription. Because in the case of prokaryotes, transcription, translation are like, they're together almost.
They are very
It
simultaneous
is.
or like very...
When I say, as soon as the mRNA is coming now, It'll take it up by your for translation.
And there is no H in RNA, there is no processing. Only
Exactly.
during the formation of a split gene, there is a more work.
Otherwise, there is nothing there.
We are a lot of work, students.
This is the Lac Operon.
Yes, correct. In Lac Operon, the gene that codes for beta galactosidase is referred to as dash gene. Do you
this-
understand the difference? Gene.
Now here you should write Z gene.
Okay,
Z
Lac
gene.
Z.
True. Now they'll know the answer.
Yes.
Lac Operon is regulated by a dash that binds to the operator at a specific dash.
Yes, Lac Z is correct.
Let's check.
Yes, repressor and inducer. Did all of them tell?
Regulated by the
Did they
repressor
tell?
protein. Yes, they told, ma'am.
Yeah.
Repressor protein, and the repressor protein will go join the operator, will not work. And this. Next question.
A genetic element that increases the permeability of the cell to beta galactosidase is termed as, or else you can just put the question in this way: who increases the permeability to absorb more lactose inside? Okay.
And here, as ma'am was discussing, I told you it's a leaky system,
Hmm.
right? So this enzyme will be present before only, even before the translation. That enzyme has to be present.
It's a leaky model.
Leaky
Completely.
model. So some of the
Lactose will
lactose
enter.
before even the
Otherwise-
translation begins.
Yes, correct. Permease. Not transacetylase. Permease.
Permease.
That is your lac A will make your beta galactosidase transacetylase, which is not in your syllabus. The genetic code is described as dash because each codon specifies only one amino acid. Yes, permease correct.
Students,
One
how are you-
amino acids.
Now quickly tell us, how was this type of teaching? As in, like, are you liking it? Are you able to solve the questions? Is the revision happening with all of you? Are you understanding every line of NCERT? Quickly tell us in the chat, how are you feeling about the session? Should we continue this challenge or should we stop the challenge, ma'am?
Should we stop it today only?
Today is the last one. Or should we? Yes, Sanvi is correct. Unambiguous.
Okay, students, please answer this question.
Yes.
Very important question. We need to evaluate.
Yeah, if you're understanding, if this is useful to all of you. See, all fun and games on one side,
But
but
on a serious note.
on a serious note, this is helpful to you. Let us know in the chat right now because you're not commenting there. So we do not know if it's helpful to all of you. So let us know.
It's so much fun to do these questions. Okay, yes, you can continue. So really helpful. Okay.
Next question, ma'am.
The Lac Operon includes genes for the enzyme dash, which is a substrate for the beta
Easy
galactosidase.
question, ma'am.
Okay.
Arush, ma'am would have explained you in the main class. Please go check.
Very useful. Okay. I think some of them are finding it useful.
Some of them are finding it useful. It's
Yeah.
fine.
I don't see all of them telling it.
This is an easy question.
Lactose.
Hmm.
You can sit for some time. I think.
Huh?
Yeah. Please.
No, it's fine. It's fine.
No, please sit for some time. After that, you do. In the Lac Operon, the dash binds to the operator region and prevents RNA polymerase from transcribing the operon in the absence of the inducer. Who is the one who will decide the fate of Lac? Not fate actually, but at least the first stops the RNA polymerase from first doing whatever is required to do. Transcription.
Read the question properly.
Students, what are the answers?
Operon, the dash binds.
To
Something
the
is-
operator.
Something is going in bind to the operator.
And who makes, right?
No.
Heredity and evolution, a 10th standard chapter.
Heredity and evolution is 10th standard, no?
Yeah.
I recently thought there. 10th standard, I was literally teaching.
Please send them the link.
Do you want heredity and evolution class 10, Sharat? If you want, I'll send it to you. My link is there. I was teaching yesterday only, not yesterday. Day for yesterday, I was teaching heredity and evolution there.
Yes, repressor, correct.
It is the repressor.
Next one. When lactose is present, it acts as a dash for Lac Operon. It acts like what? Okay, it acts like what?
So, in this case, whenever lactose is present, E. coli will become very active. Oh my god, lactose is present. Now I need to do something.
Yeah.
So the whole genes will start to work.
Come on, come on.
Inducer, exactly.
Good.
Sandhya.
Next one. Next one. The regulation of Lac Operon by the repressor is referred to as dash regulation.
Positive or negative?
Don't say that.
Forget that. Forget that. Is it positive or negative? I don't know. I know it's at neutral. It likes bitter ion.
You just tell them, forget that because they are computers that they will delete the memory.
When is biotechnology?
Pata nahi.
Pata nahi. But will soon. Yes, negative.
Students, first we'll do biotechnology chapters because it's very difficult for us to do it without, teaching. We don't feel justified. This chapter we can because I
See,
finished the chapter.
The reason we are doing this type of series only for your finished chapters, so that is better. But then we'll be doing evolution next tomorrow.
Tomorrow we'll be doing it.
Oh, who's asking? Here. So tomorrow we'll be doing NCERT line by line for evolution. Yes.
Yes, evolution.
Evolution tomorrow, same time, we'll be coming together again like this, and we'll be teaching you evolution every line to line, and we'll make it interesting tomorrow. Okay?
I know. Okay, next. The human, we reached HGP.
So students, do you notice we have almost covered the chapter? We started off with DNA,
Yeah, polynucleotide
chain and everything. Then we learnt about your
Double
DNA
helical
structures.
Then replication. Central dogma. Then replication. Then
Transcription,
transcription. Then translation.
translation,
Now
then-
slowly moving to HGP and
We finished
DNA.
even
pigment.
Lac Operon also is done.
Yeah.
Yes, Lac Operon is also done.
Okay.
Yes, I know evolution has not been done, but tomorrow will be done.
So the evolution we'll do after that. Okay, first
Okay.
we'll do revision. Challenge has to work, na? Challenge has to go. Yes. What's the date? 1990.
Yes. 90.
You were born, no? 1990.
No, I'm not born. I'm not. I was 1990. I'm not tell.
Don't tell. Okay. So 1990 to remember, think about Basaraj sir's date of birth. Okay. The estimated.
What even?
You should have put that goal before. I would have thought like that. If you would have told it's Gopika ma'ams, I would have.
I don't even know what she's saying. The estimated cost of sequencing the human genome was approximately $US per base pair. Per base pair, they're selling it.
Money minded. They're selling it. 9 billion.
Rani.
3
3.
USD per BP.
Now convert that to INR and tell me first.
That's why they don't 9 billion.
No, convert it to INR.
Oh,
$3 is how much for Indian rupee? Tell that fast.
Okay. One of the goals of HGP was to identify all the approximately dash number of genes in human. Human. That's all. Full
Human
stop.
DNA.
Yeah.
No,
Human.
DNA.
DNA.
240 rupees or 200 rupees. I don't even know how much that.
Please multiply.
I don't know
No,
how much
you
that one US to one INR. How much is that? 80 rupees.
72.
72. I don't know.
We don't know you, so definitely you can leave. 20 to 25,000.
They're still multiplying that. 20 to 25,000 genes in the human DNA.
Yes.
Okay. Next one. The Human Genome Project aimed to determine the sequences of the dash billion chemical base pairs that make up the human DNA. How many base pairs are there? How many base pairs are there? Billion. It's in billion. Nine. That is too much. You're roasting spammers, huh? Exactly, 3 billion. Awesome. Is it 3 billion?
Yes.
I'll read.
Okay.
The Human Genome Project was closely associated with the rapid development of a new area in biology called as pain.
We have studied this.
That's the
Very.
pain.
We were crying students every class.
One day before the exam, I was how I'm teaching you now. One day before the exam, I was teaching my classmates this one that day. One day before the exam, that time also they study. Students don't, not only you, even in the not biotechnology,
Bioinformatics.
bioinformatics. Yes, Shreya.
Shreyas correct. Bioinformatics.
And this is actually, if you know the concepts, if you're able to understand this, it's very application wise. And if you really want to do any type of research, it needs to have bioinformatics in it. Unless there's bioinformatics done your research, it is not valid.
You cannot just write any theory and
go.
No one will
You have to
see.
do
You have to do
bioinformatics.
graph, you have to do plotting and tell
Every
that
single
this
thing
is
you have
what
to
we
do.
have done.
Actually, the best part was in biotech, if I remember correctly, the RNA designing, primer designing.
Primer design.
So students, you know what is a primer, right? Actually, there are a lot of softwares to design a primer. Like you need to do PCR, you need to design a primer. You cannot use any primer in the market. You need to write what are the components it needs to have, and it's supposed to take a website, go on, design the primer, and then send it to a company. The company will send you a primer. Very interesting process.
Yeah. And you know that companies used to not even used to reject us.
Yeah, we should reject it because primer is not designed properly.
One of the methodologies used in HGP was dash sequencing tags. Yes. Students, dash. Two methods were taken. One was a blind approach and one was a proper approach. So, which was the blind approach taken? Yeah, to just, do HGP. Taking everything, coding, non-coding, all the strands.
When your exam is tomorrow and you're late for exam, what do you do?
First he asked, do I know you? Now he's telling you looks familiar. You should have a clarity what you want to do in life.
Yes, express sequences.
The common hosts used for cloning in HGP were dash and dash.
Now, this is a question which also present in your biotech application.
What is the host used?
Which type of vectors?
Vectors also will come.
Make them skill things.
No, back and yak is the vector. Question is host.
Host.
Who is the host? Vector is different, host is different.
Yeah.
Right, mosquito bites Baswa sir. Baswa sir becomes the host. Mosquito becomes the vector.
And I'm getting plasmodium.
Everything. Typhoid, dengue, chikungunya, everything. Exactly. You don't understand anything in bioinformatics.
Bioinformatics is one. Tree building and all we learned.
Yeah.
It's bacteria.
Even that protein also we did, no?
Protein. Yeah, protein sequencing.
Sequencing.
Sequencing. Beautiful.
Histone, all that we were starting with. Yes, bacteria and yeast. Very good.
I don't understand.
Not English.
Not English. I thought my English was bad.
The vectors used in Human Genome Project for cloning were dash and dash.
Now
Back
you
and
should
egg.
tell.
No,
Now
they
you should
told
tell.
back and yak.
Back in like you told, no?
Yeah. Next one. The Human Genome Project was completed in the year dash. Come on. Yes. Human Genome Project was completed in which year? Started 1990. Which year did it complete?
Your sister was born.
No.
22, no? Sister was not born. That's how I remember it now.
Yes, 2003. Correct, Rani. No, Subhashni, 2003. Yes. One method of sequencing in Human Genome Project involved automated DNA sequencer that worked on the principle of a method developed by. Come on, tell me the answer.
Name the scientist.
Name the scientist who actually helped in breaking down all the overlapping sequence just to put everything into place. Who helped? Because it was not possible manually. So then what was the technique they used?
And the Nobel Prize was won for this.
दो like एक for
First
this.
other one was insulin. Sanger. Exactly.
Yes, very good.
Frederick Sanger. Next question.
The human genome contains. No, I'll tell. Okay, the human genome contains approximately dash billion base pairs. Number.
Venkat Ramaswamy actually came to my college, my undergrad college. I have a book signed by him. I got a book called as Machine. And he worked on ribosomes. So I got a book signed by him. Full on.
That is showing off.
Yeah. Full on. Because when you meet such famous personalities, now you will know Venkat Ramaswamy, amazing guy.
Yes. 3, very good. No. 3 1. Yeah, they should tell the number, na? 3.164. Yeah, no problem. 3 also they'll get marks.
The largest known human gene being dash at 2.4 million base spans about almost dash of the human genome.
The only one. Okay, the only one largest gene. Okay, yes. 3 1
Gene machine. I'll send it in the Telegram. I'll put it.
Students, you can join us on our Telegram, that is Vedantu NEET English. And if you want to join us on our individual Telegrams, you can join Gopika by Biology, Baswaraj Biology.
No, it's just Baswaraj.
Okay, Baswaraj.
No biology. Because I don't know what to add. I was very skeptical.
Correct. Dystrophin.
Yes.
Dystrophin 1 by 2000th. Okay, here. Almost span is 1 by 2000th of the human gene. Yes, got it. Next one. Less than dash % of the gene codes for proteins. Students, in this only you are covered with PYQ, MCQ, question answers, whatever. Because every line of NCERT is converted into a question. Okay? So this is like the best revision you can have.
Because when you have MCQs, we'll do the MCQ also. Don't worry. You might be thinking, sir, why are you not giving us options? Because NEET will give you options. But don't worry. This is a different thing we are trying for you to learn. But MCQs will be soon coming up on the channel. That is the price.
Options. See, why NEET becomes difficult is because they play with the options.
Yeah.
There will always be 2 options which are very, very in close proximity that there'll be very one factor to decide. So that kind of training you will definitely need when you're closer to your NEET preparation, because your concepts will be strong. Foundation is set. Now you're understanding. Okay, this is the answer, this is the answer. That time we will do. Don't worry.
Chromosome 1 has the most genes, 2968, and Y has the dash. Yeah, this is JEE mains for biology.
No, look at that. Sam.
No. Actually, both of us did not talk much in the college. Even though we used to be in the same class, we used to not talk.
And we both used to teach in different places, but we never.
Yeah, when we left the college also, we left in different places. And somehow, after I got to know ma'am is coming back to Vedantu, I was super happy. I was like, okay, my classmate is coming back and teaching with me. I was super happy. And that is why we are doing all this now. Like, it feels so good.
This is called faith. Yes, 231. Very good.
Next question.
Scientists have identified about 1.4 million locations where dash vary among humans. Okay?
I actually lost French.
Let's not talk about this. So many things will be revealed. Our teachers should see this.
Yeah.
Students, tell us which makes the difference. Now, see, both of us have straight hair. Now, what makes the texture difference? Just because of change of one thing. I've told you that, no?
Single.
Yes. So, what is that name called? You can tell the short form. Don't type the whole thing. Just put the short form. Yes, very good, Rani. Very good.
Single nucleotide polymorphism.
Yes, SNPs. SNPs makes all the differences that you see in 2 people. Okay? Yes.
Next question.
0.1% was the 2% question. Students, 2%. The 2% genes are, their job is known.
The DNA fingerprinting. So we are in DNA fingerprinting now. If you know.
Coming to an end.
Coming towards the end.
Yes.
The DNA fingerprinting involves identifying differences in some specific regions in the DNA sequence called as dash DNA.
That's why I'm having curly hair. Yes.
Yes.
SNP played.
Played a game.
Played big time, Sharat.
That dash type of DNA. Introns, no?
Yes. Did you all subscribe to the channel? Tell me.
They'll say no.
No, they will tell yes.
They're like, why should I subscribe?
No. They're good students. They will subscribe. Students, quickly subscribe to the channel and hit the like button. Okay, we are giving you this revision. That means you should be. Okay.
Hopefully, they say.
Let's see. Satellite DNA. Very good. Satellite DNA. Oh, repetitive DNA. I
Yeah.
mean, satellite DNA also the same thing. Okay. And this is satellite DNA.
Yes.
Okay, next question. Sorry, students, I told the answer. Dash is the basis of genetic mapping and paternity testing. Yeah, who is the father?
Just check no. Who is the father of this child? How do you know?
Yes. Sanvi, I know.
Sandeep.
Blindly, we trust Sanvi that she subscribed to the channel. She's a regular student again.
YST. I believe in YST.
YST also.
She has shown so much of love towards you. I'm like, I believe her whatever she says.
Oh, 250 likes. Good job.
Exactly,
Very good,
Arush.
Arush. DNA fingerprinting. Yes, Niriksha. Yeah, their names are so beautiful, no? We can't even pronounce.
Yeah, so beautiful.
So easy, our names have kept in parents.
DNA fingerprinting.
Was initially developed by Dash. He almost read half of the question. Okay.
Yeah. Scientist name.
Scientist name. Alec Jeffrey. Even Shreyas is answering all the questions. But he's crying and answering. That's the only problem I have.
Yeah, why is crying though?
I'm just so happy about his
tears.
happy tears. Alec Jeffrey. Yes. Huh. Now, this next question. The DNA regions used as probe in DNA fingerprinting are called as. You know, this thing, this concept is not all explained in NCERT.
They'll give
And
you-
yeah, they just given one line. Okay, this is what you do. It is very crazy if students has to get that concept.
True.
That
If you
radioactivity.
do not know this concept, please go watch Gopika's video. She has explained beautifully when I was watching that.
Yeah, HGP and DNA fingerprinting.
Very beautiful explanation.
That's the only way you understand what is this. Because NCERT
True.
has just mentioned two words.
Yeah.
Okay, VNTR,
Variable number that
Yeah.
random repeats, but
And-
it doesn't say anything.
anything, and they have used the word radioisotope. Now
Yeah.
students will be like, oh my god, from
Where
where?
does it come?
Then suddenly they're going to southern blotting.
No.
So that's the
They
thing.
don't even explain them blotting also.
No. They don't know why they're doing it.
Yeah.
So this is the need for a teacher. Understood? All of them will be like, oh, biology is so easy, I can read NCERT. Mysterious book.
The technique as used earlier involved dash blot hybridization using radioactive labeled VNTRs as a probe. See, everything is here.
Yeah, the same word in NCERT. He killed your name.
You killed my name. Entertainment with those black hearts. You killed my name. I know my name is difficult, but that is some other name only. Ethidium bromide, no. Southern blotting, yes. It is southern blotting. Students, do you actually know there are different types of blotting actually?
Yeah, I mentioned
You
this.
were told also.
Yeah, because we learned it, no?
Yeah.
Okay. Yes, southern blotting. Ooh, we done?
We're done.
Yes.
We are done.
Oh, full on.
Full on. Okay. So, students, we are done with almost more than 150 questions.
Yeah.
If you are not sure.
You haven't counted, but you know how many slides were there? We had 150 plus slides.
261 slides.
Yeah, 261 slides. You can divide it by 2. Okay. Yes.
So we had a more. What's the meaning of my name? So
Surviving.
Your name is surviving.
My name is not.
Joke was so bad. So my name is Baswarna. There is a god Baswarna. Nandi. So Baswaraj means the king who has power of bull. What is Gopika meaning name?
नहीं बोलूँगा.
King who has power of bull. Yeah. So that was the end.
About the mentorship and fast track revision.
Okay, students. So that was the end of today's class. Everything is done. We had almost 261 slides. Every single thing one is over. And we have solved more than 150 questions today. And I hope the entire chapter is revised with you. As I was saying, Gopika ma'am mentioned before, like some of the students right now might be saying that I do not have the motivation. Or, sir, I do not understand, even I'm doing the mock test, even I'm doing MCQs, I'm solving the questions with you, I'm not understanding the chapter still. Sir, what are the other things which I need to avoid right now? There are so many things which you need to avoid right now. It's very evident. For all those things, Gopika ma'am and I, we decided finally. We were talking other day, like what could help, what could help all of you at this point other than the academic, because we are giving everything for free. But there's one thing which, even if we, I don't know, we cannot give it on YouTube. I'm very sure on that. I know we can, like we can give everything right on YouTube, but there is some of the students will be like, no sir, I am very hesitant to talk on YouTube. I'm hesitant to share my problems on YouTube. In the chat I can put fire emojis, heart emojis, but there are some small pain, like small thing which we cannot tell on YouTube.
Yes, yes. Students, and not only that, we get a lot of messages on Telegram. We get a lot of calls on Instagram telling that, ma'am, I want to talk to you. I'm facing this. But, every time it's not possible, right, to talk, or maybe we are not in that headspace at that point of time. So we feel sad that we should have attended them that time, right? So to avoid all this, to not have that guilt, oh, I did not help that student. Because see, we all have our personal lives, and sometimes when we are in our personal life, we will not be able to check social media, or the student has typed so many messages, not possible. So I thought, why not give a dedicated time, okay, to just ask you people.
Exactly.
Okay.
As Anvi is saying, I always get scared before the mock test. See, the reason you get that is because you have not solved enough of mock test actually. When your NEET exam is coming, you should not be feel scared. You should be excited. Like imagine tomorrow one favorite episode is going to come. You'll be so excited to watch that episode, right? The same excitement you should have when the NEET exam is coming. It should not become, it should not become like a scary thing for you. You should be more excited. You should be more excited. Yes, my dream exam is coming for me to get into my dream college. And for that, you need a little bit of motivation and everything.
Students, understand, this is a very small step. Even though we tell NEET, students understand, in MBBS, all this that you're going to study, all this that you have, this foundation is going to, see, understand, when you're sitting in a class of your first year MBBS, there are going to be students who spend 10 lakh, okay, say 2 lakhs, 3 lakhs for a coaching, okay?
Yeah.
But maybe their foundation is not as strong as you are. There will be students who did not spend 1 rupee also, but their foundation might be stronger than this person. That means you're going to be in a mixed crowd. Now, all of you are in the same concept. I want to crack NEET. I am here in the mock test. But when you go there, you are going to face all the kind of people, right, who has been doing this for past 4 years.
Yes,
It
yeah.
might be their 5th attempt that they passed. So their knowledge, you cannot compare. But understand, what will make you different is your foundation. If now this small step, I'm telling you why this is a small step, because in MBBS you will have more, it is going to be hard. It's not going to be easy, right? Because doctors are people who have to be there when most of us would not like to be there, right?
Example is COVID.
Yeah, when COVID was happening, no one wanted to step out, but they took the risk, right? So you people have to be that persistent. You have to be that, strong enough to be there.
Simple NEET exam cannot scare you. If you're going to be that person, right, become a doctor, a simple NEET exam cannot, scare you.
Exactly.
Think of the NEET exam just as a stepping stone to reach your destiny. This is not just a, end. This is the starting of a beautiful journey.
Yes.
So there could be a lot of problems you might have. So for that, on Wave platform, whenever we are free, we are planning to have one small session, weekly only once, and we'll not take much of your time because we know how precious your time is. In this small 1 hour or 30 minutes or 45 minutes, just come to the live session with us, where we'll not be teaching anything. We'll not be talking any academics. I'll not be explaining you small tricks like this. I'll not be explaining you any kind of.
For that, we have YouTube.
For that
We
we
are
have
very
YouTube.
glad that this channel is there. Okay. But we need another space. So that space we will provide. We will not waste your time. That every minute you spend with us will motivate you, will be able to, reduce your burden, because there are a lot of things that you cannot tell your parents, because when they're paying the money, they expect you to do the perfect
Yeah.
thing. So for that, we are there. Okay, students. So we will hope to see you all, right, in the mentorship. And also we will be starting just a revision for our CBSE students, who, it will be like a question answers, not very specific to NEET, but very specific to CBSE.
True.
Okay, we'll put the questions and we will tell you what type of answers you have to write with all the keywords. It will be very focused for our 12th board students. Okay, so yes, we will see your response, and then we will see if we should continue or not. That also happens, students, because when we do that, we take the extra time, we come to office and we do that, we want that same kind of a response. Okay, yes.
So we will be seeing you there on the Wave platform. and it doesn't matter how many students are there. We just want our regular students to be there. And
just go contradictory to my statement.
no, I'm just telling you.
He cares more about students, how many students are there than I do.
We just want all of you to come there and just sit with us and talk. That's all. It's going to be just talking, where you'll be talking to us, because we'll be unmuting them, right?
Yeah, I think we can do that.
Yeah, it's not just you won't be just typing. We'll be hearing your voice. You'll be talking to us, and it's going to be a normal interaction kind of thing.
Yes. So yes, now Diksha ma'am will be joining. So do not leave anywhere. See you all. Bye.
Fast track, you told?
Yeah, I told.
Fast track.
Yes, students, we are trying and testing what works for the both students, okay? Because we don't want to waste your time for the NEET preparation, but at the same time, we want to help them also. There are a lot of students who does not go for tuitions. Even board 12th class tuitions are very expensive. I have been a teacher there. I have been in colleges. I know
You've been
how
a student there
difficult.
also.
Yeah, we have been a student
there
also,
also.
so it is very difficult. Okay?
Expensive also. And sometimes
Yes.
when I'll tell you what is the problem there. What I used to think also with me. I used to be like, I'll learn this chapter in school. Then if I don't learn this school, I'll be like, I'll learn this in the tuition. When I go in the tuition, I'll be like, I'll learn this in school. That used to be a cycle, and I used to have so many backlogs. So I was very stupid. So very stupid, did not realize the importance of time. But all of you do not make the same mistake, because we are here to tell you now.
Okay, students, so see you all. Bye.
Bye-bye, take care.
Good night.
Good night.
After Diksha ma'am's class. Yes, please.
Hi everyone, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. How are you all? Very good evening to everyone. Am I audible? Am I visible to everyone present here? So yesterday we completed haloalkanes and haloarenes, alcohol, phenols and ethers, and today we are going to do aldehyde, ketones and carboxylic acid, a very scoring chapter of organic chemistry. So many questions are asked from this chapter, from organic chemistry itself. So guys, are you ready for this? I know you have been studying for like 3-4 hours, so I know it's like too much for you, but you have to do this because your exams are just 2 months away. If not now, then when? When after 5th of May, you will be free, right? After that, you will be like, okay, ma'am, we want to study. What if? You don't, you should not have what if in your life, okay? What if I did that? What if I did that? No, you have to do it now, and you must do it now if you want to achieve your dream. Like I was just I was actually listening to what Gopika ma'am and Basma sir was saying. That was absolutely correct. That this is not the end of any journey. This is the starting. This is just one step that will give you a push to your journey. MBBS college is your start of journey. This is one. This is one test or something that is being done for you to get enrolled to that college, and after that you will get into MBBS, and then so many things. You will have your MD, your DM. There are so many things after that. If you want to be a great doctor, to treat someone is a big thing. That is equivalent to God itself. You're giving life to someone, right? Yes? Okay, so shall we start? Everybody in the chat box. Everybody in the chat box. Shall we start the question answers now? Yes? Okay, welcome Bacha. Welcome Keith. Welcome. Perfect. So let us start. I am perfectly fine. Thank you so much for asking. So let us start this question answer session. Firstly, okay. So this is from aldehyde, ketones and carboxylic acid. Starting with the very first question, I want you guys to answer this like rapidly. Okay, this is like the Karan Johar round, rapid fire round. So how it goes: question answers. This is how your brain should work in the examination hall, right? Okay, perfect. So everybody in the chat box, organic compounds containing carbon, oxygen, double bond are called. Okay, carbon, oxygen, double bond are, what are these organic compounds? Carbon, oxygen, double bonds. They are called as carbonyl compounds, right? What are these called? Everything that has this this bond, these are called carbonyl compounds. Next we have the carbonyl compounds in which carbon of carbon is bonded to carbon, hydrogen and carbon, oxygen. Okay, they are saying where this thing is bonded to oxygen and then this is bonded to OH. What is this group called? This is called carboxylic group, right? Very easy. Next, esters and anhydrides are derivative of ester, anhydrides or acyl halides. All these are derivatives of carboxylic acids, right? Okay. Next we have everybody. Yes, very nice, very nice, very nice. Okay, you don't need to write the full name. You can just directly write COH. Okay, I'll understand that. Okay, I understand that typing fast is little difficult, so don't worry. You can just write the initials of that. So common name of CH3COH. What is the common name of? They're not asking the IUPAC naming. They're asking the common name of CH3COH. What is the common name? What is the common name? Yes. What? No. Ethanol is not the common name. That is the IUPAC name. Okay. Ethanol is the IUPAC name. The common name is acid aldehyde. Okay. This is the common name. This is the common name. Okay. Right. Common names, not IUPAC names. Common name of this one. What is the common name? What is the common name of this compound? This is benzene CHO. What is the common name of this compound, everybody? Yes, this is acid. This is benzaldehyde, right? Perfect. No, bacha, not formic acid. Bacha, how this is formic acid? Formic acid is this. This is formic acid, beta. Okay? This is not even acid. So this is benzaldehyde. Next we have, what is the common name of this compound? What is the common name of this compound? Everybody in the chat box. Yes. Everybody in the chat box, what is the common name of this compound? This is aceto. What is the common name of this compound? CH3CO. No worries, no worries. The common name here is acetone, right? This is acetone. Next we have the common name of this compound. This is a ketone. We have a double bond. We have carbonyl group here. One side we have benzene, other side we have CH3. This particular compound, this thing is called phenol. This is a hint. Okay, this is called phenol. In common name, just regard it as phenol. So now what is this? This is acid group. Okay, what this will be? This will be acetophenone. Okay, this is acetophenone. Right? Okay. Next we have this compound. Here we have carbonyl group. One side it has benzene, other side also it has benzene. Two benzenes on one carbonyl group. What will be the answer? This is phenol, right? Okay, this is not phenol. Okay, this is phenol and this is benz. So what will this? This is benzophenol. Yes, this is benzophenol. Okay, this will be benzophenol. Benzophenol. Understood, everyone? Yes, perfect, perfect. So next we have the IUPAC names of open chain aliphatic aldehyde ketones are derived from the names of the corresponding alkanes by replacing E with dash and dash dash respectively. So they are saying open chain aliphatic aldehyde and ketones. With aldehyde, what is the suffix? Very nice. This is not biphenyl, beta. This is not biphenyl. This is biphenyl. Okay. This is biphenyl. This is biphenyl. That is not biphenyl. This is biphenyl. Okay. This is benzophenol. Here we do not have carbonyl group in between. Here we have carbonyl group in between. This is benzophenol. This is biphenyl. Right? Okay. Yes. In case of aldehyde we have al. In case of ketones we have on. Understood? Yes. Next question is the IUPAC name of, I think I should replace it here only. Yes. The IUPAC name of CH3, CH2, C double bond CH, COH. Now you have a double bond and you have one CHO group here. Okay. How the naming will be 1, 2, 3, 4, 5. And then on second position we have ene group and this is al group. So what will be the IUPAC naming of this? What will be the IUPAC naming, everybody in the chat box? What will the IUPAC naming? This is pentane 2-ene. We have second position, we have ene. And next is al. Okay, pentane 2-enal. And why not enal? Why not enal? Because this ene, if you have, in IUPAC naming, we have learned that if you have E and after that if you have A, I, O, U or Y, this E will be cancelled here. Okay, so this is very simple, pentane to none. Next we have the IUPAC naming of this thing. Now here the IUPAC naming will start from this one, okay, from benzene. This will be 1, 2, 3, 4, right? Or you can also write it as this is 1, 2, 3. In this case, what is the IUPAC naming? This is a ketone. One side you have a CH2, CH3. One side you have benzene. Everybody in the chat box, what is the answer for this? Propiophenol. Okay. Other students, what is the name of this compound? What is the IUPAC name of this compound? Keith have answered this. Anybody else? Anybody else? Anybody else? Okay. So the answer is 1-phenyl propane, 1-one. Okay. On the first position you have phenyl, and on this side 1-phenyl propane, 1-one. On this side you have, this is 1, 2, 3, and this is on the first position you have this phenyl group, and this is ethine group, or you can say ethyl group. Okay, perfect. So this is 1-phenyl propane, 1-one. Understood this? Very simple. Very simple, guys. Very, very simple. So next we have, when the aldehyde group is attached to the ring, the suffix. When this is attached to the ring, okay, the suffix is added after full name of the cycloalkane. Okay. When the aldehyde is attached to a ring, the suffix dash is added after the full name of the cycloalkane. Okay. After cycloalkane, the answer is still the same. The answer is still the same. If it is a cycloalkane and some aldehyde group is attached to it, what will be the suffix? Very simple, right? The suffix will be al itself. Okay, so this is okay. So now they are talking about actually we have done this. They have not mentioned this very correctly. So let me tell you one thing about CHO group. So about CHO group, always remember 2-3 things. Now, if you have this ring, okay, there are two cases when we use carbaldehyde. First is symmetry. And second is when it is directly attached to the ring. Okay, if I am talking about symmetry, here we can say if you have this C, and this is CHO, this is CHO, this is CHO. In this case, we will write it as carbaldehyde. It will be propane 1, 2, 3 tricarbaldehyde. Okay, tricarbaldehyde. This is what they are talking about. But the interesting thing is that, if we are talking about this IUPAC naming of this one, this is not known as Benz carbaldehyde. Okay, this is not known as Benz carbaldehyde, but this is known as benzaldehyde. Why not Benz carbaldehyde? Benz carbaldehyde, according to the rules of IUPAC, Benz carbaldehyde is the right thing. But here it is not Benz carbaldehyde, because already it was famous by this name, that is benzaldehyde. So that is why we do not include Benz carbaldehyde in this case. Okay. Otherwise, except for this one, we always say if that is a CHO group is attached to some ring, that is carbaldehyde. Okay. If COH group is attached to, that is carboxylic acid. Always remember that. Okay. Perfect. So now next we have this question where we have the IUPAC name of this one is. Now the IUPAC name of this compound is, what is the IUPAC name here? What is the IUPAC name here, everybody? Ma'am, how symmetry? Okay, how it is symmetrical? How it is symmetrical? We are not taking symmetry as that. We are not taking symmetry as if we can cut it into half pieces. This is not the symmetry here. The symmetry means if I name it like this, 1, 2, 3, 4 and 5. This CHO will not be included in the parent chain, and this CHO and this CHO are included in the parent chain. So to maintain the symmetry, to give the equal importance to every CHO group, we number this as this. Okay, this is numbered like this. This is numbered like this. So that is this is what I call symmetry. Okay, this is symmetry, that to give priority to all the CHO groups with the numbering is 1, 2, 3. Okay, not 1, 2, 3, 4, 5. We can include this, but we are not including this. Understood? This is symmetry. So now, very nice. This is cyclo what aldehyde? Carbaldehyde. Cyclocarbaldehyde. Okay. Cyclohexane aldehyde. Okay. Cyclohexane. Where is E? Where is E? Okay, there should be E, okay? There should be E here. Cyclohexane. E should be here, okay? Do not miss E here. E is always cancelled. Only is this case. If you have A, if you have I, if you have O, if you have U, if you have Y. Only in this case E is cancelled. Here we have C after E. So it is not cancelled here, okay? Next we have carbonyl carbon. The carbonyl carbon and the 3 atoms attached to it lie in the same plane, and the p electron cloud is dash and dash in the plane. So they are talking about the COH group, that the carbonyl carbon and the 3 atoms attached to it lie in the same plane, and the p electron cloud is dash and dash in this plane. It is, don't worry, yes it is above and below the plane, above and below the plane. Okay, understood? They are talking about CH2 group. Next we have ozonosis of dash followed by reaction with zinc dust. Ozonosis of dash followed by reaction of zinc dust. They are talking about reductive ozonosis, right? And water gives aldehyde, ketones, or a mixture of both depending on the substitution pattern of this. Depending upon the substitution, ozonosis of what they are talking about? We have 2 ozonosis, alkene and alkynes. Okay, alkene and alkynes. So in this case, they are gives aldehyde and aldehyde ketones, or a mixture of both, depending on the substitution pattern. Yes, this answer is alkenes, right? The answer is alkene. In case of alkyne, if you have triple bond here, if the bond is broken down, so it will be C and C here, double bond here and double bond here. It will be like this, okay? But in the alkene case, if you have C double bond C, this will be broken down. This will be this and this. Either it can be aldehyde or it can be ketone or the mixture of both these compounds, okay? So this is alkene. Next we have the addition of water to ethyne in the presence of, now the addition of water. In the case of water, you have HD, you need mercuric ions, right? So in this case, addition of water to ethyne they are talking about. If you are talking about ethyne, so they are talking about the addition of water in ethyne. Water in ethyne means, for example, this is CH, this is single bond CH, this one is, let's suppose this is positive and this is negative, this is double bond here. To the negative, we have included H positive, OH negative. OH negative will be here and H positive will be here. Now you have this thing, okay? And this is enol. This is enol. This will be converted to, by tautomerism, it will be converted to keto form, okay? So it gives addition of water to this. What does it give? So after a keto form, this H bond will be broken down. It will be double bond O, and here we will have C, H, and this will be, yes, 1, 2, 3. Okay. So CH3, right? Okay. Understood, everyone? The answer will be this. What I'm writing here, wait. This is double bond O. Wait, this is double bond O. This will shift to this one. Okay. Yes. So what is the answer? What is the answer? Obviously a ketone will be formed. What is the answer? Let us see. Have they mentioned the IUPAC naming? Acid aldehyde is formed here, right? CH3, CH2 group is formed here. So many of you have written here, this is not a ketone. This is an acid aldehyde. This is what? This is CH3. This is CHO. So do not just write it down that it is ketone. After tautomerism, it is getting converted into aldehyde. Okay, after tautomerism, it is getting converted into aldehyde, not a ketone. Now, next we have the acyl chloride or acid chloride is hydrogenated over catalyst. Acyl chloride, that is COCl, this is hydrogenated over a catalyst, palladium or barium sulfate. This reaction is called. Now, it's a very famous reaction, a naming reaction. What is this reaction called? Here we poison the catalyst with the help of BaSO4 or quinoline or CaCO3, anything that is used as a poison, so that to slow down the reaction. What is this called? Yes, this is called Rosenman reduction. Okay, and the catalyst is, what is the name of catalyst? What is the name of this catalyst, everybody? Yes, the name of the catalyst is Lindlar's catalyst. Yes, okay, perfect. So now you have this reaction H2PD BaSO4. What will happen here? Reduction will occur. Okay, reduction will be here. Reduction will take place, and the Cl will be replaced. This C double bond will be replaced. Yes, very nice, very nice. Again, BaSO4 reduction will occur, and you will have the formation of CHO group. Okay, this will be CHO group will be present here. Now, next is, and always remember, this is the poison here. This is not the poison. This is the catalyst. This is the poison here. And this whole thing is called Lindlar's catalyst. Okay. Next we have nitriles are reduced to corresponding amines with the stannous chloride. It's a metal SN stannous chloride in the presence of hydrochloric acid, which on hydrolysis with corresponding aldehyde, the reaction is called. Again, a very important naming reaction. A very important with metal halide. What do you do? Nitriles are getting converted into amines. Nitriles are getting converted into amines. Yes, everybody? Perfect. No. So many different answers are here. Somebody is saying Itard's reaction. Itard's reaction. Are you sure about Itard's reaction? What is Itard's reaction? Everybody in the chat box. What is Itard's reaction? This reaction is Stephen's reaction. Itard's reaction is not this. We will discuss that in this chapter only. Okay. Now you have this reactant. We have the formation of, we have the reagent is ALH. This I means isobutyl twice and H2O. You have cyanide here. Now tell me what will be the answer to this. What will be the answer to this? This is similar question. Similar question that we discussed here. This is also metal. Okay, L is also metal. So what will occur here? This is a cyanide or a nitrile here. And after that, this will be converted into, I can't see that in the chat box. Kate is answering Krishna, Sanjana, Deepak, Samaria, and who all? Sanvi. Everybody. Yes, what is the answer? Hexane 2-ul. Hexane 2-ul, is it? So broken down. And hexane 2-ul. 1, 2, 3, 4, 6. Hexane 2-ul. No. Okay. This will be, okay, this is 1, 2, 3, 4, 5, 6. This is, the IUPAC naming will be 6, right? So this is hexane 4-ene-ul. Okay, not hexane 2-ul. Okay, got it? So the CN is getting converted to CHO, and it is a selective reagent. It does not reduce C double bond O group, right? So next we have DIPAL, double, and H2O. What will occur here? What kind of reaction will take place here? You have the CH3, CH2. It's a very long chain, and this is ester group here. Now after this DIPAL, what will occur here? Yes, aldehyde. No, alkene will not be affected in that case. Okay, alkene will not be affected. Yes. So we have this reaction DABL. After that, this CHO group, and only this group will be affected here. Now everything is same here. This bond will be broken down, and this is C2H5CO will go, and we will have the formation of CHO group here. Right? Okay. Aldehyde is always a priority. Next we have chromyl chloride. Now this is your reaction that you were talking about, right? This is the reaction that we were talking about. Chromyl chloride oxidizes methyl group to chromium complex, which on hydrolysis give corresponding benzaldehyde. This reaction is called. What is this reaction called? Now this is the reaction that you were talking about. Yes, everybody, this reaction is called. What is the reaction called? This reaction is called Itard's reaction, right? Okay, sure. Next we have, this is toluene CrO3. Then you have the this is anhydride, and then you have 2 at 0 to around something degrees Celsius. This is the chromyl chloride complex, okay? And after hydrolysis, you will have this is the chromyl chloride complex. After hydrolysis, you will have the formation of what is this reaction? Again, the same reaction, that is you will have the formation of benzaldehyde, okay? You will have the formation of benzaldehyde. This is the proper reaction here. The reaction that we were talking about, this is the proper reaction here, okay? Next we have side chain chlorination. About the side chain chlorination of toluene they are talking about, gives benzyl chloride, which on hydrolysis, side chain chlorination they are talking about. Everybody in the chat box, side chain chlorination of toluene, the CH3 group here, right? And gives benzyl chloride. This will give benzyl chloride, which on hydrolysis, after the hydrolysis it will give, yes, after hydrolysis, what kind of aldehyde will it give? What is the name of the aldehyde, everybody? Yes, very nice, benzaldehyde. Okay, benzaldehyde, very nice. Next we have when benzene or its derivative is treated with carbon monoxide, and again a very important reaction, hydrogen chloride in the presence of anhydrous aluminium chloride and cuprous chloride, it gives benzaldehyde or substitute to benzaldehyde. This reaction is known as, what is the name for this reaction? Everybody in the chat box. Everybody in the chat box, what is the name of this thing, carbon monoxide? You should get an idea about what they're talking about. Yes, what they're talking about, very nice. They're talking about, everybody, yes, very nice. They're talking about Gatterman-Koch reaction. Okay, you can learn it at OCH. OCH means CHO. Just reverse this CHO. Okay, just you can remember this by this. Okay, Gatterman-Koch reaction, CHO. Next, treatment of acyl chloride with dash prepared by reaction of cadmium chloride with Grignard reagent gives ketone. Now this thing that they are talking about, that is prepared by reaction of cadmium chloride with Grignard reagent. CdCl2 with Grignard reagent gives ketone. Acyl chloride with something. What is that something? What is that something? Everybody? Yes? What is that they are talking about? What is that they are talking about, everybody? Yes, very nice, very nice. Yes, very nice. R2CD, very nice, Sanvi, very nice. Okay, so they are talking about dialkyl cadmium, that is R2CD. Okay. Okay, the benzene or substituted benzene is treated with acid chloride in presence of dash. Now, benzene or substituted is treated with acid chloride. Okay. In presence of something, it affords the corresponding Friedel-Crafts acylation. Okay, this is very simple. Very simple. Very, very simple. Now everybody, this is a very simple question. In the presence of what they are talking about? Benzene or this with acid chloride in the presence of what kind of acid? Right? What kind of acid? Yes, a Lewis acid, that is AlCl3 or anything else. A Lewis acid is used here, right? AlCl3. Next we have benzene with CH. Again, the reaction is repeated here. What will happen here? What is the name of this reaction? You already did this. The name of this reaction is, everybody in the chat box, we already did this. Yes, this reaction is Gatterman-Koch reaction and will have the formation of benzaldehyde, right? Okay, this is Gatterman-Koch reaction. The boiling point of aldehydes and ketones. So aldehyde and ketones, their boiling point are dash then hydrocarbons. Now, as you all know, for aldehyde, this is the group. For ketones, this is the group, right? This is the group, right? And for hydrocarbons and ethers, we were talking about hydrocarbons, that is this, right? And about ethers, hydrocarbons are this and ethers are this. Okay, of same molecular masses. What about the same molecular masses? What is the reason behind that? Everybody, yes, they are higher. These are the groups, right? Okay, this is more electronegative, right? Right. Due to H bonding, very nice. Okay, they have no oxygen is directly bonded to any very highly. This is not actually hydrogen bonding here. This is oxygen is not bonded to any. This hydrogen is not bonded to here. Even hydrogen is not bonded to any. This is because of the polarity of this thing, not because of hydrogen bonding. Okay. the polarity of this bond. Hydrogen bonding is present when this is not hydrogen bonding with water. It will have hydrogen bonding with water, not with itself. Okay? Not with itself. It will not have hydrogen bonding with itself. There is no hydrogen that is actually bonded to any electronegative atom, right? But the polarity of this bond is much higher. This polarity is very higher because this carbonyl group, okay? Because of this carbonyl group, it is like this, okay? Yes. Yes. Perfect. Perfect. Inductive effect. Very nice. Because of inductive effect. Very nice. Not because of, yeah, with water. When we are talking about with water, we are talking about solubility, right? Okay, when they are talking about boiling point, they are talking about the molecule itself, like between the molecules. With water, they are talking about, with water it will have hydrogen bonding, right? Okay, perfect. So now the boiling point will be higher. The boiling point of aldehyde ketones are dash than those of alcohols of similar molecular masses to absence of this, okay? Why? Because alcohols we have ROH, right? This ROH, it itself with some other molecule of ROH, okay, alcohol, it will have the hydrogen bonding, right? But the aldehyde or ketone do not have hydrogen bonding, the molecule of itself. So it will not, the boiling point will be lower, right? Okay, yes. Next we have the lower members of aldehyde ketones such as methanol, ethanol, propanol are dash with water because they form dash with water. So lower members means the alkyl part will have less molecular mass. It will have less surface, right? So the carbonyl group has double bond. So carbonyl group has double bond. So this is there is polarity. This is partially negative. Okay, if there is water here, it will form the hydrogen bonding here in this case, right? Okay. In this case are higher because of they form hydrogen bonding, right? Okay, are miscible because of hydrogen bonding. It will form, no, it will be miscible. If it is forming hydrogen bonding, you have this carbon double bond. For example, this is R and this is R, right? Okay, so if the R part is having very less surface, the surface area is very less. So in that case, this part will be dominating here. If this is very large, it will be very difficult for this bond to form hydrogen bond here, right? Okay, so in this case, it will be partially negative, partially positive. So if you have water here, this is water here, this is water here. In this case, it will form hydrogen bonding with water. It means it is miscible. It can mix. It has good solubility because of the hydrogen bonding with water. Yes. Next, we have the solubility of aldehyde ketones dash rapidly on increasing the length of alkyl chain. If you are increasing the length of the alkyl chain, what is going to happen? The alkyl part is bigger. Now, the dipole-dipole interaction will be stronger. The hydrogen bonding, the surface for hydrogen bonding is less available. For example, this is the bond and this part is very big. This part is very big, right? So, this hydrogen bonding will be very difficult to achieve, right? Okay, perfect. So, it will decrease. Next, we have the aldehydes are generally dash reactive than ketones in nucleophilic addition reaction. So, they are saying aldehydes are generally in nucleophilic addition reaction they are talking about. Now here comes the GOC part. Here comes the GOC part. Everybody, here comes the GOC part. You have, this is the aldehyde, right? For example, this is, let it be R and this is the ketone. This is the ketone. This is ketone. So for nucleophilicity, what do you need? What do you need? This is giving it plus I, this is giving it electrons. This is also giving it electrons. This is also giving it electrons. This is plus I here, plus I from this side, right? Okay. So nucleophilic attack will occur only when this is very electron deficient. So it is providing electron here. Here we are providing electron from two sides. So nucleophilic attack will be more in this case, right? Okay. So aldehydes are generally more reactive, right? Next is electronically aldehydes are more reactive than ketones because two alkyl group reduce the dash of the carbonyl group. The deficiency, right? Because ketones are steric hindrance is also another factor. Yes, you can also write. Yes, steric hindrance is also another factor. First is inductive effect and second is steric hindrance. These are the two factors. Okay, these are the 2 factors. Very nice, Sanvi, very good. So now next we have, because 2 alkyl group reduce a dash of carbonyl compounds carbon more effectively than the former. So they are providing the electrons. What they are doing? They are providing the electrons. They are decreasing the electron deficiency of the carbon. Okay, they are decreasing. They are reducing the electrophilicity of the carbonyl carbon. Right? Okay, the deficiency is less here. Right? The love for electron is now decreasing because they are actually providing the electrophilicity. Electrophilicity means the love for electron is now decreasing because it is getting electrons from the alkyl group, right? Yes, the polarity is decreasing here. The aldehyde and ketones react with hydrogen cyanide to yield. The aldehydes and ketones they are talking about, they react with HCN to yield. The attack will be very simple, just like Grignard reagent. The attack will be just like that. Okay, attack will be similar to what we do in Grignard reagent reactions. Okay. This is the carbonyl group here, okay? Aldehyde, for example, we are taking this ketone here. Now, the H for the positive part, this is H positive, C negative. Now, the positive part, this is single bond here. Okay, the positive part is going to jump on this side, the negative part on this side, right? This is partially positive, this is partially negative. Okay, everybody? Yes, very nice. Cyanohydrin, very nice. Cyanohydrin, right? What is that? We have not drawn the structure, so I will just draw it here. This part will move here and it will shift here. Electrons will shift here. So this will be RC, this is OH, and this is R, and this is CN. Okay? This is cyanohydrin. Okay, next we have aldehyde react with dash equivalent of monohydric alcohol in the presence of dihydrogen chloride to yield alkoxy alcohol intermediate known as dash. What is this alkoxy alcohol intermediate known as? What is this alkoxy alcohol intermediate? The aldehyde react with dash equivalent of monohydric alcohol. Okay. In the presence of dihydrogen chloride. Dihydrogen chloride, everybody in the chat box. What will be the right answer? Yes, anybody here? Kirts, Rani, Samaria, Nireksha, Sanvi, Rani, everybody, yes, 2-hemiacetal. Okay, Nireksha has answered it. Anybody else here? Anybody else here who want to answer this? Alkoxy alcohol. What is this alkoxy alcohol called? What is this alkoxy alcohol? This is called hemiacetals, right? These are called hemiacetals. So aldehyde react with dash equivalent of monohydric, 1 equivalent of monohydric alcohol in presence of. Now, what if there is ketone here? What if they have written ketone here? What will be the answer? What if there is ketone here? The answer will be acetal, right? Okay, perfect. So now aldehyde and ketones are reduced to primary and secondary alcohol respectively. To primary and secondary, yes, by dash or dash as well as by catalytic hydrogenation. Okay. Aldehyde are they are getting reduced to primary and secondary by dash or dash as well as this catalytic. So what are the reducing agents that convert aldehyde to alcohol? What are the reducing agents? Like NaHBO4, LiAlH4, right? These are the reducing agents here, right? Okay. Anybody? Is the chat stuck here? I'm not able to see your answers. Guys. I'm not able to see your answers, everybody. Yes. Okay. Very nice. PCC, PDC. Yes, you can also use that. So in Clemenzin reduction, the carbonyl group of aldehyde or ketones is reduced to CHO group upon treatment with. In Clemenzin reduction, what happens? This is a reduction. What we do here? What are the conditions here? On treatment with, is there basic conditions or acidic conditions? It is treated with what? Zinc amalgam, HCl. And what are the conditions? Acidic conditions. Yes, very nice. Zinc amalgam, HCl, right? They must have written here only. Zinc amalgam, concentrated HCl. Okay, so the conditions are acidic here. In Wolff-Kirchner, the conditions are opposite. there is reduction of carbonyl compounds into, the answer is same. The product is same, the reactant is same in both the cases, Clemenza and Wolff-Kishner. The difference in the conditions, okay, the difference in the conditions. For example, you have a group, for example, let's take an example, that you have a group that is, you have a compound that is C, this is CHO, for example, this is CHO here, and here you have OH. So in this case, in case of Clemenzin reduction, there will be effect on the base as well. This is OH negative. So what will happen here? In this case, this base will be converted into an acid, okay? So it will be converted into an acid. In the acid and base, they will have neutralization reaction. If we are talking about Wolff-Kishner reduction, for Wolff-Kishner, this will change to CHO, right? Okay, so this will change to CHO, but there will be no effect on OH. Okay, because here we have acidic conditions. Here we have basic condition. Here we have basic condition and acidic condition. There will be neutralization reaction between this OH and this acid. So it will lead to OH will go with H positive and there will be CH negative here. Right? But in this case, as such, nothing will happen here. Right? Okay? Perfect. So Wolff-Kishner reduction is reduction of this carbonyl compounds into the answer is same, hydrocarbons. Next we have the carbonyl group of aldehyde or ketone is reduced to this on treatment with dash followed by treatment with sodium or potassium hydroxide. Okay, so they're talking about Wolff-Kishner reduction. In this case, what you use, what are the reagents present in this case, everybody? The reagents that are present in this case are dash. What are these reagents in basic conditions? Solvent such as basic. Solvent is basic, and what is the reagent here? Yes, everybody. What is the reagent? Wolff-Kishner. Wolff-Kishner, the reagent is no. Okay, what is no? You are saying no. Kishner, I will not go with you. No, Krishna, I will not go with you. So that is hydrazine. Okay, that is no. NH2, NH2. Okay, no. Yes, very nice. So this is hydrazine in presence of ethyl glycol and basic conditions basically. Okay, there will be basic conditions here. So in dash on warming an aldehyde with freshly prepared ammonical silver nitrate. What is this called? Tollens reagent they are talking about in dash on warming. What is this? Very simple. Where you see the silver nitrate or mirror, the answer is Tollens always, right? You don't need to read the full text here. The answer is Tollens reagent, right? Very simple. Okay, everybody. Yes. Okay. Next we have Felling reagent comprises of two solutions, Felling solution A and Felling solution B. Felling solution A dash, Felling solution B is dash. What is the name of their two solution? Benedict solution is also the same. It's just the difference is that Felling solution is prepared. You have to prepare this on the spot. Okay, it is very unstable. You can't just store it. Benedict solution you can store it. Okay, that's the only difference here. Everything else is same here. So what is Felling solution A? What is Felling solution B? Everybody, yes, what is Felling solution A? Potassium tartrate, very nice. Sodium potassium tartrate, okay. And what is Felling solution B? CuSO4 and sodium potassium tartrate. Yes, okay. Aqueous CuSO4. And what is the color change here? Aqueous CuSO4, sodium potassium tartrate. Color changes, very nice. Rochelle salt, very nice. Sodium potassium tartrate are also called Rochelle salts. Very nice. So this is aqueous CuSO4. It is of blue color. Okay. Basically we'll have the blue color solution here. Okay. It will turn to brick red color. Right. It will turn to brick red color. So this is alkaline sodium potassium tartrate. Also called Rochelle salt. Right. Dash aldehyde do not respond to Felling's test. Now the question is, how do we differentiate it? Dash aldehyde do not react with Felling test. Which are the aldehydes that do not? Ketones do not give reaction of both. Okay, both Tollens and Felling solution. Ketones do not give reaction. What about this? What kind of aldehydes? Yes, very nice, very nice. Aromatic aldehyde do not respond to Fehling test. What about Tollens reagent? Does aliphatic it is applied to? Is this, am I right? Is this statement correct or wrong? Aldehydes, whether it's aliphatic, whether it's aromatic, it will react with it will give positive Tollens reagent test. Is this statement true or false? Everybody here, is this statement true or false? Yes, Tollens reagent will react with both aromatic and aliphatic, but Fehling will only react with aliphatic. So if you have to differentiate between aromatic and aliphatic, then you have to apply Tollens Fehling test here. If you want to differentiate between ketone or an aldehyde, you can apply either Tollens or you can apply Fehling solution. Both the tests, right? On heating an aldehyde with Fehling's reagent, a dash precipitate is obtained. They are saying on heating an aldehyde with Fehling's. If you want to heat an aldehyde with Fehling's reagent, a dash precipitate is obtained. What kind of precipitate is obtained here, everybody in the chat box? What kind of precipitate is obtained here? Yes, very nice. We have already done that. Reddish brown precipitate is obtained here. Okay. So, or you can say brick red. So, iodoform. Now, very important. What is iodoform? Haloform test. Very important, given in your practical chemistry as well. A very important test. So many questions are asked from this. Okay. Iodoform reaction with sodium hypoiodide is also used to detection of dash group and CH3CHOH group, which produces dash group on the oxidation. What kind of group does it produces? What is the color of that compound? Right? What is the detection? The detection of what kind of groups, everybody? These kinds of group, these kind of aldehyde, which have this thing present there. Right? Okay? Yes, everybody? Or secondary alcohol. Right? Okay? Perfect. So now, what is the color of compound? That is yellow color compound. Yes, very nice. Okay. This is CH3CO group is formed here on reaction of this is yellow color group. Okay. This is, they're talking about CHI3. Okay. CHI3 yellow precipitates. Yellow precipitates is formed here. Okay. Perfect. Yes. Very nice. Ketone undergo number of reactions due to acidic nature of dash hydrogen. They go into, this is undergo number of reactions due to acidic nature of which hydrogen, which is the hydrogen that is very acidic in nature. Now, this is alpha hydrogen. Okay, alpha hydrogen is very acidic in nature. Right? That is the reason they show aldol condensation, Cannizzaro condensation. All these condensation are shows because of alpha hydrogen presence. Right? Because of this alpha hydrogen, they readily go. It can readily go from this place. It can leave from this place. So that is the reason. Very nice. So alpha hydrogen is the answer. Next we have aldehyde and ketone having at least one alpha hydrogen. At least one alpha hydrogen they are talking about. Undergo what kind of, they are talking about a reaction in the presence of dilute alkali. Dilute alkali. Now we have jumped to a very important segment of alcohol phenol, very important segment of aldehyde, ketones and carboxylic acid, that is aldol condensation, Cannizzaro condensation, cross aldol, cross Cannizzaro, all these reactions. Okay, very important, very important. So everybody in the chat box, aldehyde and ketones having at least one alpha hydrogen undergo reaction in the presence of dilute alkali as a catalyst to form dash or dash. Form a aldol to form dash, aldol or ketone respectively. Okay, they are talking about which place to place. Okay, aldehyde is, aldol is formed by aldehyde, okay, and ketone is formed by ketone, right? It is formed by ketone. Yes, okay, yes. We can say beta hydroxy unsaturated compound is formed. Beta hydroxy aldehyde, beta hydroxy ketones are formed here. Very nice. Very nice. Okay, what they're asking? Wait. Have I? Okay, having at least one hydrogen giving a reaction in the presence of this as like two forms. Sorry. They're talking about two form dash. Okay, so yes, this was beta hydroxy unsaturated aldehyde. Okay, beta hydroxy unsaturated ketones. Yes, very nice. Beta hydroxy aldehyde, beta hydroxy ketones. Next we have the aldol or ketone readily loses water, that is the condensation, right? to give alpha beta unsaturated carbonyl compounds. So what happens exactly here? Let us do a reaction of this, okay? Or not? Okay, we'll do that in the lecture itself. We'll do that in the lecture, okay? If you want me to do some reaction here, I'll do that. Just answer that in the chat box, okay? The aldol or ketone readily loses water to give alpha beta. This is not AB, this is alpha beta, okay? This is alpha beta unsaturated carbonyl compounds which are aldol condensation products, and the reaction is called, what is the name of this reaction? Aldol condensation, and we get alpha beta unsaturated ketone or aldehyde, okay? Perfect. Next we have now we have done that. Next, the aldol condensation is carried out between two different aldehyde or ketones is called. Now what is the condition for aldol condensation? What is the condition? The condition is alpha hydrogen should be present there, right? In both the cases. If you are doing self aldol condensation, even then alpha hydrogen. If you are doing cross aldol condensation, alpha hydrogen should be present in both the compounds, right? So this is called aldol condensation. Aldol condensation between two different is called cross aldol condensation, okay? Cross aldol condensation. Now we have this reaction, okay? We have this reaction where we have different, this is basically cross aldehyde, okay? So in this case, we do not have alpha hydrogen. No alpha hydrogen, okay? No alpha hydrogen, this is sp2. Alpha carbon should be sp3 hybridized, okay? Alpha carbon should be sp3 hybridized, and this is sp2 hybridized. And here we have the alpha hydrogen here. In this case, what is the reaction? Firstly, tell me what will be the reaction that will take place in this case. What will be the reaction here? What will be the reaction, everybody? Everybody. Wait. No. Okay. It has, wait. We are talking about this thing. Just give me a minute, bacha. Just give me a minute. Let me see this. If we are talking about this here, this is CHO, and this is, or I can draw it on the other page, right? If we draw it like this, C double bond, this is H here, right? We break this bond. If we take this alpha hydrogen here, okay, there is just one product, right? This does not have alpha hydrogen, this has alpha hydrogen. Just wait. Okay, so we will take out the alpha hydrogen from this case and double bond from this case. The product will be, so you have this, this is C, this is H, this is double bond. So here the double bond, we will just, how we solve this question. So this double bond O and this is H, right? So we'll keep this H here, and the O, we will just replace this oxygen with the oxygen here, okay? We'll replace this oxygen with this carbon, this alpha carbon, okay? So we've connected to this alpha carbon. Here we will replace one hydrogen here, right? Then this will be double bond O, and this is benzene, right? Okay, this is hydrogen here. Two hydrogen will be replaced here. Wait. Yes, this is benzene CH double bond CH, and this is okay. Understood how we formed this? Everybody? Yes, this is cross aldol, and how we form this? Now I have just one molecule that has alpha hydrogen. This does not have alpha hydrogen. So there will be a major product. If they both have alpha hydrogen, in that case, if they both have alpha hydrogen, in that case, there will be mixture of product that will be formed here. So how we do it? For example, you have this is C double bond, this is H, right? And this is C double bond O, this is CH3. Now this is the alpha carbon here, right? This is the alpha carbon here. So from the carbonyl carbon, this is the carbonyl carbon here. I have drawn this benzene ring here. This is the carbon. I have drawn it here. The carbonyl carbon double bond is intact here in this case. How we directly draw the products? Just the carbonyl carbon double bond is intact in this case. We have this oxygen here. We'll just replace this oxygen. Okay, we'll just forget about this oxygen. Okay, we'll just forget about this oxygen. So double bond is in this case. Okay, double bond is here. Now after that, what we'll do this instead of this oxygen here, place this here. Okay, just copy paste this to this side. Instead of this oxygen, what you will draw here, the alpha carbon here. The alpha carbon is here. This is the alpha carbon of this compound. The alpha carbon is here. The hydrogen is here. When I have drawn just one hydrogen in this case, what is the reason? What is the reason? Because as you can see, this is the alpha carbon, right? So the one hydrogen will be replaced from this side. Okay, one hydrogen will be replaced from this side. So after that, it will have the formation of this is carbon. Now this has C double bond over here. Then it has benzene here. Understood? It will take two hydrogens from this side. Okay, everybody. I don't know if I'm able to explain this. I'm not able to explain in that much detail. We will do that in the lecture itself. We'll do aldol condensation. We'll do cross aldol, Cannizzaro, cross Cannizzaro. So how it is basically done? We'll solve a lot of examples on this. Okay, understood? Yes. So this is the product here, and after that, yes, aldehydes which do not have a dash atom undergo What is the aldehyde which do not have dash? What is that dash? Okay, what is the condition for Cannizzaro reaction? Everybody. Okay, everybody, what is this reaction? This is Cannizzaro reaction. Okay, this is Cannizzaro reaction. So aldehyde which do not have a dash atom. What is that atom? Alpha hydrogen. Perfect. Alpha hydrogen, that are called Cannizzaro reaction. So now you have formaldehyde. Now this is, what is the name of this reaction? The both do not have alpha hydrogens. This does not have alpha hydrogen. This does not have alpha hydrogen. In this case, no scope of aldol condensation here. Cross aldol condensation not happening here. Now in this case, you have concentrated KOH. Now you know there's a hint for Cannizzaro reaction. In Cannizzaro reaction, this is not cross Cannizzaro reaction, simple Cannizzaro reaction. One will form alcohol, one will form salt of carboxylic acid. Okay, one will form alcohol, one will form salt of carboxylic acid. So one we have alcohol, one we have salt of carboxylic acid. Okay, very simple, very, very simple. Next we have this is benzaldehyde. Two molecules of benzaldehyde reacted with concentrated this. Again, two molecules, not even one has alpha hydrogen. That means there is no scope for cross aldol condensation here. Because it does not have any scope for cross aldol condensation here. What will occur here? One case we will have alcohol here, right? That is this one. Okay, in the other case you will have carboxylic salt. Okay, in the other case this is Na, so this will be the carboxylic salt here, right? Okay, this will be the carboxylic salt. Very simple Cannizzaro reaction. Now again we have this benzaldehyde reaction with HNO3 and H2SO4 at 0 to this degree Celsius, 273 to 283 Kelvin. What will be the answer to this? Everybody, what will be the answer? Yes, benzyl alcohol and sodium salt of benzoic acid or sodium benzoate. Yes, very nice. So what will the answer here? You have this benzaldehyde. Yes, everybody, benzaldehyde. Then you have HNO3, H2SO4. You have HNO3, H2SO4. What they form? What is the formation here? It's a very simple reaction. Yes. Now the question here is, will it be ortho-para directing? Will it be meta directing? Yes, very nice. But why this will be a meta directing product? Because CHO group, you know, this is the benzene ring, right? This is directly bonded to CHO group here. Now this is the carbon, this is directly bonded to oxygen. oxygen is more electronegative as compared to carbon. So it will pull out the electrons, right? It will not give the electrons. So this will be minus M effect. For minus M effect, you have ortho and para position positive. And now you have here we will have the generation of NO2 positive electrophile. So it will attack on that area which has more electron density. So more electron density will be on meta position. As compared to, there will not be a negative charge as such, but yes, there will be more electron density. That is, we consider negative charge. Okay, so this will be meta directing group here, right? This will be the meta directing group. As you can, this is ortho, meta, para, right? Okay. Next, we have a carboxyl group consists of carbonyl group attached to dash. A carboxyl consists of carbonyl attached. What is this carboxyl? Very simple question. Very simple. Very simple. What is this carboxyl group? This is hydroxyl group attached to it. This is C double bond O. This is OH, right? This is carboxyl group. Next, you have IUPAC naming system. Aliphatic carboxylic acids are named by replacing the ending E with the name of corresponding alkane with mesomeric effect is always dominating. Mesomeric effect decides the direction, whether it be ortho-para directing or meta directing. This is the mesomeric group that decides it, okay? So in the IUPAC naming system, this is oic acid, right? Okay, this is oic acid. Oxygen of OH, yes, very good. Not all. We are talking about the carboxyl group. Okay, so that is, we are talking about oic acid, carboxylic acid. For naming compounds containing more than one carboxyl group, the alkyl chain, we have more than one carboxyl group. So alkyl chain dash carboxyl group is numbered, and the number of carboxyl group is indicated by adding the multiplicative prefix dicarboxylic, tricarboxylic to the name of parent alkyl chain. The alkyl chain dash is the numbered and the number of carbon. The naming compounds, they're asking for naming compounds containing more than one carboxyl. The alkyl chain dash carboxyl group is numbered, and the number of carboxyl group is indicated by adding. I don't get the question here. Okay. The alkyl group leaving carboxyl group is numbered. Okay. So, yeah, the question is little unclear. So, yeah, the question is unclear. So, yes, very simple. This is just about, they are talking about IUPAC naming, a very general question. So now, next we have the IUPAC naming of CH, COH, CH2, CH, COH, CH2, COH is, what is the IUPAC name? What is the common name of this? Okay, what is the IUPAC name of this? Everybody? Yes. So, everybody here, the IUPAC name of COH, CH2, CH, this is COH, CH2, COH. What is the IUPAC name here? Everybody in the chat box. Yes. Ma'am, Theory, I didn't get you. Devendra, can you please ask that in English? Can you please ask that in English? So, this is propane 1,2,3 tricarboxylic acid. So, why this is named as this? Okay, this is CH2, this is CH, this is CH2. Now, this is COH. We have already done this in case of aldehydes, right? In case of aldehyde, we named it as, this is 1, 2, 3, right? If there is aldehyde, we name it as propane 1,2,3 tricarbaldehyde. Here also we will not write carboxylic acid. To maintain the symmetry, we will write carboxylic acid. So this will be propane 1,2,3 tricarboxylic acid. Okay, you can write it down, right? Tricarboxylic acid, yes. So next is one IUPAC naming of this. Now this is attached to directly ring. Now they are directly attached to ring. So if you have symmetry, if you have ring, even in both the cases, we have carboxylic acid written there. Okay, we have carboxylic acid written there. Okay, perfect. So what will be the name? The name will not be oic acid. This will be carboxylic acid. Okay, So you can write it down 1, 2, 3, 4, 5. You can write 1, 2. You can write it as benzene. Either you can write it in the form of benzoic acid, or you can write it in the form of carboxylic acid. Okay, this is benzene 1, 2, benzene 1, and this is 2 dicarboxylic acid. Right? Okay. 1, 2. Yeah, this is also right. 1, 2 benzene dicarboxylic acid. Yes, perfect. So now the carboxyl group is dash electrophilic, then carbon atom. So now they are saying carboxylic carbon. You have this carboxylic carbon, right? Okay. And this is the carbonyl group. Let us take the example of ketone. So now, as you all know, here we have also one more oxygen that is present directly with this carbon. Okay, this is partially negative, this is partially positive. So here we are providing the plus side from just one side. Here we are also taking the electrons from two oxygen atoms, by two oxygen atoms. Right, so that means this is more electrophilic than carbonyl carbon. Right, it will be more electron deficient. Okay, more electron deficient, that means it will be more wait, carboxylic carbon is dash electrophilic than this carbonyl carbon. No, the nucleophilicity will be more, the electrophilicity will be no. Okay, ma'am, please tell my alpha. I don't get you, Devendra. I don't get you what you are talking about. Okay, so the carboxyl carbon is dash electrophilic than carbonyl carbon. I have doubt on this question. Either there is this misplacement of this word. Okay, so I have doubt on this question. We can just ignore it now. Yes, in the carboxylic acid, the bonds of carboxylic carbon lie in one plane and are separated by about. We have done this also, right? The bonds of carboxyl carbon lie in one plane and other are out of the plane, right? They are at 120 degrees Celsius, that is one plane, and are separated by, okay. So they are talking about this thing, the trigonal geometry they are talking about. Then you have this thing, this is OH, this is R. So the geometry here is sp2, so this is trigonal planar. And in trigonal planar you have 120 degree of angle, right? Okay. The Jones reagent, so in acidic media, is it a weak? Firstly tell me, Jones reagent is weak or strong? Jones reagent is weak oxidizing agent or strong oxidizing agent, right? Okay. Wait. Somebody is answering this, okay? Yeah, okay. Who is this? Yeah, Padma. Yeah, Padma has answered this, right? I just missed this concept, okay? This is RCO and this is OH. Now, because of the resonance factor here, we have O negative. Now, in this case, we'll have resonance here. Okay, we'll have equivalent structures here, and that is the reason, because of the resonance here, it is less electrophilic. Because of the resonance, the electrons are actually revolving. Yes. So the electrons are actually present in all these cases. Here we have, just in case of carbonyl carbon, we have just inductive effect, right? We just have inductive effect of either aldehyde, or we are talking about ketones. We have just inductive effect, but in this case we have resonating effect also, right? We have resonating structures as well, that to equivalent resonating structures, and that is the reason it is less electrophilic. Yes, right. Very good. So next we have, this is 120 degree. Now tell me, Jones reagent, dash in acidic medium. Is dash in acidic medium? Padma deserves a Padma. Very nice. So Jones reagent says Cr2 in acidic. Now tell me, in acidic, if it's a strong acidic, if it is strong acid, then it is acting as a strong oxidizing agent, right? If they have given you H2SO4, CrO3 plus H2SO4, then that will be strong oxidizing agent, okay? But what if they have given a weak oxidizing agent? What if they have given a weak acid or simply an acetone here, right? So in that case, if you have CrO3 plus acetone, in that case it is a weak oxidizing agent, right? And if you are given nothing, just Jones reagent, that case you will just assume that they are talking about strong oxidizing agents, okay? Next we have CH3, CH2, this CH2OH. Now this is Jones reagent they are talking about. They are given H2SO4, strong oxidizing agent. So it will directly get converted to, yes, it will get directly converted to COH, right? Okay, their steps have been reduced in this case. For example, you have alcohol, after that you have aldehyde or ketone, and after that you have COH, right? So if it is a strong oxidizing agent, it will directly get converted to COH, okay? Now next we have primary alcohols are oxidized to carboxylic acid with dash. Okay, they are with dash potassium permanganate in neutral or acidic or alkaline medium by potassium dichromate. This in acidic media. Okay, what are these? It's a common dash. What are these common? What are they talking about? What is this KMNO4? What is this K2Cr2O7? What is this CrO3 in acidic medium? These all are strong oxidizing agents, right? Okay. So these are all strong oxidizing agents. So we should specially write it as strong oxidizing agents, okay? Next we have aromatic carboxylic acid can be prepared by vigorous oxidation of alkyl benzene with dash or dash. Everybody in the chat box. Now the aromatic carboxylic acid can be prepared by vigorous oxidation. Vigorous oxidation of alkyl benzene. The whole alkyl chain is oxidized in this case. With dash or dash, the entire side chain oxidizes to carboxyl irrespective of the length of the side chain. Yes, the entire oxidizing. What are these? What is this? What are the reagents in this case? Everybody, what are the reagents? What are the reagents? Everybody, the whole alkyl chain. For example, you have CH3, you have N, right? This whole will be getting converted into COH, right? Yes. You have strong oxidizing agent. What are these strong oxidizing agent? Chromic acid, acidic or alkaline potassium permanganate, right? They give the vigorous reaction on the alkyl chain, right? That is attached to benzene, right? Okay, perfect. All the answers are correct. Nitriles are hydrolyzed to amides, okay? To amides and then to acids. Yes. 3 steps in the presence of H positive or OH as catalyst. Mild reaction conditions are used to stop the reaction at what stage? So nitriles are getting converted into amines here. Yes, yours were right. Yeah, right. Yours right also. Mild oxidizing agent, I'm saying. Nitriles are hydrolyzed to amides. Okay. You have C triple bond N, that is converted to CO, NH2. At which stage? Catalyst mild oxidization are used to stop the reaction at carboxylic state, amide state. So this is what is the formula? What is the formula of amide? You all know, right? Okay, that you all know, yeah. Okay, Grignard reagent react with dash to form salts of carboxylic acid, which in turn give corresponding carboxy after acidification with mineral acid. Now again, very simple reaction. Reactions of Grignard reagents are very important, right? So react with dash to form salts of carboxylic acid. CONH2, yes, very nice. So Grignard reagent react with what to form salts of carboxylic acid, which in turn give corresponding carboxylic acid. How does it give corresponding? After acidification with mineral acid. Everybody in the chat box. It reacts with Very nice, very nice, very nice. It reacts with CO2. Yes, very good, very good. So next we have acid chlorides and anhydrides when hydrolyzed with water. It gives, okay, with water there will be a reaction H positive, OH negative, replacement of that, compounds to other than this, Grignard reagent 2. Very good organometallic compounds, yes, very nice. Dry ice, yes, solid carbon dioxide. Acid chlorides or anhydrides when hydrolyzed with water. For example, you have COOH, right? When this is hydrolyzed with water, what does it form? What does it form? To give? Yes, very good, very good, very good. Acid chloride I should write here, right? So it will give acids. Very good. It will give carboxylic acids. Yes, very good. What will happen here? This is a positive part, the H positive, OH negative, and this will break down. This is negative, this is positive. This will go here, this will be attacked here. So we'll have the formation of carboxylic acid. Next, acidic hydrolysis of esters give directly carboxylic acids, right? While basic hydrolysis, acidic hydrolysis give acids, directly give acids, but basic, they are talking about esterification reaction here. Acid condition, basic condition. Acidic conditions, they give simply carboxylic acid. For basic condition, they give sodium salt of carboxylic acid, okay, that is carboxylates, okay. After that acidification, then we will have carboxylic acid here, right? Okay, perfect. Next we have carboxylic acid have dash boiling point than aldehyde ketones. So what is the boiling point? The boiling point is higher, right? Because it has a hydrogen bonding. This form dimer. Because of formation of dimer, the boiling point is higher in this case, right? Okay. Aliphatic carboxylic acid having up to 4 carbon atoms are miscible in water due to the formation of dash with water. Why they are always miscible? If the alkyl part is very low, if the alkyl part is having less number of carbons, in that case it will have good hydrogen bonding, right? Okay, because of hydrogen bonds. Next you have higher carboxylic acid are practically insoluble in water. Higher are insoluble. What is the reason behind that? Because of higher alkyl chain, higher surface area of alkyl chain, right? Due to the increased dash interaction of hydrocarbon part. Because of the hydrophobic part, there will be dipole-dipole interactions, right? Yes, very good. The high carboxylates are practically insoluble due to increased dash interactions, increased hydrophobic interactions. So this is the hydrophobic part, right? This is the hydrophobic part because it is getting increased, so dipole-dipole interaction between this hydrophobic part will increase, right? Next you have carboxylic acid with NaH. This is a very old reaction. You used to do it in lower classes. Very simple reaction. Anything with metal carbonates or metal bicarbonates, any acid, it gives off carbon dioxide, water, and it gives off salt of that carboxylic acid, right? Okay, so it will give, yes, because of steric hindrance. Very good. As alkyl part will increase, there will be difficulty in forming hydrogen bonds, right? So this is salt of carboxylic acid, right? Next we have carboxylic acid are dash then mineral acids, but they are dash acids, then alcohols and many simple phenols. They are organic acids are weak than mineral acids, right? But they are stronger in comparison of alcohol or phenols, right? They have resonating structures, equivalent resonating structure, and that is the reason they are even more acidic than phenol having 5 resonating structures, okay? Because it has equivalent resonating structures, right? Okay, so answer is weaker and stronger acids, right? Electron withdrawing group dash the acidity of carboxylic acid by stabilizing the conjugate base through delocalization of negative charge by inductive or a resonance effect. Now what is the answer to this? Everybody in the chat box, electron withdrawing groups. If you have electron withdrawing groups, okay. Now, by stabilization the conjugate base through delocalization of negative charge, dash the acidity. So now you have this is COH, and you have any electron withdrawing group. If you have electron withdrawing group present here, it will take out the electron. Now this is already negative, right? You are taking out the electron, you are making it more acidic, right? So it will increase the acidity. This is simply from GOC, and GOC covers a lot of part, right? Okay. Direct attachment of groups such as phenyl or vinyl to the carboxylic acid, right? Dash the acidity of carbonyl carboxylic acid. Direct attachment of phenylic group and vinylic group. This will increase the resonance in that case, right? It will increase the resonance. Because of resonance, the acid will be more stable. So it increases the acidity, right? Whether it's a phenylic group, whether it's a phenylic or it's a phenylic group, okay, vinylic or phenylic. For example, this double bond, you have this C, this is O, this is OH. So now you will see double bond, single bond, double bond. Good resonance. The resonance is also present here, right? So that is the reason. Or you say this is COOH, right? In this case also you increase the resonance here, and that is the reason for increasing the acidity. Carboxylic acid on heating with mineral acids such as this and this with P2O5 give corresponding. So after heating with this, what are these? What are these? If heating with such as H2SO4 or with P2O5 give corresponding, right? What does it give? Everybody in the chat box. It gives anhydride. What is this anhydride? This is nothing. For example, this is R part, right? This is COH. Now you will have the formation of anhydride from here. You'll have the anhydride is this. C double bond O, this is O, this is double bond O, this is R. Okay, this is the anhydride. Right? Okay. RCOH and R, this is esterification reaction. So the answer will be RCO R dash. Okay. Esterification reaction. Understood? This is RCOH in presence of PCl5. This is same as a halogen, same as alcohol, phenol halogens. You have done this, right? The OH part will be replaced by Cl. Very simple, okay? Just replace this OH part with Cl. This is ROCl. Everything else is same here. Everything else is same here, okay? So you will have the formation of acyl chloride. Then you have acid with a PCl3. Again, you will have the formation of RCOCl, acyl halide, right? The reactions are just same. Like you used to do that. This is ROH. In this case, similarly, you had the formation of RCl. In this case, you have RCOOH and you have the formation of acyl halide. Okay. So, just replace the OH with the halogen. Next, you have, this is SOCl2 again. This is RORCOCl, acyl halide. Right? Carboxylic acid react with ammonia to give ammonium salt, which on further heating give high temperature. On reaction with ammonia to give ammonium salt, right? Which on further heating at high temperature. Firstly, you have ammonium salt. After that, on further heating, what you will get here? Everybody, yes. What you will get here? RCOCl, though it was like before. Yes. RCOCl, perfect, perfect, perfect. So after that, now let's jump to this question, okay? Just 10 questions left now. We have just 10 questions left. Yes, it will have the formation of amides. Very good. It will have the formation of amides. Perfect, perfect. So now you have this acid. So now with ammonia the same question, okay? With ammonia the same question here. Now this is a very important reaction. Okay, very important naming reaction. What is this? What is the name of this compound? What is the name of this compound? What is the name of this compound? Yes, everybody in the chat box, what is the name of this compound? After that, you have ammonium phthalate, right? Everybody, my chat is like, okay, is there any lag here? Because yes, I am not able to, see your answers on time. Yes. Phthalimide, this is phthalic acid. Okay, this is phthalic acid. With ammonia, it gives ammonium phthalate. After that, you have phthalimide. And after the reaction on strong heating, what it will form? What is going to form? After the reaction of phthalimide on strong heating, it is going to replace this here, right? So, you'll have the formation of This is not phthalimide here. You will have the formation of this thing. Okay, how do I write this? So what will happen here? You will have this is NH2. This H will go from this side, and you will have the formation of this is okay. This C double bond O, C double bond O. Now this is NH2. This is NH2. So from this side NH2 and this H will go, and you will have the formation of NH here. And after that you will have Gabriel phthalimide reaction. Okay. Yes. Gabriel phthalimide reaction, and that is for the formation of 1 degree amines. Right. So if you just further react this compound, that is called Gabriel phthalimide reaction. Okay. Yes. Sodium borohydride dash reduces the carboxyl group. Sodium borohydride. You have sodium borohydride dash reduces the carboxyl group. It will have the formation of, in Gabriel phthalimide reaction, will have the formation of just primary amines. Okay. The mechanism is also important. For Gabriel phthalimide reaction, the mechanism is also important. Okay. Yes? Okay. So you'll have, it does not reduces the carboxyl group, right? RCOH with the reducing agent or B2O this after hydrolysis. What will have the formation? Just few reactions of carboxyl group. Just few reactions, and some of them are very important. Right? Okay? We'll do Gabriel phthalimide reaction in amines. Yes, it does not. RCOH with LiAlH4 and ether or B2H6 after hydrolysis, it will have the formation of. Okay? Yeah, this was a little confusing question, so you can just ignore this. Not even confusing, this is basically not a very clear question, but these are clear questions. Yes, it will have the formation of, very good, it will have the formation of alcohol, right? On the same number of carbons. Now the trick here is the same number of carbons here. The same number of this, the carbon here present, the carbon will be present in the alcohol also. Carboxyl acid lose dash to form hydrocarbons when the sodium salts are heated with sodium in the ratio of. Now they are talking about decarboxylation, right? We have done in this in hydrocarbons. So this is carbon dioxide in the ratio 3:1. The ratio here is 3:1. Lose carbon dioxide. This reaction is called soda-lime decarboxylation. Okay, this reaction is called soda-lime decarboxylation. It will have the formation of alkanes. Like for example, from this you will have the formation of RH, not RR. Okay, the alkyl part. The alkyl part will be the hydrocarbon here. So alkali metal salts of carboxylic acid undergo decarboxylation on electrolysis of their aqueous solution. They are talking about which reaction? Which reaction? Alkali metal salts of carboxylic acids. They undergo electrolysis decarboxylation. What is the name of this reaction, everybody? To form hydrocarbons having dash number of carbon atoms. How many number of hydrocarbons are there? What is the formation? What is the name of this reaction? What is the name of this reaction? Everybody? Yes, this is Cole's electrolysis, and it has, for example, you have RCONA, you will have the formation of RR here. Right? Okay? Perfect? Yes. Now tell me just one thing just tell me also one thing. At anode, what is formed? At cathode, what is formed? And what is the medium? At anode, what is formed? At anode, what are the compounds that are formed at anode? Yes, twice the number of alkyl group. Twice the number of alkyl group. Very good. What are the compounds that are formed on anode? What are the compounds that are formed on cathode? Right, everybody? On anode, you have the formation of hydrocarbon and carbon dioxide. On cathode, you have the formation of hydrogen gas. Right? Okay, and what is the medium? The medium is acidic. The medium is basic. Alkane, cathode. On cathode you have NaOH, and you can just not clearly say that on cathode it has NaOH. You can say the medium is basic. Yeah. Okay, CO2 and alkane on anode, and cathode we have H2. Okay, yes. The medium here is basic, yes. In the Helmholtz-Zelinsky reaction, the carboxylic acid, okay, the HVZ reaction, again a very important reaction. There are so many naming reactions in this chapter. Are hydrogenated at dash position by using dash and dash. The HVZ reaction, the carboxylic acids are hydrogenated, okay, at dash position by using dash or dash. What is HVZ reaction, everybody? Everybody, the medium is basic, right? At alpha position using what? Using red phosphorus or halogen, right? Okay, this HVZ reaction. Alpha position is substituted in this case, right? Alpha position is substituted in this case. Okay, perfect. So after that we have this compound with, again, very simple nitrating mixture. But now the questions for this will be very interesting. For nitration of this, for nitration of anilines are also very interesting. Okay, this is easy, but the anilines are like difficult part, because it is giving different type of reactions. So in this case, concentrated HNO3, this is a nitrating mixture, NO2 positive. Again, the same reaction that we did for aldehydes. This is a meta-directing product, okay? Meta-directing product will be present here. In this case, you will have Br positive, a meta-directing product will be formed here, right? Okay? Then we have this. Dash carboxylic acid do not undergo Friedel-Crafts reaction because of carboxylic acid is deactivating. I think it is very important question. Very important question. Okay? Now everybody in the chat box, dash carboxylic acid do not undergo Friedel-Crafts reaction because the carboxylic group is deactivating and the catalyst aluminium chloride Lewis acid gets bonded to the carboxyl group. Now Lewis acid is electron deficient. It needs electrons, right? It needs electrons, and that is the reason if we have, for example, if we have this thing, okay? Now what will happen here? Instead this Lewis acids, for example, you have AlCl3 or you have FeCl3, okay? Now this is a Lewis acid. This is electron deficient. It will get attracted to anything that has electrons. So that is why it get attracted here. And does not get Friedel-Crafts alkylation, Friedel-Crafts acylation. It got bonded to this carbon here, okay? Okay everyone? Understood? Yes. Understood this, no? Why carboxylic acid, this aromatic carboxylic acid do not give this, okay? They do not give Friedel-Crafts alkylation or acylation, right? Because they have minus M effect, right? They will have the electron density over here. So the electron density is more on this position as compared to this. And that is the reason the Lewis acid, that is FeCl3, that is FeCl3, it gets attracted on this COH group instead of this benzene ring, right? So important question that was. So you have RCH2, now this is HVZ reaction, Helmholtz-Zelinsky reaction. So now here we have the substitution at alpha position. At alpha position, this is the alpha position, right? Here we'll have the substitution at the alpha position. Okay guys, here we have the substitution at the alpha position. So guys, tomorrow we are going to do amines. Tomorrow we are going to do amines and biomolecules. And biomolecules, we are going to complete these two chapters, okay? We are going to complete these two chapters, NCERT line by line. That will be a very good revision session for you all. So everybody do join that, okay? Yes? Perfect, 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 perfect. So did you enjoy the session? Everybody in the chat box? Did you enjoy the session? Let's have a chit chat session now. Let's talk about something now. Yes, okay everybody? Yes. Keith, Sanvi, Padma, Samaria. Very good. Who all are present here? Everybody in the chat box, write down your names. Yes, yes. Rani. Very good. Padma. Keith. Sure, ma'am? Perfect, perfect. Okay, guys. So, thank you, thank you. Yes. So now we will complete. We have done questions for inorganic chemistry already done. We will be done with organic chemistry by tomorrow, and after that in one day we will complete questions from physical chemistry. Okay, all the conceptual questions that are asked, as you all know, inorganic chemistry, so many questions are asked from inorganic chemistry directly from lines. Organic chemistry, less questions from directly NCERT. Okay, you will have to do NCERT questions and everything, but still we have tried our best to complete every single line. Okay, everything in this series. Now from physical chemistry, it's not like they will ask more numericals from that, more numericals from your NCERT, but they are asking conceptual questions also. So I'll take physical chemistry class one day, and we'll finish off electrochemistry, solutions and chemical kinetics, all these three things. Okay, everybody? Yes, surely I'll see that. GOC little difficult. I would advise you to see my lectures on GOC. We have completed GOC, okay? And we will increase the frequency of chemistry classes because I really want to complete your syllabus. And don't worry, in one chapter, one day we'll do that, okay? Whether I have to take the class for 6 hours, 7 hours, I'll be there for you, okay? I just need you guys to be there. Ma'am, chemical bonding chapter, yes, okay, definitely. After organic chemistry, I promise you I'll pick chemical bonding and coordination compounds firstly. Okay, before physical chemistry, we'll start off with chemical bonding and coordination chemistry. Okay, done? Yes, I know these chapters you find little difficult, so don't worry. Don't worry, it will be a very short, crisp session. Okay, crisp session of physical chemistry. Yes, one day physical chemistry. Okay guys, then bye bye, take care guys, see you all, and just keep learning, keep up the, just stay motivated with the, I know there will be times you will feel that okay, we are not good enough and all these things. This happens with everybody, but always remember that what you're doing this for your future, you're doing this for yourself, right? And when you have big dreams, you have to work hard. And by seeing that you are here for 5 to 10, I can clearly see 5 hours. So I can clearly see my future doctors here. Right? Yes. Okay, I'll surely do that. Redox reactions, okay, electrochemistry, separate lecture. Okay, done. I'll take separate lecture for everything. Don't worry. Okay then, bye-bye, take care, all the very best bachcho, keep learning and stay healthy, eat good food, and take care of your mental health as well. Please take care of your mental health. Don't be depressed. There's so many messages that that are coming on Instagram as well, that okay ma'am, we are feeling very demotivated. I know the exam is near, there will be time you will feel demotivated, but please take care of your mental health. We are here for you. If you feel anything, like just write it down in the comment section that okay ma'am, this is what we feel as exam is coming near. We'll definitely read out your comment and support you. Okay guys? Okay, bye-bye, take care, have a sound sleep, see you all tomorrow, bye-bye.